Christodoulou, Minister of Agriculture, Rural Development and Environment, Professor Vasiliki Kasianidou, Deputy Minister of Culture, members of the Parliament, ambassadors, leaders of political parties, chief scientists, commissioner, President and members of the Cyprus Academy of Sciences, Letters and Arts, President, President Emeritus, Chair and trustees of the board of the Cyprus Institute. Good morning, ladies and gentlemen. Good morning and welcome to the International Conference, Climate Crisis in the Eastern Mediterranean and Middle East, co-organized by the Cyprus Academy of Sciences, Letters and Arts and the Cyprus Institute. Unfortunately, our conference is happening at a terrible time in the midst of intensifying warfare in our region. Even so, we are very pleased to report that the conference is very well attended, exceeding our expectations. We have prominent academic and policy leaders from at least 22 countries, most of them speakers and panelists. That is you, the recipients of this message right now. This is an excellent omen for a very high level and very productive meeting. Before we begin, I would like to kindly ask that you ensure that your mobile phones are switched to silent mode for the smooth running of the event without further interruptions. It is now my pleasure to welcome Professor Kostas Papanikolas, Chair of the International Organizing Committee, an Institute Professor and President Emeritus of the Cyprus Institute, a member of the Cyprus Academy of Sciences, Letters and Arts. Professor Papanikolas.
The need for action is unprecedented, but so is the opportunity, not just to deliver on climate, but on economic prosperity and sustainable development. Climate action cannot be captive to geopolitical divisions. This is what Antonio Guterres said in June 5th, the World Environment Day this year. It couldn't be more fitting to this time, to this audience. Excellencies, colleagues, ladies and gentlemen, good morning. Welcome to the International Conference, Climate Crisis in the Eastern Mediterranean and the Middle East, which is co-organized by the Cyprus Academy of Sciences, Letters and Arts, and the Cyprus Institute. The Eastern Mediterranean Middle East region is a climate hotspot. Recent data confirm modeling predictions that catastrophic impacts are manifesting in this region in a most intense manner. If we do not abandon our business as usual approach, if we do not act immediately and in a concerted effort, then the impacts on the nearly 500 million inhabitants of this region are forecasted to be nothing short of devastating. There is time to act. There are solutions, and the impacts of this pending catastrophe, if we don't do anything, will reverberate globally. For the next 2.5 days, the evolving climate situation will be evaluated and projections will be presented. Mitigation and adaptation strategies will be discussed among leading scientists and leading policymakers. We hope that collaborations will emerge and plans and actions will emerge, especially those of a transboundary, transnational nature, which are badly needed. Unfortunately, as already mentioned, this conference is happening at a terrible time, in the midst of intensifying warfare, the worst that our region has witnessed in decades. The intensification of hostilities in recent days has impacted participation to this conference. A number of key speakers and participants had to cancel, not because of their choice, because it was impossible, for example, to fly out of Beirut. We had a number of cancellations yesterday. During the last days also, their trip to Cyprus. Some will be able to connect via internet, even though it was stated that this is not a hybrid conference, but we consider this a force majeure and will allow them to participate remotely. In addition, the UN General Assembly meetings this week, and especially the Summit of the Future, which has a lot to do with the future of the planet, is happening this week in New York City and has also impacted participation here, for good reason in this case. A few keynote speakers are participating in the meetings, including the President of the Republic, who will not be able to join us here. He has far more important business to do at the UN. They express, nevertheless, and they asked me to relay their deep regret that they are not able to join us. Some will have sent us pre-recorded messages. Some, even at their huge inconvenience, given the time difference, will try to connect live via internet. Even so, we are very pleased to report, as already mentioned, that the conference, even though we had set an original limit because of room, etc., at 150 participants, we had to admit 250, and we had to reject a number of applications that came late. So this is an excellent omen in this climate, in this situation, that you are here for this tremendous cause, and thank you very much.
Thank you, Professor Papanikolaou. I now call Professor Achilles Amelianidis, President of the Cyprus Academy of Sciences, Letters and Arts, and Professor and Dean of the School of Law of the University of Nicosia, Cyprus.
Honorable guests, let me also welcome you cordially in Cyprus for this very topical and important conference. The Cyprus Academy of Sciences, Letters and Arts is the National Academy of Cyprus, and one of its principal objectives is to help in the dissemination of knowledge on issues of extreme importance. Clearly, climate change is an issue that concerns all of us, because if we do not have a planet to live in, then all other discussions are meaningless. This conference undeniably deals with issues that are of pressing importance. As my colleague, Professor Papanikolaou, just mentioned, we need solutions now. We don't have any more time. And although the topic is regional, it refers to Eastern Mediterranean and the Middle East. Clearly, those regions are hotspots, so the importance of this conference is not only regional, it is by logical necessity global. We are facing a climate emergency which necessitates our immediate action. We are proud to have you here with us, some of the preeminent experts and policymakers in the field, in order to collectively consider how we can best respond to the crisis we are facing. I would like to thank, on behalf of the Cyprus Academy, the Cyprus Institute, Professor Stavros Malas and his colleagues. We have had a very sincere and productive collaboration for the organization of this conference from the beginning, and indeed we could not have had such a successful conference without the Cyprus Institute. This is one of the many initiatives that the Academy is currently undertaking regarding climate change, but I think it is one of the most important due to the presence in Cyprus of so many of you. I should note that the Academy comprises of 3 classes. It is a comprehensive academy. It comprises of the natural sciences, the humanities, and the social sciences. And we are happy to note that this conference does not restrict itself in a single topic like technical issues or issues relating to the natural sciences, but it engages also to issues of social sciences like finance and law, and to societal ethical implications. And I think that this comprehensive dealing with the issue will assist us in reaching results that can be both practical and immediate in their implementation. We need key stakeholders to embrace realistic policy solutions so that we can convince world governments to implement them. I would like to particularly thank Professor Papanikolaou, who has led these initiatives, and Maria Papapoliviou and all members of the Cyprus Academy. There are many, so I will not mention them all by name, who are participating and have led the organization of this conference. And I think that this will be proved to be a very fruitful collaboration. I'm certain that our proceedings will not stop at the end of this conference, but will continue after our concluding thoughts are given. We will continue the efforts by using this network and other networks in order to promote this solution and take further collective action for the benefit of the entire region. I thank you and welcome you to Cyprus once again, and look forward to the further fruitful productions and meetings of this conference.
Thank you, Professor Emilianidis. Now, I would like to call Professor Stavros Malas, President of the Cyprus Institute.
Good morning, everybody, ministers, excellencies, distinguished guests, welcome, colleagues. Allow me first to welcome, in particular, to this conference, scientists and policymakers and NGOs from the region who, despite the difficulties they're facing internally and both regionally, have made it. And I'd like to assure you, colleagues, that the Cyprus Institute, Cyprus in particular, will always welcome you to set the stage and facilitate this dialogue between you for the cause of peace. It is a great honor for me to welcome you, of course, on behalf of the Cyprus Institute and the Academy to this event. Now, there is an intrinsic message here. Scientists in Cyprus and the region are sending a message to politicians, to governments, that we're dealing not with a problem, but with a crisis. And it is probably the most worrying crisis the globe, human beings are actually going to be faced with. And it is actually of their own making. Now, the Eastern Mediterranean is, without question, this region, a hotspot of this crisis, and the repercussions will reverberate surely beyond the region. So we like to discuss and send clear messages. Now, at this point, I want to say that this effort, on behalf of the Cyprus Institute, was instigated 4 years ago by the visionary approach taken by the time by my predecessor, Professor Papanegolas, who led an effort known as the Climate Change Initiative, certainly supported by the government of the Republic of Cyprus at the time, which culminated in a scientific report and the regional action plan, which was presented in COP27. And of course, that visionary approach essentially is continuing with the launching of this event, and I'll make some announcements now. So over the past few decades, of course, we have witnessed this environmental transformation, increasing temperatures, more frequent and intense heat waves, reduced precipitation, all of which have had devastating effects on ecosystem economies and the well-being of communities. As I said, the science is clear. The crisis is here, and if we do not act now, the consequence of climate change in our region and, of course, the world will be very severe. Now, scientists are sending two messages with two key words: adaptation, learn to live with the crisis, and mitigation, trying to mitigate the problem of not getting worse. These are two different meanings, and adaptation will be with us for hundreds of years, even if tomorrow morning we completely stop CO2 emissions. So the problem will be with us for many years, and therefore the adaptation will be with us for many, many generations. So the risk of food and water security, public health, economic stability, and regional cooperation are obviously monumental. But alongside these challenges, there are opportunities. This conference is a platform to address these collectively, to share knowledge, build on science, and of course to strengthen our collaboration in finding sustainable solutions for a future in a region that collaboration is difficult in its own right. Therefore, this conference is not just a space for discussion, but for action. We need to accelerate our efforts in developing climate mitigation strategies, increasing adoption of renewable energy, and enhancing sustainable practice in all sectors. Furthermore, it is essential that we prioritize adaptation strategies, particularly for the most vulnerable populations in our region. Our efforts today will help ensure that future generations, many future generations, will inherit a world that is more just, equitable, and livable. At the Cyprus Institute, we are dedicated to advancing scientific research and fostering innovative solutions to address the climate crisis. I call this translational research. We actually translate our research into policies, conveying to the politicians and to the public. And we remain committed to being at the forefront of research and action on climate change in particular, and will continue to work with our regional and global partners, providing insights into specific solutions. Our research initiatives, as I said, for the region has actually placed the Cyprus Institute in the center of this effort in the region, and we will continue to do so. Now, in closing, I'd like to express, as I said, my sincere gratitude to my predecessor, but also to the government of the Republic for the trust placed on the Cyprus Institute by reappointing us, and we had formal communication with that, to lead the continuation of the climate crisis initiative in this region. This significant responsibility underscores the importance of our ongoing research and collaborations aimed at addressing the crisis in the region. We are committed to fostering these strategic partnerships that will safeguard our environment, will promote sustainability and build resilience and climate change resilience in particular. Now, I can also announce today that a key pillar to this initiative, this new initiative, will be to lead, as Cyprus Institute, mandated by the Republic, the forging of a regional alliance for climate, regional scientific alliance for climate change in this region, and use this partnership not only to fertilize the political process in the region, which of course is very difficult in developing a regional action plan, but also to harness the opportunity of the membership of the European Union, Cyprus being a member of the European Union, the only member in the region, and holding the presidency in 2026 to actually fertilize the new research program of the EU in actually developing key funding tools for enhancing research for the region, because the crisis in the region will actually affect Europe as well. Therefore, colleagues, ladies and gentlemen, let us use this opportunity to forge stronger alliances, share innovative solutions, and move forward with a renewed sense of urgency. Together, at least in science we're very collaborative. We can make the difference for the region and, of course, for the entire world. And I welcome you to this conference. Thank you.
Thank you, Professor Malas. I now call Her Excellency Dr. Maria Panagiotou, Minister of Agriculture, Rural Development and Environment.
Honorable guests, distinguished colleagues, ladies and gentlemen, it is a great privilege to stand before you today as we gather to address one of the most critical challenges facing not only our region, but the entire world, climate change. In the Eastern Mediterranean and Middle East region, we are directly impacted from climate crisis. Rising temperatures, erratic rainfall patterns, prolonged drought, and a strain on natural resources are no longer distant threats. They are realities that demand our immediate and coordinated response. As the Minister of Agriculture, Rural Development and Environment of Cyprus, I want to share with you our nation's strategic response to the climate change. Our efforts are targeted on two essential and interconnected pillars: climate mitigation and climate adaptation. Let me begin by emphasizing our efforts on mitigation. Cyprus is fully committed to achieving its decarbonization goals as outlined in our National Energy and Climate Plan 2021-2030. This comprehensive plan provides a clear roadmap, setting ambitious targets to reduce greenhouse gas emissions, enhance energy efficiency, and significantly increase the share of renewable energy in our economy. Our vision is to transition to a carbon-neutral society with cleaner energy sources and more sustainable practices at every level. The National Energy and Climate Plan is a transformative project that impacts on every sector: energy, transport, agriculture, waste management, and urban planning and land use. One of its central aims is to reduce Cyprus' reliance on fossil fuels by expanding the use of solar and wind energy. We are making significant progress in promoting solar photovoltaic systems, which are particularly well suited to our sunny climate. Moreover, we are encouraging the use of energy-efficient technologies in building and transportation systems to lower emissions. The transition to a circular economy is another critical component of our National Energy and Climate Plan, focusing on minimizing waste and maximizing the circular economy. This includes waste reduction strategies in agriculture, where the treatment of animal waste is being adopted to reduce methane emissions, a potent greenhouse gas. We are also working in improving recycling and infrastructures and reduce the amount of waste that ends up in landfills. I would be remiss not to acknowledge the challenges we face on this path. Transitioning to a carbon-neutral society requires substantial investments, technological innovation, and public commitment in embracing new practices. The scale of this transformation is unprecedented, and while we are fully committed in meeting our targets, we must also recognize that this journey will have its difficulties. However, as we move forward, I remain confident in Cyprus' ability to adapt and innovate. We have made important strides in promoting renewable energy, but the full infrastructure necessary for a complete transition is under development. The modernization of our energy grid and transportation systems will require not only significant financial resources, but also cooperation at both political and public-private levels to propel these efforts forward. Yes, challenges lie ahead, but the commitment of our government, alongside with the readiness of the private sector and the will of the Cypriot people, remains steady. We will push forward, determined to come as close as possible to the goals we have set, because progress is not measured by perfection, but by the relentless pursuit of a better, more sustainable future for all. While mitigation is crucial for reducing the long-term risk of climate change, we must also focus on adapting to the immediate impacts that are already upon us. Cyprus is no stranger to water scarcity, extreme heat, and land degradation, and these challenges are only expected to intensify as climate change progresses. This is where our National Adaptation Strategy comes into play. The National Adaptation Strategy, which is currently undergoing a comprehensive revision, is designed to address Cyprus' unique vulnerabilities. It focuses on building resilience across critical sectors, including water management, agriculture, biodiversity, land use, and infrastructure. Adaptation is not a secondary issue. It is an urgent necessity. We must prepare for the changing climate and ensure that our natural resources, communities, and economy can withstand the impacts that are already being felt. Water scarcity is one of the most pressing issues facing Cyprus today. With rainfall patterns becoming increasingly erratic and droughts lasting longer, we have had to rethink our approach to water management. Our drought management plan is a key component of this, ensuring the sustainable use of our limited water resources. We are focusing on recycling wastewater for irrigation and domestic use, using more efficient systems in water supply, increasing the capacity of desalination plants, and promoting rainwater harvesting. Our agricultural sector, which relies heavily on water, has had to adapt significantly. We are implementing efficient irrigation systems, encouraging the use of drought-resistant crops, and supporting soil conservation practices that help retain moisture. These actions are essential to maintain agricultural productivity and ensure food security in a climate-stressed future. While we are making progress, the changes are immense. Water shortage will continue to threaten our agriculture, and we will need to further innovate to ensure the sustainability of food production. Public awareness campaigns and incentives of water conservation are crucial to achieving these goals, but it will require the cooperation of every citizen, farmer, and business. Beyond water management, our agricultural sector is adapting to the changing climate in other ways. We are promoting climate-smart agriculture by encouraging practices such as crop rotation, no-till farming, and the incorporation of compost into the soil to improve soil health and reduce erosion. Healthy soils are not only vital for agriculture, but also play a key role in carbon sequestration, helping to mitigate some of the impacts of climate change. The protection of our natural ecosystems is also a priority. The Ministry is working to implement measures to combat desertification, a growing concern in Cyprus. This includes reforestation projects, the use of plant barriers to prevent soil erosion, and the sustainable management of agricultural land to protect its long-term viability. It is important to stress that mitigation and adaptation are not competing priorities, but two sides of the same coin. Reducing emissions through the National Energy and Climate Plan is essential to limit future climate risk, while adapting to the changes already underway is critical to protect our economy and communities today. Both efforts must move forward simultaneously if we are to build a resilient future for Cyprus. Our National Energy and Climate Plan gives us a clear roadmap for decarbonization, while the National Adaptation Strategy ensures that we are ready to face the immediate challenges of climate change. Together, these plans represent Cyprus' comprehensive response to the climate crisis, but we must remain flexible, realistic, and prepared to adjust our approach as we move forward. Ladies and gentlemen, as I conclude, let me emphasize that Cyprus cannot fight climate change alone. The challenges we encounter are shared across the region, and the Eastern Mediterranean and Middle East Climate Change Initiative is a testament to our commitment to regional collaboration. By working together with our neighbors, we are building synergies to better understand and mitigate the unique climate challenges we collectively face. Through shared knowledge, scientific cooperation, and coordinated action, we can achieve more together only one country cannot do it. On the coming months, our goal is to strengthen regional cooperation with neighboring countries to tackle the severe impacts of climate change in the Eastern Mediterranean and Middle East. This initiative, which the President of the Republic of Cyprus will elaborate on shortly, is key to ensuring our collective resilience and preparedness. The climate crisis is indeed daunting, but it is not insurmountable. The challenges ahead are significant, but with determination, innovation, and cooperation, we can rise to meet them. The actions we take today, both in mitigation and adaptation, will shape the future of our country and our region for generations to come. Cyprus is committed to leading by example, balancing ambition with realism, and pushing forward with the necessary actions to ensure a sustainable, resilient, and prosperous future for all. In conclusion, allow me to extend my heartfelt congratulations to the organizers, the Cyprus Academy of Science, Letters and Arts, and the Cyprus Institute for organizing this successful conference. I also wish to express my sincere thanks to all the distinguished guests for your presence here today. Your participation reflects a shared commitment to finding solutions, exchanging knowledge, and working together toward a more sustainable and resilient future. Thank you, and I wish you all a productive and insightful conference.
Thank you very much, Minister Panayiotou. It is with much regret that the current situation in his country and the area in general did not allow His Royal Highness Prince Hassan bin Talal of Jordan to be with us. He relayed to the chair of the organizing committee the following message to be relayed to the conference.
My dear friend, Professor Kostas Papanikolas, as we speak today, I am reminded of the words of Antonio Gutierrez that we are living a time of global boiling. Without further ado, I would like to say that in the 1980s, when a part of the Independent Commission on the International Humanitarian Issues that we are facing, we acknowledged the importance of understanding disasters. We separated them into 4 categories: elemental, earthquakes, tidal waves, floods, volcanic eruption and landslides; foreseeable, famine and epidemics; deliberate, for example, the results of war between states, civil wars, guerrilla warfare; and accidental. And by that I mean industrial and nuclear catastrophes. I want to say that earlier this summer, I addressed the Green Transition Forum in Bulgaria on regional impact and global sustainability efforts in Central and Eastern Europe. And my country, at the center of the Levant region, is technically, geopolitically, or geostrategically, if you will, Mediterranean, literal, in the Levant Agreement we signed with Egypt and Syria in 1977, although we do not border the Mediterranean. I once asked the Europeans, does this make us like Portugal? They do not border the Mediterranean either. But it seems that discrimination, even in practical geography, still lives quite effectively when they answered me, yes, but the Portuguese are European. So unlike you Cypriots, we are not European. We are not a literal state. We do border the most important dividing line, however, between Asia and Europe, Eurasia. At the same time, we continue with the great African Rift Valley, distancing the east and west coastlines of the Red Sea, the Nubian Shield on the one side and the Arabian Shield on the other. It should make us party that everything happens to everything that happens in the stabilization of the Red Sea region, from Anatolia, in fact, all the way to Madagascar. But our problem in this region is manifold. Our problem is that transcendence is not recognized other than during crises such as COVID. People then woke up and realized that we are vulnerable and that disease can spread. But today, projects. Nobody considers the social impact of these projects. We're told that by 2050, protracted heat waves and sandstorms may make West Asia and the North Africa region uninhabitable. Already extreme weather disasters have displaced over 20 million people a year over the last 10 years. 80% of those displaced live in Asia, home to over a third of the world's poorest people. As these regions become a focal point of intractable conflict and climate change, already fragile conditions may worsen, leading to humanitarian crises. Addressing climate change or climate boiling is inherently linked to a generational contract. We're not talking about our futures. Kostas and Hassan, we're talking about future generations. So the decisions and actions taken by today's policymakers and societies at, for example, the future conference to be held in the United Nations later this month, investing in sustainable practices and reducing greenhouse gas emissions is honoring a contract, a covenant, if you will, as the United Nations Environment Program in Nairobi has called it, a covenant, al-mizan, the balance, and in Arabic and in the Quran, describes the ecosphere very well. Winning the human race, we called for an international humanitarian order, but unfortunately the jury is out on the word humanitarian. Climate refugeedom is a prevalent phenomenon, a truly global problem that demands a truly global solution. A bottom-up approach coupled with unconventional and innovative approaches whereby we empower our people to become citizens rather than to continue as followers. We are not sure about the course of events in terms of relying on this 20th century global structure, which is still not suitable for challenges we face in the 21st. I just want to close by saying that without synergies, achieving the UN Sustainable Development Goals, and particularly goal number 17, partnership, is not possible. And climate objectives remain out of reach. In fact, the whole ecosphere remains out of reach. Addressing climate change and achieving the SDGs are, we are told, inextricably intertwined. But for whom and for how long? Keeping that in mind, I hope that the 7th UN SDG is taken seriously, affordable and clean energy. And for that matter, once again, partnership in our shared humanity. Thank you.
The President of the Republic is currently in New York attending the General Assembly of the United Nations. He has relayed his regrets that he cannot be here to deliver the opening address. He pre-recorded the following address.
Your Excellencies, ladies and gentlemen, dear participants, dear friends, it is my honor to address this esteemed international conference on the climate crisis in Eastern Mediterranean and the Middle East being held today in Larnaca. At the outset, allow me to congratulate the Cyprus Academy of Science, Letters and Arts, and of course the Cyprus Institute for their timely initiative to bring all of you here together to discuss the ways and means to address the greatest challenge that humanity as a whole is currently facing. What brings us all here today is our collective concern and our determination to do our utmost to respond to a serious threat and a profound challenge. Home to over 450 million people, the Eastern Mediterranean and the Middle East region is experiencing increasingly severe climate change events, including extreme weather, rising temperatures, decreased rainfall, increased wildfires and rising sea levels, all of which have profound regional but also global consequences. The immediate and direct effects of climate change are those we all know very well. Climate data from recent years are not at all optimistic. Just to give an indication of the situation in our region, in the past 4 decades, the Eastern Mediterranean and the Middle East has warmed by about 0.5 degrees Celsius per decade. Dear friends, projections under the business as usual scenario for the Eastern Mediterranean and the Middle East region are quite pessimistic. In addition, as regards to Cyprus, the numbers and the scientific predictions are dire. To mention just an example, in my country, the last 5 years have been warmed by 1.5 degrees Celsius compared to the average of previous decades, with several months breaking records of the last 40 years. This situation negatively impacts our environment, our ecosystems and natural resources of our countries. Furthermore, it affects human lives and livelihoods, putting them at serious risk, leading to health problems, agriculture and food insecurity, forced migration and displacement. Dear friends, Cyprus is in the unique position of being the only European Union member state in the geographic area of the Middle East. Building on that unique role, our country has strived since its accession to the European Union in 2004 to act as a bridge and as a facilitator of synergies, common understanding and cooperation between these two parts of the world. This conference here today is a testament to this effort. Within this context, my country undertook an Eastern Mediterranean and Middle East climate change initiative in 2019. The aim of this initiative was to foster regional synergies to mitigate the impact of climate change in the region in line with the goals of the Paris Agreement. At the core of the initiative was the development of a detailed work plan underpinned by two fundamental pillars: a scientific research project and an intergovernmental action plan. With regards to the first pillar, the scientific research project, which was led by the Cyprus Institute, 240 scientists and experts, primarily from the Eastern Mediterranean and Middle East region, formed task forces. The aim was to produce a more detailed assessment of the current situation, identify gaps in research and policy needs, and produce a toolkit of possible actions and recommendations to address the region's climate challenges. The second pillar of the initiative included the development of a regional action plan based on the scientific recommendations of the team of experts. A series of scientific and ministerial conferences were held in 2021 and 2022 in Cyprus to facilitate discussions on the development of the action plan. In November 2022, at the COP27 summit, Cyprus and Egypt co-organized a side event with the participation of heads of states and governments of the countries belonging to this initiative, namely Bahrain, Cyprus, Egypt, Greece, Iraq, Israel, Jordan, Lebanon, Oman, and Palestine. At the event, a political declaration was adopted, as well as a regional action plan. This plan is a toolkit with policy recommendations intended to be incorporated on a needs capacity basis by participating states, both as part of their national action plans to mitigate and adapt to climate change, as well as through regional cooperation between all or subgroups of countries participating in this initiative. Furthermore, the plan has a dynamic character and is intended to keep evolving based on further contributions, developments of the climate crisis, and advancement of the scientific knowledge, data, and technology. The plan is to be realized through projects with the participation of a group of countries that so decide and is open to future additional memberships. Lastly, the recommendations are based on regional suitability. Several of the recommendations have a capacity-building character and propose a restructuring of economic activity that would lead to greener economies. I'm very pleased to announce today that ahead of COP29, my government has decided to revive this initiative and to operationalize the regional action plan as part of its national effort to contribute to the global fight against climate change. In the next months, we intend to intensify our efforts, both at the political and scientific level, in order to enhance regional synergies with the aim of working together with the countries of the region to better prepare, manage, and where possible, reverse the dire consequences of climate change in our neighborhoods. Let me assure you that my government and I personally are fully committed to the continuation and strengthening of this regional initiative. Your Excellencies, dear friends, it is clear that we must act urgently decisively and collectively. No one can change this course of action alone. We need to act together as neighbors and allies against climate change. A common, collective effort by our countries to combat this planetary crisis could also form a paradigm shift that will show the world that we can work together in determination, cooperation, and synergy to leave future generations a better world to live in. Let us walk the necessary path to climate neutrality together. Let us work hand in hand to build resilient, sustainable, and green businesses, communities, and countries for the future of our youth and the prosperity of our region. Thank you very much for the opportunity and best wishes for successful deliberations during your conference.
Thank you, Professor Papanikolas, Professor Malas, Professor Emilianidis, and Your Excellency, Dr. Panagiotou. We will now take a short break to allow the Minister and other dignitaries who unfortunately need to attend other urgent business to depart. We will reconvene sharply at 9:45. Thank you. important it is to adhere strictly to the schedule. As the deliberations will be broadcasted and remote participants tune in for specific panels at specific times. Maybe we'll give 1 minute to people to join. I would like to now kindly ask the conveners and the speakers to adhere strictly to the schedule of their session or panel. Also, please note that the deliberations of this conference will be recorded. We now welcome Professor Jos Lelieveld, Director of the Atmospheric Chemistry Department at the Max Planck Institute for Chemistry in Mainz, Germany, and Professor at the Cyprus Institute, who will convene the first panel for today. The title is The Evolving Climate Crisis, the Scientific Basis. Yes.
So, thank you very much. Please join us. We're going to discuss the scientific basis, and actually the good news is we have the top scientists in the field who are going to lecture in this session. So our first speaker is Professor Marko Kumala. He's by training a physicist from the University of Helsinki. He's the world-leading specialist on aerosol processes. He's director of the Institute of Atmospheric and Earth System Research in Helsinki. He's a member, actually, of multiple academic academies of science, including the European and the Chinese Academy of Science. He leads a Center of Excellence in Atmospheric Science, and he established comprehensive measurement networks and stations in the EU and worldwide to actually underpin Earth system science. Data are needed. He has an amazing publication record, almost 1,000 publications, several dozens of them in Science and Nature. He has been for many years the #1 most highly cited scientist in geosciences, and we're really proud that he is among our speakers. Marko, please.
Thank you, Jos, ladies and gentlemen, and let's now. Where is now my presentation?
Something happened here.
Let's now. There is now two times Philip's presentation and 0 times my presentation.
Can somebody assist here and retrieve this? The Kumala presentation is gone.
CR, CS.
We have 2 times CS.
Yeah. Pandemicăm έχουμε δύο φορές το CS. Professor Kulmala's presentation is here. Kulmala.
I had only in your email.
Technical issues.
Yeah.
One moment.
Thank you very much. Some small technical issues, but luckily I have my presentation here. As everybody knows, we have only one planet. We do not have a second planet. Maybe only Elon Musk can go to Mars and have a second planet for himself, but other people we do not have. And in this planet we have plenty of grand challenges. Population is increasing. Population globally moves to cities. And what do we need? We need good social network, of course, but we need good food, fresh air, fresh water, energy. But what do we get? Climate is changing, especially in big cities. There is air quality issues. There is challenges in water, food and energy supply. There is biodiversity losses. There is acidification, deforestation, diseases, chemicalization, pandemics, etc. And all of them are interlinked. We are certainly not able to solve them one by one. And we actually need all disciplines to work with that. We need different initiatives, like I have now mentioned a couple of those. And one of those are, of course, different academies, scientific academies and collaboration in those. I mentioned here the World Academy of Science, which is Academy of Global South. We need science diplomacy, we need open data, we need different kind of activities like WMO, Global Atmospheric Watch, data getting, and our own initiative, Global SMEAR, getting comprehensive data. ICOS, ACTRIS, ALTER activities, which are European research infrastructures, and I know that Cyprus Institute is member of a couple of those. And also work from ideas to implementation. And if you think about ideas, if all of our ideas will be implemented, then we have too small number of ideas. But if only 1% of our ideas will be implemented, then we have too many ideas. And we need to have balance between ideas and implementation. Okay, if you think about global energy challenge itself, world population is increasing. It is estimated that the maxima is coming 2060, 2070, 2080. The global gross domestic production is increasing more rapidly than population. But all this means that there is increased need for energy supply also. And with this increased need, we can also see, if you look this more carefully, fossil fuels are still making majority of it. Estimated also 2040, 2050 that they are making majority of this. And what does this mean in CO2 point of view? If you take observations from Mauna Loa, we are actually able to see that every year the maxima has been, which is in springtime, in May in practice in Northern Hemisphere, it's bigger than earlier. And there is now numbers from May 2018 to May 2024. And we also see that how much in practice biosphere is able to eat CO2 per year. We have always summer minima in August, September, when biosphere has been active. If we think about the whole data set from 1958, it's now 65 years old, the data set. Some of us are older than this data set, some big fraction of us are younger than that data set. But this is important data set. We are able to see exactly how much this is increased during the last 65 years. And how rapidly it's increasing, how rapidly this maxima is increasing per year. In 60s it was about 1 ppm per year, and nowadays about 3 ppm per year. It's even speeding up. And actually in 20 years we should see that this maxima start to go down. That not increasing this 3 ppm per year, it should go down. Hopefully 3 ppm per year after 20 years. Philip will tell more how realistic this will be, maybe. Okay, if we make the estimation that let's assume that emissions goes down 2% per year and sinks goes up 2% per year, it will take 23 years before the maxima start to go down. And right now we do not see any evidence that the global emissions start to go 2% per year down all the time. or those things. Could be natural things or technical things, doesn't matter. Also, we are not able to see that how rapidly it will go. And although the first thing is to shut down emissions, fossil fuel emissions, then try to increase the sinks. I'm also asking that, do we need solar radiation management? Do we need to study it? Yes, we need to study it, but hopefully we do not need to really use it. And then you can think about who will then start to implement this solar radiation management. Is it EU? Is it Finland, where I'm coming? Is it Cyprus? Maybe not, all of these. But is it Chinese army, US, or Elon Musk? Maybe. And that's why we need to know. Okay, besides greenhouse gases, we have other effects and feedbacks in radiative forcing in climate point of view. And this is one example. Based on our observations in Finland, in Hytiälä, and actually based on the data what we are getting together with this MCARE project and the Cyprus atmospheric observation, we plan to start to compare this north and south comparison between Cyprus and Finland. But anyhow, whenever we have photosynthesis, we have carbon sink, and as a side product of photosynthesis, we are producing volatile organic compounds and then producing aerosols. And without aerosol particles, there is no clouds, no precipitation, the whole water cycle will be different. Furthermore, these aerosol particles and clouds will enhance diffuse radiation, and the diffuse radiation related to global radiation enhancement means that we have more photosynthesis. And this kind of feedback loop will enhance carbon sink when we take into account VOCs, aerosols, clouds, precipitation, and albedo, even 80% in carbon sink alone. Unfortunately, we have only this kind of very long enough data sets from Hytiälä, and I hope that we can make it also here in Cyprus. We start to have data. We need to get data from this kind of boreal and Arctic area, eastern Asia. This EMME region, also a hot topic, Africa, Amazonas. All these are hot topics. And if we briefly look two things, we need this kind of global observatory, high-level, comprehensive, continuous, long-term data, also to answer this kind of air pollution cocktails. And in air pollution cocktail point of view, I think that most of you have been in China. It has been clean days and less clean days. And actually, if it's a really very bad air quality, you are not able to get the, you do not see this distance. It means that you cannot make selfies if you have a bad air quality. If you can make photographs and selfies, then air quality is still reasonable. Maybe it's not, but anyhow, you can make photos. And this area is very big. The air pollution in eastern China is a very big area, and actually, I know, I hope I start later. The point is that in eastern China, today, 10% of world population lives there. It's today. And there is a triangle between this Shanghai, Xi'an, Beijing, and back, where this 10% lives. But this kind of China gigacity can be a living lab for haze studies and air pollution studies to India, to Africa, to Latin America. And also, if we think about air pollution cocktails, that how much people is dying due to air pollution. The more red, the more people is dying. And let's look very briefly the population. Today, population is China, India focusing, but estimation for 2100, it's moving to Africa. In Eastern Africa, it's coming more and more people, and of course there is then the tendency, this kind of, that people want to move from that which is coming hotter and hotter to north. And now back to Eastern Mediterranean, Middle East area. Actually, the temperature is increasing here more rapidly than anywhere else. And if you make the prediction, having this kind of this red curve gives very high temperature increase, and it actually means that business as usual, nothing happens. And then this RCP 2.6 is this blue one, which more or less says that when we make very, very heavy cut down emissions. And if you think about the temperature itself, this is already hot area, left-hand side, and right-hand side we have this, that how much it's increasing, but actually this I like more. If you think this anomaly density, this is actually from Josti's pictures. Anomaly density is historical, and if we really go business as usual, that we do not do anything, already after a couple of decades, we are here. We get really higher temperatures, and anomalies can be even 6 centigrades per this annual temperature increase. And at the end of century, we are here, which means that around 4, 5, 6, but even 8 centigrades, and it's a lot. And those of you who want to see this in more details, there is publication in Reviews in Geophysics, which has been published about a year ago, where we did look carefully what is climate change and weather extremes in this area will be in future. And short summary of that. Somebody want to take a photo of this? But it's now coming short summary of that. This is area, M area is forming worse very fast actually. And this is really a hotspot. That's why it's important to get data from this area to understand how to mitigate and adapt. And rain is decreasing, sea level rise the same as other ways, but also our own emissions has some effect on that. And now one equation. Actually, based on that what I said, we need to make some change based on scientific understanding. But we have always resistance to change anything. But if we want to go over the resistance, we need to have clear understanding, which needs more data from models, satellites, ground-based observations, vision, what we want to do, capacity to change, and visible plans to really face the inherent. Then we can go over the resistance. Thank you.
Thank you very much. I propose that we take questions after the session, so we now continue with the next speaker. I'm going to use you first. Yes, number 2. Excellent, thank you very much. Yes, another very eminent scientist is Philippe Sieyès. He's from CNRS in Paris. He's originally also a physicist and initially specialized in Holocene historical climate studies using Antarctic ice cores. Using isotope data, and then he started developing models actually for carbon cycle models for carbon dioxide and methane, and he also established a monitoring network in Europe to support these modeling activities. He published seminal articles on the carbon cycle, anthropogenic emissions of CO2 and other greenhouse gases, and the role of the biosphere. He also has an amazing publication record of nearly 700 publications. He's highly cited in both geosciences and environmental sciences, which is rather unique, and also many of them in publications in Nature and Science. He has been ranked #1 in publications, influential papers in climate sciences for many years. So, welcome, Philippe Sies.
Thank you very much. It's not the latest version of the slides. The title was Challenges and Opportunity by the Eastern Med and Middle East countries to help reach the global Paris goal of containing warming below 2 degrees. Today I want to speak about scenarios, because I think you all know that climate change is caused by human activity, more precisely by human activities that emit greenhouse gases. There are two main activities. One of them is the need of humans for energy, and we are extracting fossil fuel. We are getting energy out of it, but we release large amount of CO2, and CO2 is the largest factor of global warming. And the other important human activity that is also leading to warming is agriculture and food production, mainly through the emissions of methane by livestock and rice, nitrous oxide from fertilizers, but also CO2 in regions that expand agriculture over carbon-rich ecosystems like tropical forests. So this graph from the IPCC is kind of showing us where we seem to be going in terms of future emission scenarios if the current implemented policy are following up during the rest of the century. It is a red curve, without any additional action. And basically we will go through a warming which is about 3.2 degrees globally. It's a lot. For a country like France, where I come from, it means like 4 to 5 degrees of annual warming, and of course a lot of more extreme events and climate disasters. If we want to contain warming below 2 degrees, we need to follow a very different curve, which is shown on the graph. We need to decrease emissions, and more importantly, the only way to stabilize CO2 and climate is to bring emission to zero. If you stabilize emissions, you will continue to have an increase of CO2, and you will continue to have climate warming. On the one hand, the situation is perhaps not that grim, because the IPCC also noted that 18 countries have made effort, and they have sustained production and consumption-based CO2 emission reductions for more than 10 years. So in the red curve, we are also seeing actions that are reducing emissions. And I think we are moving away from the most catastrophic scenario that was shown by Marco, the RCP 8.5, where we continue unattended emissions. Still, we are going into a world that will have much climate warming than what is needed for the Paris Agreement. The central question that the IPCC cycle will address in the next 7 years is the question of scenarios. Scenarios have been made by economists, mainly from northern countries, and there are two central questions. One of them is equity. Of course, we cannot just make scenarios based on economic affluence and technologies. We need to include equity. It's very important. The second consideration that has been a bit overlooked by the IPCC so far is the relationship between reduction of emissions and sustainable goals. We cannot just reduce CO2 emissions and continue to spread reactive nitrogen, to overuse water resources, to overuse land resources, to degrade soils, and so on and so forth. So the coordination between mitigation and sustainable development goals, as we heard, in fact, in the introduction, is very important. In this context, I have updated the graph I showed 3 years ago, which are based on historical emission data. They are quite accurate for CO2 and methane. And I have taken together all the countries from the Eastern Med and the Middle East region, which are listed on the right. It's represented by the pink curve. And as you can see, this region as a whole is a very significant contributor to current greenhouse emissions. And it's also a very large contributor to the current increase of emissions, because unlike in some other countries, emissions from the regions have been increasing. Today, the Eastern Med and Middle East region is number 3, just behind the US and China. For CO2 and for methane, because there is a lot of fossil fuel extraction, it ranks number 2 in the world. So when you come to emission reduction scenarios, the approach that has been used by the IPCC is to use relatively complex models, which are called integrated assessment models. They consider basically a carbon price, and then they have different sectors, different opportunities, and they see how regional and global economies can reduce emissions based on a constraint. It's a kind of intertemporal minimization problem. It has a lot of uncertainties, and it has a lot of hidden assumptions about the capacity of countries, about the technological progress, and of course about the geopolitical implementation. And as a result, you can see that there are quite a lot of differences between the different economic assessments that lead us to limit the warming to the Paris goals. We have tried to use a different approach. It's really a data-driven approach. We realize that for the UN, nations have made pledges. They have made some unconditional pledges that they will do anyway, and conditional pledges that they will do with additional effort. But the pledges only go to 2030, and of course we need a whole curve that goes up to the end of the century. But many countries also have made net zero emission commitments. So China, for instance, said will be net zero in 2060. Europe said will be net zero in 2070. Saudi Arabia said will be net zero in Europe in 2050, and Saudi Arabia in 2070. So what we did is that we just took the pledges, we analyzed them per gas and per country, and we took the endpoint, the net zero declared by the countries that have a net zero commitment, and we fitted a simple curve. It's a simple logistic fit, so it's very transparent. The only constraint we had here is that the derivative of the curve, basically the emission reduction rate, should not exceed something like 5% per year. It's a bit of a complex curve, but it shows what we get from the current pledges which are on the table. The good news is that emission should reduce if, and only if, the countries, of course, do what they have promised. And in this promise, the net zero commitment is the most important, because this is what will take us to the limitation of the warming. What you can also see at the end of the century is that we don't reach net zero with the current pledges. In particular, we have a lot of methane emissions, and this is because many countries did not want to touch on food security. They did not want to say we are going to do something about agricultural emissions because they are afraid that it could jeopardize their food security. So in this very simple analysis of emissions for the future, we can also look at the contribution of different regions, in particular the Eastern Mediterranean and Middle East region. And today, this region is only, for the historical period, since the beginning of the century, of the previous century, this region has a small contribution. It's 7%. But because this region has a lot of countries that are emitting a lot and that have no net zero commitment, we were quite surprised to see that in the middle of the century, the region will become the second largest emitter, just next to China. And in the end of the century, because China has a net zero pledge, this region will become, responsible for 20%, as much as China, of the global emissions that will be left by the end of the century. We then used different climate models, simple climate models, impulse response function, whatever, to look at what are the temperature implications for our simple counterfactual estimation of the future emission from pledges and from net zero. And we found that although emissions will reduce, we are still above the Paris goals. We also found that there is a very large uncertainty that we must consider in the climate system. We still don't know very well the climate sensitivity, for instance. For given emission profile, you still have an uncertainty of about 0.5, sometimes to 1 degree, just because we don't know how the climate system, basically how temperature, will respond for a given emission reduction scenarios. Then you can also look, in the spirit of the Paris Agreement and the UN Convention of Climate Change, at the responsibility or the contribution of different regions to the climate warming. It's slightly different than the contribution of the regions to the CO2 emissions, because we know that CO2 is a long-lived gas. So even CO2 that has been emitted in the last century, there is still a lot of it in the atmosphere, so it will still contribute to warming during the coming century. And in this picture, you can see that the Eastern Mediterranean region is contributing still something like 10 to 13% of the future warming. And because we are optimistic, we looked at the possibility to improve the pledge. For instance, we take the global methane pledge from Glasgow, and we assume that all the countries will sign for it. But the global methane pledge is ambiguous. We don't know if the countries will do the pledge in addition to their previous pledges, so it will be an additional reduction emissions, or if they just will do the methane pledge, but they will count it basically as part of the overall nationally determined contribution. So we studied this. We also looked at the possibility for countries that have a late net zero point, like Saudi Arabia. What if Saudi Arabia decided to do a net zero in 2060 or in 2050 instead of 2070? It's very important. And also we made a scenario where countries that do not have a net zero commitment, this is the most important thing, will take one. And we did that, of course, for the Eastern Mediterranean countries. And we found this picture. So again, it's a complicated picture, but every color strip is the additional wedge you get for reducing emissions, where you take some kind of improvement of the NDCs. We found different things. First of all, that if tropical countries really halt deforestation, it will be very beneficial. And secondly, this is a dark blue curve, that if all the countries, in particular the countries of this region, will commit to net zero by the mid of the century, it will have a very, very important effect to reduce global emissions and to meet global warming. You can see on one of the sub-pictures that adopting net zero by all the countries of the Eastern Mediterranean and the Middle East will probably, it allows us to save about 15% of emissions globally. So it's very important. Conclusion, the region will have a very critical impact on the future of the world emissions, therefore on reaching or not reaching the 2-degree target. I remain optimistic. Limiting warming to below 2 degrees is possible, but very difficult. 1.5 degrees, we're already at 1.3 or 1.4. But for this, net zero commitment by 2060 or before are needed. In conclusions, sorry, part of the slide is cut. It was seen, I think, in the news that for the first time, China, in 2024, has reduced its emission. It was quite unexpected. China's fossil energy system is 75% based on fossil fuel. They are investing a lot on renewable. And for the first time in 24, the amount of energy, power produced by renewable in China exceeded the amount produced by coal. So it's a very good news. So I wanted to ask the question, if China can do it, why the most affluent countries of the Eastern Mediterranean and Middle East region could not do it? I believe the region, of course, has a huge potential for transition in terms of solar power. The most affluent countries also have capital and resources to make this transition possible. We all know that in terms of sobriety, more efficient use of energy is possible. And it was a bit hidden in the slide, but because this region is extracting a lot of oil and gas, it's a kind of no-regret option to do something to fix the leaks of methane from the oil and gas industry. First of all, you save money when you are an oil producer. You recuperate more gas that you can use and sell on the market. And of course, it's very good for the climate. With that, I will stop here.
Thank you very much. I'd like to say one other thing is that we had originally planned to have a session with 4 people. As you can see, the gender balance is not really good here. One of our invited speakers had to cancel. She is from Abu Dhabi and originally from Lebanon. She said there's a family emergency, so I don't want to think about what might have occurred there. But anyway, this is the reason why we have only 3 speakers. So the third of our speakers is our local hero, Jean Siard. He's director of the Climate and Atmospheric Research Center of the Cyprus Institute. His research focuses on the characterization of atmospheric composition, in particular aerosols. He's a chemist. I would rather call him a biogeochemist because he looks at cycles and he has a track record in studies on interactions between the atmosphere and the ocean. He actually did a postdoc at our institute more than 20 years ago, so it's always good to see that your young scientists are making a good career. So, and then he was a research director at CNRS. He is since 2014 a professor at the Cyprus Institute, where he establishes the critical infrastructure that is needed to underpin atmospheric and climate science. Studying atmospheric composition and attribution also of pollutants to the sources. Jean, the floor.
Good morning. It's my pleasure to be part of this conference. We have initiated with Professor Papanikolas the first one in 2018. It's the third one, and it has been monumental in developing activities on climate change and air pollution at the Cyprus Institute and over the region. And we have seen how successful are this type of conference to bring together science and policy. And it's my pleasure here to bring a little bit of science in this conference. Jos was asking me to bring the role of air pollution on climate change. And actually, when you ask people if air pollution has a role on climate change, it's pretty unclear for the people. They say yes, they say no, everything gets mixed. CO2 is a pollutant, yes, no. So I will try to explain you a little bit better here what we should consider as pollutants, but having a role on climate. And then I will focus on aerosols and short-life climate pollutants, which are called SLCPs. So these aerosols and short-life climate pollutants, I will define them first and their impacts on climate and health. I will highlight here the current gaps in observing these species, which prevent us to provide accurate prediction of their concentrations and also of the efficiency of mitigation actions taken locally. What has been so far for a couple of years our strategy at the Cyprus Institute to fill this gap, and conclusions and perspectives. So starting with the definition. So we have atmospheric species which are either pollutants or climate forces. If you look at some typical air pollutants like SO2, NO2, CO, they are air pollutants, but they don't contribute directly to change the climate. If you look at aerosols, what we call PM, particulate matter, PM2.5, PM10, which are regulated aerosol parameters, they are pollutants. They are impacting the climate. Actually, they are cooling the climate, and you have heard, I'm sure, a lot of discussion on geoengineering and why we should not spread aerosols in the air to cool the atmosphere. And then you have black carbon in aerosols. So it's a component of the aerosol which is black, which is a pollutant, again a climate forcer, but here warming the atmosphere, and methane. Methane, which is a pollutant, climate forcer, and again warming the atmosphere. These are the short-life climate pollutants. And of course CO2, and CO2 is not an air pollutant, but is warming the atmosphere. So with this picture, you have an understanding of where we are, and I would like to focus my talk on aerosols, black carbon, and methane, so on aerosols and SLCPs. Aerosols, what we are talking about, here are pictures of human hair, thin beach sand you can find nearby the hotel, and PM10, which is very small. Actually, PM2.5 is a very small fraction of PM10, and if you look, even black carbon is an even smaller contribution of aerosols, typically below 100 nanometers, so nanoparticles. And here are microscopic pictures of black carbon, which comes from complete combustions of fossil fuel and biomass. Aerosols have a lifetime of several days, meaning that if today you switch off everything that emits aerosols, for human activities, within a week, you will have nothing in the atmosphere. The sources of aerosols and black carbon comes from human-made activities, transport, traffic, industry, domestic heating, and natural aerosols like sea salt, fires, dust, volcanic ash. Methane is another SLCP. It's called short-life climate pollutant because compared to CO2, it has a lifetime of 7 to 12 years, meaning that if you switch off human-made emissions of methane now, you will see that they will decrease fast and nothing will remain within a few years. That's not the same for CO2, has been highlighted by the previous speakers, that CO2 lifetime may stay there for hundreds, even thousands of years. Will be very difficult to remove and will take time. Methane has been multiplied by 3 in 100 years. The main source of methane are agriculture, as mentioned by Philippe. Oil and gas is the main contributor of methane in the region from the oil and gas production. Now, what are the impact of these species, aerosols and short-life climate pollutants? This is the very well-known IPCC picture where everything on the right side is warming, everything on the left is cooling. And basically, aerosols is almost the only human-made product in the air that cools the atmosphere by reflecting the solar light or changing properties of clouds. And the SLCPs, the methane and black carbon, are important components as well that is responsible for the global warming. Actually, if you sum these two, basically they are as much as contributing as much as CO2 to the global warming. I mean, CO2 is not the only player here when it's about warming the atmosphere, right? And mitigation measures should not, of course, take only CO2, and you should integrate this in your mind that if you just put CO2, we will not achieve our goals, but if we implement mitigation that combine CO2 and the SLCPs like black carbon and methane, then we will be in better capacity to reach our goals. Now, aerosols on climate. I told you that aerosols are cooling the atmosphere. Actually, a work led by Josselefeld at the Cyprus Institute tried to understand what happened in the Mediterranean that we have experienced in the recent years, a very fast warming. Actually, they have investigated different reasons. So these are here, greenhouse gases, radiative forcing, the influence of aerosols, the influence of soil moisture, the influence of multivariate like ENSO index, and solar irradiance. And they did this for the Mediterranean, but they did this also for different places in the world. And what they found very interesting for the Mediterranean is that the second parameter responsible for the warming in the Mediterranean after greenhouse gases is aerosols, basically the reduction of aerosols in the Mediterranean because of better air quality, because of the measures that have been taken in Europe to reduce emissions of aerosols, have led to an increase of temperature in the Mediterranean. So it's a bit counterintuitive that something that is good for the health may not be so good for the climate. Nevertheless, climate is the main goal here, and we should find strategies with co-benefits. Now, impact on health of aerosols is a matter of size. Actually, PM10, PM2.5, and black carbon have different impact. The larger particles of air that you breathe remain at the upper level of your breathing systems. But when they get smaller, like black carbon, which are typically below 100 nanometers, then it can go very deep in your body and even reach some part of human bodies, like the brain. In short, the smaller the aerosols are, the biggest health impact they have. And in this respect, black carbon is warming, is a bad guy, but also has very bad health impact. That's why I'm focusing here on black carbon. Now, where we stand in the region, and why it's important, you know that observations without observations, there is no a level 0 that we need to have when we implement mitigation strategy. We want to have a reference baseline so that we can say that our policy is efficient or not. Where we are, these are observations of greenhouse gases, which is led by the European Research Infrastructure, ICOS, and nothing is done in the Mediterranean and the Middle East. For aerosol and reactive gases, the same, nothing. For desert dust, which are currently monitored by LiDAR, by remote sensing techniques, Again, nothing. For solar radiation, nothing. We have no information about all these species which are an impact on health, an impact on climate in the region. There is some observations, though, from WMO, the World Meteorological Organization, that this is all stations in the region that are registered. But if you look at the stations which report data, you have much less. So many stations in the region have data, but don't share the data. That's a problem. After, you need to have long-term observations to train your models and to see trends. I mean, this is a network that provides a quantity of aerosol in the atmospheric column. And that's very important because this type of data are used to validate the models that simulate the impact of aerosols on climate. If you look 1 year data, it's a lot. If you look 5 years data, it's much less. But if you look for stations which have 10 years observations, it's almost nothing. How you can address trends if you have no long-term observations? So it's not just a matter of geographic gap, but also in temporal gap that we have. Our strategy to address this is here taken from a satellite picture of NO2, which is a product that is emitted from the combustion of fossil fuel, and black carbon is co-emitted with NO2. These are the hotspots in the region. The Nile Delta, the region of Lebanon, Israel, then you see some hotspots, Riyadh, Jeddah, the Gulf region, with Qatar, the coast of Saudi Arabia, UAE, and some other places. These are the places where we should look at to address emissions of black carbon, of everything that is responsible for health impact, climate impact from local emissions. So it's transport, it's domestic use, it's industries, energy production. The problem is, and I have experienced it by myself, it's almost impossible to go in these countries and get data and get them published. All these data are measured, all these data are confidential. It's forbidden for the researchers in their country to publish this data with few exceptions. But how we can do to address this? Satellites. The region has no clouds. Satellites can measure everything now. We need to calibrate these measurements, and we have installed with the University of Bremen in Cyprus at the Cyprus Institute an instrument which is very accurate, and you can see is the only one in the region that can help to calibrate satellites from NASA, from ESA, that this satellite can provide CO2 measurement, that these CO2 measurements can be processed, for instance, by the team of Philips, that can be in capacity to assess the emissions of the cities, even though it's not possible for us to go there. Another example, a joint PhD between the Cyprus Institute and the University Paris-Saclay in France, again using satellite data, and here investigating the role of NO2 over Egypt, has been able for us to estimate emissions, compare with what is reported by the country in terms of inventories, found out that our satellite observations show that there is higher emissions than what the country is claiming, and of course this will lead expectedly to higher emissions of black carbon. But we have also not just satellite-based strategy, but also in-situ observations, and we have developed here a world-class observations to monitor regional pollutions. This is a network of observations we have implemented for a couple of years in Cyprus. We have integrated them in international networks. We are sharing all data produced in Cyprus for the scientific community to use this data for their predictions. Example of data that we have been acquiring here is when you have a peak of pollution in Cyprus, where it comes from. These are the hotspots for black carbon and organic aerosols. And it comes from where? It comes from the Middle East and from the combustion of fossil fuel. Now, if you look at the pollution that we breathe in Cyprus, and you try to locate it where it comes from. When it comes from the Middle East, for the last 10 years, we breathe more and more pollution from the Middle East. Sulfate, biomass burning, organic aerosol. All these emissions are increasing where everywhere in Europe, all these emissions are decreasing because of new technologies. Another example is if you want to look in Cyprus, what Cyprus is contributing to. So this is the regional, let's say, composition of aerosols that we receive in Cyprus. Half of the pollution we breathe in aerosol in Cyprus come from the region, and have you seen, mostly from the Middle East. Half of it is sulfate, is fossil fuel combustion, but everything else is also fossil fuel combustion. Basically, 2/3 of the pollution that comes over Cyprus is fossil fuel combustion. Now, if we look at what the city itself produces, we are not better. Traffic, biomass burning, domestic heating with wood, that represent very strong pollutant in Nicosia and Limassol, are the typical pollutants that are produced locally. The last example, in some countries it's possible to make some measurements. You have been in Egypt. We have tried to understand the reason why there is a big haze over Cairo every year. And surprisingly, we have found that the main responsible is this compound, NH4Cl, which is a tracer of combustion of plastic from combustion of domestic waste. They have a big problems in dealing with their waste. They are burning them, so it's good they burn them, they don't emit methane, but they burn them and they emit pollution. Actually, they know about this. Actually, they have asked funds from the World Bank, like $200 million to combat this pollution in Cairo. Actually, the Cyprus Institute is helping the government of Egypt and the Greater Cairo area to implement strategies to decrease air pollution over Cairo. Conclusion and perspective, my take-home message are the following. Aerosols and SLCPs, black carbon methanes, are key climate forces, not just CO2. They have strong health impacts, for which mitigation options shall be considered in our strategies. Fossil fuel extraction combustion is the main source of human-made aerosols and SLCPs in the region. There is still a major gap of atmospheric observation in this region, which makes it difficult to quantify emissions, to estimate trends, and better predict with a good accuracy the efficiency of any mitigation measures. Cyprus and Cyprus Institute has been filling this gap and has become in few years the regional leaders to measure aerosols, SSCPs, and greenhouse gases in the region through various means, satellites, ground-based observations, campaigns. But similar research-based observations must be implemented in the Middle East, in the region here, with full and transparent open access data. Thank you for your attention.
So we have, according to my calculations, 11 minutes for questions. We started 10 minutes late, so are there questions? Yes, please. I'll bring you the microphone.
My name is Mary. I am from Jordan. How we could talk about global warming and the climate change without thinking about the risk in the region and what the war around this area in the Middle East is causing for threatening everybody's life, every human life. So is there a law is going to control the law, because we live in one global. So we are in one ship. If somebody try to make the ship drown, it's going to drown with everybody. I am in Jordan, and we have a lot of refugees, and we are one of the poorest countries in water. Yeah, I just want to focus how we could, let this global survive, since we have the war around in Gaza, in Lebanon, killing people that they can't survive, and they are in the front line of the global warming and the climate change.
Well, it's definitely true that the region is facing multiple crises, but let's not trade one crisis to the other. I mean, we're focusing here on the climate crisis. I think we have top scientists in the field, and I'm not sure if there are also top scientists in the field of making peace. But the need for action there is a point very well taken. Are there more questions? Maybe I have a question. Is there a question there? Oh, there's another one. There was this layer there.
Thank you. Just further to her intervention, when you calculate the carbon dioxide emission Did you consider the amount of tonnage of carbon dioxide, the emission of this amount, when you studied what will be the impact and when it will be zero emission, the current war that is happening because of pumping and fire in Gaza and Ukraine and everywhere? So this amount of carbon dioxide with a huge amount, and you know what is, it is much more, maybe 20% more the footprint of what you ask a developing country to adapt and to change into clean energy, whatever. So when you study this, did you study what will be the impact of this big amount of carbon dioxide that is emitted because of fire, because of war, and what will be its impact in reaching our goal? Thank you.
I understand that this topic is burdening many of you, but for example, we know from the Kuwait oil fires that the emissions of CO2 actually were not affecting very much the global CO2. And we also know from COVID, this was a really crisis. And maybe I can ask Philippe CS, the COVID crisis, how did this affect the CO2 emissions and the climate? Can you say something about that?
Well, unfortunately, to answer your question, I think it's a very good question. We don't have data to look at the impact of war, like the war in Ukraine or the war in the Middle East. It can be on both ways. Of course, when you have a reduction of economic activity, you have reduction of emissions, and then, of course, you have war activities that are emitting more. But we know that human activities are very addicted to energy and to carbon. Basically, humanity is very addicted to carbon. And as Jos said, during the COVID, you know that the population was confined globally, and the emissions were only reduced by 6%, which is very low compared to the stop of human activity. So definitely the conclusion of this is that the way to fight against climate change is not to confine people at home. It's just to replace energy that we need by clean and low carbon energy.
Thank you.
I could also comment both of those. Every war will be bad for climate, bad for biodiversity, bad for water and food supply. And the emissions are, of course, CO2, but also black carbon and aerosol particles. And then how big are the environmental issues? It's hard to say, but we start to have some evidence and some data from Ukraine, and hopefully also get some data from Lebanon and Israel. But it's hard to get. It's not typically any open access. But anyhow, we try to get the data and then to maybe after years to have an answer to your question.
Thank you. I think there was a... Please go ahead.
Hello. My name is Abdurrahman Sultan. I'm from EcoPeace, Jordan. Thank you very much for the presentation. It's an eye-opening to see that the Eastern Mediterranean suffers a lot from climate problems and crisis. We understand that we're in the Middle East. As you mentioned, in Cyprus, we have 1.5 degrees centigrade, and probably in Jordan, Palestine, Israel, we have higher degrees and less rainfall in the last decade. It's really important to understand that probably in our region, we are a result of a global climate change, and probably our region suffers most from climate change. Probably the wind that is coming from Europe and other countries also brings all those pollutants to our region, and there is a stagnation in our region, and that's why probably it's really important to see if there is meteorological and oceanographic models that explains it why. But in any case, I think that the Middle East is subject for more climate crisis, and adaptation is very important. So we need to think of what actions need to be taken in the neighborhood of the Mediterranean, but also in our region, to reduce the risk of the sudden and increased climate changes, especially temperature and NOxes, etc., etc. Thank you.
Okay, thank you very much. Maybe commenting on that, you also mentioned that the region is suffering from climate change. This is exactly right, but as Philippe CS has shown, the region is also a major cause of climate change. And so we are not only a victim here, we are also partly the cause. And if you look at the trends of greenhouse gas emissions, you see that the trend in the region is strongly upward. And it's not only Saudi Arabia, I want to mention this also. It's really the region. So we also need to contribute here to solving this problem in this way, through mitigation. I saw another hand. Yes, please.
Is that okay? Right. Okay. Hi. My name is Galit Cohen. I'm from the INSS in Israel. And I would like to ask you, you said a lot about lacking of information and data in our region. And I know that in one of our research is using a platform that based on AI and machine learning and trying to predict the climate crisis and climate risks around the world. And we get all this information. Actually, it's a platform that used for an financial sector, financial institutions that help them to evaluate and manage the risk, climate risks. So what do you think about that? Did you think about using those platforms or, you know, create one that can use the information all over the world and do not need any specific information for one place? Thank you.
Thank you. So maybe we can subdivide this question into data availability. Maybe I can ask Jean. And then on the machine learning component, especially of the large data set, I think Philippe Sies could say something.
Now, regarding the data, I think I have highlighted here that there is a critical gap of data, and satellites cannot do all the job, but actually satellites must be calibrated with data at the ground. And we have a very nice example of having satellite data which were overestimating emissions from a country of the Gulf. And actually, the measurements of this country would prove that the satellite that was not calibrated and would decrease by 25% emission, which was very good, by the way. The country would show that satellites data, if they don't have in-situ data, they would overestimate emissions. However, this country refused to share this data, and then we had to publish something that we knew was 25% over the reality. So you have, and we have to make a lot of education of these governments in the region that it's all benefits for them to be part of all these activities of observations so that also they have a say in the communication it is done. Currently, it starts to happen. I mean, we have very good examples in Egypt. We have good examples also in the Gulf, in UAE, where the environmental agencies, after the COP there, start to understand that they need to do something. They do, and they need to communicate. We have been able to publish one of the first papers on methane emission from the Gulf with the governmental agency of UAE. Can you imagine? This is changing. And I think if we are managing to change this mentality in these different ministries in the countries, we will be able to get what we want, get more observations, more robust predictions for the future.
Thank you, Jean. As a final remark, I mean, the use of artificial intelligence.
I think it's an interesting point of view to use AI, and there are some very significant developments which happened last year in the weather forecast domain, where we have seen that AI can basically replace some parts of the weather forecast system and still be very accurate. However, if you use AI for climate impact, I think we have to be careful, because you can build emulators of climate model using AI, no problem to do that. But we have to see that, for instance, in Europe, none of the current IPCC models are able to predict the observed warming rate. In the United States, it's the opposite. The climate models are over-predicting the hot extremes, all of them. So, because they are missing some parameterization, they are missing some fundamental processes. And at the moment, we see AI eating models, but it is still not clear, in particular in the weather forecast domain, if AI will eat the observations. Basically, if AI will be able to tap into the Earth observations, satellite observations, or weather stations to predict the weather. This step is not achieved yet.
Okay, I think we have to end our session. I would like...
I would like,
Come in with a
okay,
it's
very
not
short
a
question.
so much as a housekeeping feeling. I'm in the 8th row here, and I'm sure I join with many other people. I just cannot see a third of the presentation screens. They're information dense, it's wonderful, but we just don't get to see them. Partly because the panel are sitting in front of, rather like I guess the word, which is the country that's missing.
Yeah,
and
okay,
the
this
panel
is something we
could
have to
remove
fix.
themselves, but also, could we project it in some way that we could actually do justice to the whole information-dense slide? It's just unfair, I think, on the presenters to give them only 2/3 of the screen.
Okay, good point, well taken. Thank you very much. I would like to thank again the speakers, and thank you for your attention.
Patience. We now continue with the second session entitled Mitigation Strategies and Challenges. For the first panel of this session, we welcome our next convener, Dr. Andreas Poulikas, Chairman of the Cyprus Energy Regulatory Authority. Dr. Poulikas will convene the first panel of the session entitled The Technological Challenge to Decarbonizing the Regional Economy.
Thank you very much for the introduction. I'm very pleased to welcome you all to this extremely interesting panel dealing with a very important topic regarding the technological challenge to decarbonizing the regional economy of the Eastern Mediterranean and the Middle East. This topic will be scientifically expanded during the discussion by our three distinguished panelists. We have with us Professor of Mechanical Engineering Bassam Dali from the King Abdullah University of Science and Technology, Saudi Arabia. Also, we have with us Professor Brian Norton, former head of energy research at Tyndall National Institute and former president of the Dublin Institute of Technology in Ireland, as well as Dr. Khalid Toukan, which is the chairman of Jordan Atomic Energy Commission and director of the Synchronotron Light for Experimental Science and Applications in the Middle East, CISAME Center. The duration of this panel will be approximately 40 minutes. The plan is to have a presentation or an opening statement from each panelist for 5 or 7 minutes and leave sufficient room for discussion, including questions from the audience. Let me give a very short introduction to the topic before we proceed by providing some highlights regarding energy transition and technology availability for the decarbonization of the Eastern Mediterranean and the Middle East region. Regarding energy transition, in our region, we need to locate the energy resources and the current and future energy technologies for all energy sectors, namely electricity, transport, and heating and cooling sectors. Also important aspects are the role of storage technologies, as well as the role of green hydrogen, that is the hydrogen produced from renewable energy sources, as well as the pink hydrogen, produced from nuclear power, as well as the role of other energy vectors such as ammonia, as well as methanol. So let me now give the floor to Professor Bassam Dali for his opening statement. Please, Professor.
Okay. Good morning, all. Thank you, Andreas, for introducing me, and thanks the organizers for inviting me. It's a pleasure to be here. I did want to make a statement in the previous session, so allow me just for 1 second. Data is available of what Israel has done in Palestine. I want to dispute that. There's scientific papers have been published. It's estimated that 30 million tons of greenhouse gases will be emitted that should rebuild what Israel has destroyed since October. In addition to that, 55,000 trees have been uprooted until February 24. In fact, Israel uprooted 800,000 trees since 1967. So these are not insignificant numbers. I encourage them to have the Israel factor when they do climate change assessment for the region. All right, this is not a topic from what I want to address, so allow me to focus on what I wanted to do. The next 5 minutes, I'd like to present my thoughts on the topic at hand, namely the technological challenges to decarbonize the regional economy. We'll keep it short, and I will be happy to expand on these ideas. Please feel free to ask more questions about it. So here's what I believe. I believe that technological solutions to address climate change and to decarbonize the economy are abundant, and in many cases are feasible and economically viable, both in the region and globally. We're no different in this region than the rest of the world, so technologies will apply here as well as everywhere else. However, I have 4 observations that would help make these technologies a reality. The first one is in enabling policies and long-term certainty. Industry investment and appetite for risk will be helped when there are predictable and clear policies and approach. An economy of scale is essential for the development of competitiveness of any technology. Scaling up will also bring investment in research and development to enable further development and improvements of these technologies. And of course, to remain competitive in the market. In other words, we have way too many innovative solutions that are waiting for industrial funding to become commercial, and policymakers can help in creating a conducive environment and for investment of these solutions. There's a really nice video online about how PV made it to become such a popular renewable energy. Innovation happened first, economy of scale through China happened after, and then they hit a plateau. And then another technology advancement happened, and then the process kept going down. And so economy of scale is important, but in today's environment, these industries will not invest without proper policies and long-term vision that governments can provide. So that's point number one, policy enabling. Point number two, being technology agnostic is a good thing. So regulators and governments should not come and say only this or only that. Let the market decide. However, an open market setting, or not picking winners, of course help in creating competition and allows the market to drive innovation. However, scrutiny of these technologies and following regulations will still be needed to ensure affordable, environmentally friendly circularity, or what's called end-of-life solutions. A detailed and robust life cycle assessment of these technologies is needed to ensure that we don't repeat the same mistakes and of course ensure environmental sustainability. I want to ask you, PV cells have been being installed for the last 2 decades. Does anybody know how we're going to recycle them? Does anybody know how we're going to recycle lithium batteries? Now, before we implement these technologies and then wait for another couple of decades and ask a question, oops, we have a problem, not that there's no technologies to decarbonize them or to recycle them, is that these options are also environmentally damaging. How much CO2 would take to destroy, to recycle a lithium-ion battery? By the way, to produce one battery for an electric car, medium-sized electric cars, you have to turn 150 tons of dirt. There's a lot of CO2 goes into that. So this is where life cycle assessment is important. And when we adopt solutions, we need to make sure that we're not causing more harm than good. So that's the point number two. Point number three is that synergy, integration, and hybridization during transition is essential. What I mean is this. There are trillions of dollars worth of stranded assets, energy-related stranded assets. They can do more, we can do more to reduce their carbon footprint. This can be achieved through finding synergetic solutions that can be integrated without major cost, while also take care of the intermittent supply and price fluctuations. A good example is fuel flexibility, by which systems can be operated on traditional fuel, alternative fuel, or a blend of which. For example, you may have heard about E10 or E20. In other words, 20% ethanol added to petroleum. Now, immediately, almost offsetted the CO2 emission by 20% if this ethanol is coming from, say, biosources. This is, for example, what's happening in Mexico. In Australia, you could go buy an E10 on normal petrol stations. There's also D5 and D20. So biodiesel can be also utilized. Another example is the utilization of waste heat or waste materials to improve efficiency, leading to a reduced in carbon footprint. With all our drive to put more PV cells and drive electric cars, we forgot about the main emitters. For example, there's 1.4 billion cars on the road. Okay, we could put as many electric cars as we want. By 2050, we'll make absolutely no dent to CO2. However, we could incentivize alternative fuels that go into mixed with current fuels, such that okay, we can continue using until the end of their lifetime, of course, and making an impact on systems that's already emitting now, or we're not going to dispose of tomorrow. Point number 4 is that industry decarbonization technologies need further investment and development. While commercial technologies are already available for the power and transport sectors, power, PV cell and hydro, transport, electrical fuel cells and hydrogen and so on, marine, ammonia and so on, the industry sector, which often termed hard to abate, is still lacking critical technologies and enablers for it to decarbonize. So industry is third of the CO2 emission. Another third is the power, electricity, and another third is the transport. So we should not forget about this third. These industries, by and large, are risk-averse, capex intensive, and trade exposed. What this means, in other words, any change can disrupt and be very expensive. Also, margins for profits are relatively small due to global competition. So hence, any changes will make a lot of difference to them, but we need to incentivize them to do something about it. More is needed to find viable solutions and strategies to help industry decarbonize, and to also develop and commercialize the needed technology into the future. Cement is 8% of CO2 emission in the world. Steel is 8% of the CO2 emission in the world. If cement or steel is a country, they will be number 3 in the world. Now that's a substantial industry where we could start. In Saudi Arabia, I'm leading an initiative to develop a roadmap to decarbonize cement in Saudi Arabia, and bringing all the parties together, the manufacturers, the government, the end users, to try and find ways by which we could move across this without shutting everything down and starting again, which will never happen, of course. So let me summarize, if you could put this slide on. 4 points. Basically, it says that enabling policies and long-term certainty are needed to de-risk investment in new technologies. Being technology agnostic is beneficial, but more attention needs to be spent on life cycle assessment and to ensure circularity and environmental sustainability. Synergy, integration, hybridizations during transitions are all will be needed, and industry decarbonization technologies need further development. I'll be more happy to elaborate on those. Please do ask me questions if you like, but thank you very much for your attention.
Thank you very much for your opening statement. Now we'll ask Professor Norton for his opening statement. Thank you.
Good morning, everybody. You'll be pleased to know I don't have any slides. That has the advantage that you don't have to think something to peer at. The disadvantage, you have to listen to what I have to say. All human needs are subject to 3 constraints, reconciling 3 constraints, and whether that's water, food, or in this case, energy. And those constraints are the environmental sustainability of what you're using, the affordability, and the security of supply. And all technologies need to be seen through those particular lenses of a whole variety of scale, from the individual and the domestic through to the national. And as you select technologies, it's not simply that something is technologically feasible. It meets that criteria within the particular local constraints. In the context of seeking to have more sustainable energy supplies, 2 things are done. One is trying to reduce the consumption of energy, and as Professor Daly said, in both industrial processes, but also at the domestic and the building scale, and then meet the energy that's actually required, bless you, from renewable energy sources. So that's the kind of combination. But renewable energy sources are variable. They vary, obviously, if you've got solar, for example, from day to night, and they vary over the year, and they're intermittent. They can actually produce more energy than is required and are curtailed, and that's a particular feature of wind energy in many parts of the world, but often they don't actually meet demand. So to do that, we move energy in time and space. We move it in space with transmission networks both at the local scale and through interconnectors at the international scale. And we move it in time through energy storage, through batteries, hot water, hydrogen, etc. So a whole range of technologies coming into play. And again, all of those exist at a whole variety of scales. So you can have a microgrid where a number of dwellings are linked together. Some might have PV, some might have battery storage, some might have PV with no battery storage, some might have none of those features at all. But in a local network, they can share that resource so that when there's overproduction of energy compared with use in one dwelling, it can be passed to another dwelling. And the local scale, that can then reduce the investment that a utility needs to make in its overall production system and give you decentralized storage. Energy tends to be seen around electricity these days, and electricity because what's produced by PV and wind, for example, and as storage in batteries. But increasingly, there's a realization a lot of energy uses are actually heat, and direct production and storage of heat and heat networks, and indeed cold networks, might also be things that need to be considered. And particularly in the climate we're in, the Eastern Mediterranean and the Middle East, there's a very high, what's called direct normal incidence solar radiation. So the ideas of producing concentrated solar to produce electricity, produce high temperature heat, and also because the storage systems of using, for example, latent heat storage, phase change materials that work at high temperatures, the higher the temperature of the phase change, generally speaking, the much higher latent heat you have and the much more compact storage of very high volumes of heat. And the potential to do that kind of system is particularly a feature of this part of the world and further development of those kind of technologies. Also, as I say, there's huge opportunities for process and end-use improvement. End-use improved in buildings in terms of using that same sky, which has got that direct normal instrument, means you have clear skies. Clear skies tend to have quite good radiative cooling at night, which means you've got the ability to produce heat sinks that reduce the cooling load for the next day, and cooling is, as many of you know, a very large energy requirement. You've also got a whole range of things to do with controls within buildings and components that can change their components to relate to the different climate conditions at different times of the year. In industrial processes, there's a huge range of opportunities to improve them. As Dr. Daly already mentioned, if you looked at cement, steel, glass, you have production processes that are 1,000, 1,200 degrees C with huge energy consumption and huge embodied emissions in the product. Now, to some extent, that can be reduced by using renewable energy to power those processes, but also there's still a lot of headroom for process improvement. One thing I'm involved with, and I have to declare my conflict of interest in that I'm involved in a startup that does this kind of work. The startup's called Pyramp, for those who've got large amounts of money to invest. There's technologies where, rather than photovoltaics that use energy from the sun, you photovoltaics that use energy in the range produced by furnaces. And the ability to produce directly electricity from steel, glass, and cement production is a huge opportunity to give process improvements that then reduce the actual energy consumption from the grid. So, in summary, there is no silver bullet, and there are huge challenges in terms of policymakers making decisions. So, for example, I mentioned hydrogen earlier on. Hydrogen had quite a lot of hype. Hydrogen is always going to be more expensive. Green hydrogen, renewable energy produced hydrogen, is always going to be more expensive than the renewable energy used to produce it. So it's better to use that renewable electricity directly into the system. The exceptions are where you've got high temperature processes that require a fuel like hydrogen, where you've got heavy vehicles, for example, or indeed in interseasonal storage of electricity from summer to winter, where that is appropriate. But I would guard against, for example, the other colours of hydrogen, the blues and the purples, because effectively they're fossil fuel produced hydrogen, and once you've invested in that, it will actually cause a delay in the introduction of green hydrogen because of the sunk costs. So making investment decisions, and hydrogen is one good example there, is complicated. It's often prevented by incumbents in a market, so market pressures don't work. So the technological solutions exist, but the market and regulatory challenges in introducing them are considerable. Thank you very much, ladies and gentlemen. Thank you.
Thank you very much, Professor Norton. Dr. Toucan, the floor is yours.
It's not projected. Okay. Good morning, ladies and gentlemen. In my presentation today, I will highlight the role of nuclear energy in mitigating strategies and challenges. I'll first touch upon basically the global scene, and I will focus in this presentation on fission, nuclear fission technology, though today tens of billions of US dollars are being invested in the development of nuclear fusion. Well, it's a human dream that has been pursued for the last 60 plus years, where you are able to fuse two light nuclei to produce big amounts of energy without waste. Now, on the global scene, definitely, there is a shift towards nuclear. Though nuclear was pushed aside over the last decade, there was a lot of investment in solar and wind came up. Nuclear was put aside because of Fukushima. But in the last few years, nuclear is back on the scene globally, and also there is a lot of activity in this part of the world on nuclear. So when it comes to nuclear, the most important development is that 22 countries have joined the declaration to triple nuclear energy by 2050 in order to basically keep the 1.5 degrees centigrade goal within reach. The United Kingdom has released a roadmap to quadruple nuclear energy capacity by 2050. France plans to construct 14 new nuclear power reactors. And Japan, which has really been hit severely by Fukushima, has adopted a plan to maximize use of nuclear energy and to extend the operation of existing nuclear power reactors and replace about 20 reactors with new advanced ones. Definitely, nuclear energy is now considered green. Even the EU, the European Union, which didn't even consider nuclear energy as green lately, and to be frank, after the Ukraine-Russia war, the EU adopted and has considered nuclear energy as a clean energy. Definitely, when you compare nuclear energy emissions, carbon CO2 emissions equivalent per kilowatt hour, it's among the lowest, where wind is even the lowest. But when you compare it to fossil fuels, liquefied natural gas, biomass firing, natural gas, it's way below that. Now, somebody might say, well, okay, you are mitigating CO2, but what about nuclear waste? What about nuclear waste for fission? Definitely, this is still environmentally for challenge that has to be addressed. It is being addressed with new types of fuel that are being investigated and tried. And by all accounts, as I have mentioned, nuclear fusion will, hopefully, in a few decades' time, will be a new source of clean nuclear energy without waste. So the current global status of nuclear power, you see that there are around 440 operating reactors producing around 390 gigawatts of electricity, but reactors under construction are around 59 gigawatt of electricity. So it's really a big portion, and the major activity taking place for nuclear construction, probably, as you might guess, is China. However, countries like India, Russia, even some countries in Latin America. So basically, it's taking place, this major nuclear construction is taking part in the eastern part of the globe and the south, maybe not so much in the Western countries, except maybe for France and UK, who have really now invigorated their nuclear power plants. In our part of the world, the nuclear activity is coming up. There are 6.5 gigawatt electrical operating reactors. 5 of them, mainly in UAE, United Arab Emirates, has now 4 nuclear power plants, each of 1,400 megawatts electrical built through basically a contract with the Korean Electric Power Company. And there is one reactor in Iran, Bushehr. However, there are 9 reactors under construction, mainly in Turkey and Egypt. Turkey is constructing 4 nuclear power plants, each 1,200 megawatts each with Rosatom, and Egypt is constructing also 4 additional nuclear power plants through a contract with Rosatom. And some of these plants, particularly in Turkey or Egypt, they will be coming into operation in 2 to 3 years' time. Jordan and Saudi are planning, and for sure, Saudi has announced plans to construct 16 new nuclear power plants. I will touch now upon the case of Jordan, my country. What are we doing with nuclear? We have launched a comprehensive nuclear energy program. Since 2008, we have an operating research reactor that's now heavily involved in producing medical radioisotopes and some radioisotopes used for non-destructive testing in the industry, and very soon we'll be going through new transportation doping. We have actually Sesame, the synchrotron light for experimental science and applications in the Middle East, which is an operating electron accelerator, accelerating electrons to 2.5 giga-electron volt. Cyprus is a very active member of this center, in addition to 8 countries in the region. We have a lot of uranium resources in the southern part of Jordan, where we have been extensively using and exploring these resources as a potential nuclear fuel supply. And all of that aiming at establishing strong pillars for building nuclear power plants, either for electricity generation or water desalination. Our requirement for a nuclear power plant project is that it has to be low capital cost, and that's why we are moving away from construction of big nuclear power plants to small modular reactors, SMRs, low cooling water requirements, as everybody knows, and we have some of you, our participants have mentioned. We have low, very small quantities of water, so we are aiming for small modular reactors, gas-cooled reactors, which don't need big quantities of water for cooling. And these small modular reactors are compatible with the small electricity grid and scalable to match the gradual increase in electricity demand. And we want to deploy them beyond 2030, where we have now the plans to fill in some of the gaps that will come in the next decade. So for us, actually, nuclear power will contribute to the sustainability of both the energy and water sectors in Jordan. We import most of our energy demand from outside, except for solar power and wind power, which has grown up in Jordan over the last decade. And we believe that introducing a nuclear component also will basically enforce the sustainability of both the energy and water sectors in terms of providing us for security of supply, particularly with the abundance of uranium resources in Jordan, economic feasibility, and less CO2 emissions. We are focusing on small modular reactors, basically for their small size and mass modularity. So rather than basically projecting 1,200 or 1,400 megawatt electricity, you can build them in modules of 100 megawatts, 100 megawatts. Some of them, actually, you can build them at 60 megawatts per plant. So you can start building these in modular units, one by one, or typically they are built as twin units, and then you can basically build more as your energy demand more. They have now, with new advanced generation 4 reactors, passive and inherent safety features, lower requirements of cooling water. This is very important. So we shifted away from big plants and going to small modular reactors. You need around 3 million cubic meters per annum to cool such plants. And as I have mentioned, there are designs now that are operational, particularly in China, the high-temperature gas-cooled reactor, which is among the first in the world to really deploy Gen 4 reactors, which is cooled by helium gas and uses very small quantities of water for cooling, economies of production, faster deployment time, and in-situ decommissioning. We have actually looked within the Atomic Commission deploying small modular reactors for our national water conveyance system, which basically aims at desalinating water in the Gulf of Aqaba further in the south. What we have envisioned is to build 3 units, 3 modular reactors in north of Aqaba. This will be the main source of power for water desalination that will feed the reverse osmosis plant and at the same time pump the water around approximately 300 kilometers to Amman. So our national water conveyance system aims at producing 300 million cubic meters per annum, pump water over 450 kilometers. Currently the government is trying to do that. They are looking at different options for energy supply. Actually, we have done our feasibility study for the, providing the main energy source for this national conveyance system through small modular reactors, 3 units. And basically, we have found actually that this providing fresh water to the capital will be very competitive. We can produce it or provide it to the capital at $1.64 US per cubic meter compared to more than $2.5 per cubic meter using other resources. What also is very important for nuclear is that these nuclear power plants live for 60 years. So this investment, your capex that you are investing, and we are talking about here a total of about $1.7 billion US, will live for you for 60 years compared to conventional power sources that will last 20 to 30 years. So in total, definitely, nuclear energy is coming to the global scene as part of climate change mitigation. Currently, the technologies that are developed is fission, but for sure, nuclear fusion will come into the scene probably, it's expected by the mid-2045, hopefully, with the new achievements that has been reported recently. Thank you all.
Thank you all very much. Although we are running out of time, we will accept 2 questions from the audience. So I will open the floor for questions. Please state your name, your affiliation, and as well as to whom of the panelists your question is directed to. Please.
Thank you. Yeah, Manfred Lange, Cyprus Institute. Professor Toucan, thank you very much for your presentation. 2 questions. One, the specific CO2 emissions that you illustrated, to what extent for the nuclear does that include the whole life cycle of nuclear power? Second question, with regard to desalination, have you envisioned, have you planned, have you realized using renewables for desalination rather than other sources of energy? Thank you.
Yes. Yeah. Yes, actually the government has looked at renewables, but surprisingly, actually introducing renewables into desalination has increased the cost. I mean, for sure, you know, because renewables are intermittent, so you cannot run an RO plant based on solar. And actually, the EU actually is one of the main providers for financing for this national conveyance system. So talking to the Minister of Water, forcing solar into the project have increased the cost rather than helping it reduce. For sure, if you just want to introduce it for cleaner energy, that's correct. But the overall effect was to increase. And you know, for RO, you cannot run an RO plant on solar, so you have to have continuous operation. This is one. Now, the figure I showed is actually one of the references. If you want to if I understand you correctly, I mean, for sure, during operation, you are not emitting CO2. But if you want to mention the CO2 emissions, if nuclear waste is treated, or probably, yes, definitely that might be the case. But for sure, I think when it comes to dealing with nuclear waste, for sure, it will not be a chemical process that will produce CO2. The challenge, the real technological challenge, is how do you deactivate these long-lived isotopes, which hopefully will come through a nuclear technique, not through a chemical technique. But the figures I got, to be correct, they don't include CO2 figures for dealing with nuclear waste. These are more of the operational. The figures for producing the nuclear fuel and during operation.
Yes, one more question, please. Yes.
Yes, Kamal Araj from Jordan. Actually, the Professor Dali, the question for him. I mean, you talked about being technology agnostics. I don't know how you could be that in that particular thing. I mean, the European Union actually are not technology agnostics, though they do classify technology based on their ethical values. For example, I detest actually the way they characterize nuclear energy as being, not green, So the energy, what you produce from hydrogen, they wouldn't call from nuclear green. But anyway, we are in different region here, and I hope we do treat the criteria much more technology agnostics, as you said. But being technology agnostics, I mean, in terms of renewable, I think there is a big hype about renewable. Definitely we need renewable, but you said I was really surprised with the life cycle costs and the impact actually of this lithium ion and all these that we are really going into energy storage, a big amount. We're talking about gigawatt here. I understand the impact on the climate and also on the environment for that. So to be clear, now talking on the Middle East, actually in terms of technology specific, I mean, we need to put a cap actually rather than being just, reduction in the energy, in the CO2 emission. For example, if you actually burn all the natural gas in the Middle East, how many parts per million will you actually increase? Burn all the oil, actually, in a way. But I think the major culprit is the coal, and nobody talks about the coal. Anyway, I think that should be complete ban of coal use in the world. But I'm just being your chemical expertise here, ask you on the question, can you actually convert the stranded additives in Saudi Arabia, Emirates, and Qatar into e-liquids or synthetic liquids that actually can put a cap on the CO2 emissions, actually, if they do that?
Thank you for the question. Let me just put a little bit of context. We procrastinated about doing something about the environment for so long, and then we were trying to put the whole solution within 20 plus years. So everybody talks about 2050, and we are now 2024. So then what governments wanted to do is to find quick solutions, and these quick solutions, let's put PVs in, let's drive electric cars and so on, and the EU is leading the way. There's a problem with the EU. Sorry, guys. I think that you think you're the center of the world. Not anymore. It's the Asian century. Whatever happens in EU is important, but it's not that important. It's really what happens in China is what's important, in India, in Indonesia. These countries actually are making a lot. And the presentations in previous session shows what this region is also contributing and how it's going to become important. Now, let then address is basically what is technology agnostics mean, and how does it relate what governments are legislating. Now, most of the focus currently of the governments is on power generation. Very little is done about everything else. In fact, they see transport as a secondary that comes after we decarbonize the network. And hence, when it comes to power, there is a balance of the voltage, there is a balance of the frequency, there is a firm supply, there is seasonal variations, there's intermittent renewables and so on, yeah? So then within that context, yes, the regulator or the operator of the network says, I need spinning reserve. I cannot get your frequency right without some machine turning. And hence, I need at least 20% to be of this form as compared to this form, okay? Now, that's fantastic. So within that, okay, what type of PV cell do we use? Okay, well, we need to be selective. Does this PV can we recycle this PV? And so on. Now let me address the stranded assets type problem. There is a problem. There is trillions of dollars worth of assets today that are emitting a lot of CO2, and that's not going to change for the next 20, 30 years. These people, whoever done the investments and put billions of dollars in, they're not going to shut it down tomorrow unless they're forced to do it. But also you need an alternative, yeah? So now, then you have to think about innovative ways by which, I'm working with Aramco, for example, who have a plan to decarbonize their operations by 2035, I think. They're coming to me and says, we have plenty of hydrogen on site that we could use instead of burning fossil fuels. Can we inject this hydrogen into our current operations and reduce the amount of fossil fuels we're burning? So the challenge is what the percentage of blending I could do when it's available, such that I reduce the amount of fossil fuels that's been burned. This is not an overall solution. This is a temporary transitional solutions to help get there. Another approach as well. A lot of countries depend on fossil fuels. Saudi Arabia is 72% now dependence on the export of oil. Iraq is 93 or 94. Now, we need to find ways by which this resource that they have can also bring in the revenue. So one aspect in Saudi Arabia that we're looking at is that we're taking this hydrocarbon, we're extracting the hydrogen out, and then trying to valorize the carbon. So as long as, at the end of the day, as long as we guarantee carbon neutrality, okay, we could use the same resource. So we need to move away from either or. If you don't have PV cell, that means you're a climate denier and so on, to how do we get to where we need to go while maintaining sustainability, and that includes environment, economy, and society. So this is the point I was trying to make.
Well, I think it's time to end this session. I'm sure that there are a lot of questions, so you can actually, during the lunch, you can have a discussion concerning this panel. So I will leave you with the next panel, I think concerning the economics of the new technologies. Thank you.
Thank you, Dr. Poulikas, Professor Daly, Professor Norton, and Dr. Toucan. We will now continue with the second panel of this session, entitled The Socioeconomic Barriers to Decarbonizing the Regional Economy. And we now welcome the convener of this panel, Professor Theodoros Zachariadis, Professor and Interim Director of the Energy, Environment, and Water Research Center at the Cyprus Institute.
Well, good morning, everyone. Thanks again for this invitation. Of course, the last panel before the lunch break has to suffer from the accumulated delays, although the panelists have been really on time, so thanks for that. This is our second panel on climate change mitigation. The previous one was on technologies. Now, our title is Socioeconomic Barriers to Decarbonization in East Mediterranean and Middle East. This is very challenging and very difficult. And it is difficult because socioeconomic barriers go deep down in our lifestyles, our food and mobility patterns, our economic structures, and our governance systems. And the region is so diverse, of course, in living standards, natural resources, policies, and political systems, that certainly there are no universal recipes to be applied. Let me remind you that according to the IPCC, solutions must be deployed at unprecedented scale and speed in order to hope to achieve climate stabilization. So in view of the technological solutions outlined in the previous panel, we would like to find out what are the economic, social, and administrative challenges to adopt these solutions at a scale and speed that may allow fast decarbonization. One way to look at the topic is that there may be adequate supply of zero-carbon technologies, as we have heard. But the question is whether we can stimulate the demand and the fast uptake of these technologies. Another way to look at the topic is to ask the questions, are technologies sufficient to attain our sustainability goals, or do we need more fundamental socioeconomic changes? So some relevant aspects that we could touch upon is about the magnitude of investments required in the region, the economic and financial incentives necessary for these investments, or how to deal with policies that run against the green transition, such as fossil fuel subsidies, the administrative and governance challenges, how to overcome informational and behavioral barriers that slow down the uptake of some measures, and last but not least, how to deal with social equity problems of the transition, real ones or perceived ones. So I'm very happy and honored to host three prominent panelists today. Professor Loukas Christoforou, a physicist formerly at Oak Ridge National Laboratory in the University of Tennessee in the United States, a permanent member of the Academy of Athens and chair of the Energy Committee of the Academy of Athens, and a founding member of the Cyprus Academy of Sciences, Letters and Arts. Dr. Manal Shahabi, a development economist and policy advisor, academic at the University of Oxford, at the School of Government, and a senior research associate at the newly established East Mediterranean Program in Oxford, consultant to the IEA and a contributing author to the IPCC Special Report, and a contributor to COP28 issues related to the just transition. And Dr. Charles Elinas, a very experienced professional in the energy field, a former non-resident senior fellow at the Global Energy Center of the Atlantic Council, a former CEO of the Cyprus National Hydrocarbons Company, and for many years a director at a major energy consultancy. So, Professor Christoforou, what would be your first take? I would like to ask you to stay at 5 minutes interventions as the previous panelists, or perhaps precisely 5 minutes if possible, so that we allow for time and we are not too late for lunch.
Thank you so much for the introduction. I have been watching these proceedings for 2 days now, and I was shocked to hear the transition between stating opinions, seeing how they apply, and applying them. So essentially we made progress, but not too much progress. For example, we heard a little bit ago the situation in Jordan and the small reactor. Truly, a small reactor is a good one. Why? Because it consumes little energy. It can be shielded. The apoβλητα, as we call them, you can burn them, or you can hide them somewhere very easily, and you can have adjustment to the reactors. You can have, instead of one, if you need more energy, you can have two, you can have three, and so forth. And you can have more than one, more than a group of them. So we have to be very careful, it seems to me. I may be wrong, but it is important to be careful how we use these new tools to satisfy the needs of humanity. And these are new tools depending upon ourselves, upon our technology that we are using, and about the efficiency with which we are applying the technology we are using. So, going back to the suggestion that I was supposed to talk about, the decarbonization. I don't know if you know, but each one of us is full of carbon. That's a part of life. So we better look at decarbonization with a little bit of care. So decarbonization, therefore, is very important, not only to see to it how we humans are using carbon to survive, to have a good life, to have life itself, and how we use it to help ourselves in the process of decarbonizing the things that we want to decarbonize. Decarbonization is very important, and we need to do as much as we can. And also we need to save especially some kinds of transportation. The transportation on Cyprus, for example. We used to have on Cyprus a train. We don't have a train anymore. Why? We have all combustion engines. Combustion engines use usual carbon-made fuels. Why do we do that? Because we haven't been thinking about the problem. We need to think about the problem, and we need to go back to trains again. Why not? Trains belong to every country. So they belong to Cyprus as well. Sorry for saying these things the way I do, but it's important to keep in mind the options that a given country does have in front of her, and therefore is capable of applying them as it proceeds. Now, Cyprus is also a very rich country in APE, as we call it in Greece. APE, renewable energy sources. We have sun and we have air. Let's use it. But to use APE effectively, we have to be careful, we have to be smart, and we need to have storage. Without storage, there is no APE. And we can, if we have storage, if we have a store that we can store the energy that we get from APE, we can use them anytime we want to. But why do I say all of these things? These are all known to you, and also the people that will come to this podium, they will follow up more on the issue. Thank you.
Thank you very much. Thank you, and you touched upon some different policy, governance, and lifestyle issues. You gave some hints, and thank you very much for that. So, Dr. Shahabi, what would be your take? You may sit there, you may stand here, whatever you like. Okay, great. Thank you.
Good morning, everybody, and thank you for the invitation. It's a pleasure to be here with you this morning. So I think the stage has already been set about really the importance of advancing mitigation, but there are indeed and of course adaptation, but we're focusing on mitigation here. There are indeed substantial regulatory, administrative, and socioeconomic challenges in the region, and I'd like to give you my take on the three main ones currently that are a problem. I think the first one is definitely an issue of finance, the large cost of decarbonization in a region where it's very fossil fuel dependent, but also a region that is becoming poorer. So if we look at governments in general, governments continue, in our consumption, we're obviously one of the most dependent on fossil fuel, despite some major advancements in Jordan, Cyprus, even Egypt and Morocco, et cetera. But in general, we're still very dependent on consumption on fossil fuels. Governments that export oil and gas continue to want to need that, or want to rely on that continuously through even carbon capture, which is still very expensive and takes, at the moment, is not very viable. Then you have importing economies that also either spend a lot of money on natural fossil fuels, sometimes subsidies, but also have a lot of labor who's working in oil exporting economies. And then there are other countries like here in the Eastern Mediterranean that are really interested in exporting the existing gas before we're not able to use it anymore. So we're still really looking at fossil fuel as the main driver of revenue. So decarbonization projects that are really announced are mostly focusing on expanding the export base, not really on decarbonizing the local economy. So from a government perspective, there's a budgetary constraint, of course. If we look at this from an industry perspective, industries are saying, for us to decarbonize, we need more incentives, we need, of course, a lot of subsidies, but these subsidies, in a constrained fiscal space, take money that otherwise would go for development. So there's a major trade-off as well. And if you look at consumers, here is really where we see massive problems and inequities as well. This region is the only region in the world that in the last decade, poverty rates have increased, including in places like rich oil exporting Bahrain, where there's 1 out of 13 who are now currently under poverty line. So, and then if you look also at the cost of energy that's coming from renewables, it's more expensive than fossil fuels. So then that makes adaptability and acceptance of fossil fuel, of renewables, obviously, and decarbonization a problem. And then again, it puts pressure on the system. How do we then ensure that there are equities in this? Because obviously social inequities as well are increasing conflict and also instability. And we see that even in areas where there's innovative solutions. For example, in Lebanon, where there's substantial energy poverty, as you know, people use solar powers over the roof, but if you can't afford it, you can't get it. So there is still within an energy access problem, energy poverty, and then obviously the equality situation here that is still an impediment. The second challenge I'd like to talk about is really more on the environment. I think decarbonization plans in the region generally simply do not prioritize the environment. And today, this morning, when the minister here was talking about her plan, energy and climate, the National Energy and Climate Plan, I was really quite happy to hear that Cyprus has merged both, because across the region, generally, there's a silo. Energy policies under an energy ministry, climate policies under a climate ministry, and they don't talk to each other. And then what that means is a lot of the decarbonization effort really has harm on the environment. And I'd like to give you just 3 examples of that. So large expansion of renewable energy in North Africa, for example, has displaced people from farming land, and that obviously has harms to the environment, but also impacts on the people. If you look at the big advancements, or maybe the potential, the hype, as we have talked about, of green hydrogen, whether it's in the Gulf where very rich economies but very water poor, or even poorer economies like Jordan that are also very water poor, there is also a major harm to the environment. And my concern here particularly is also on water, because 14 out of the 17 poorest water countries in the world are in the region. And if I can pick on Jordan as an example, it's not the only one, but as an example, green hydrogen plants are basically competing with the water that would be available for people basically to drink and for farming, which is already very low. So that is a major conflict that there is. And the third example here as well is basically on desalination, also related to water. Because desalination is either very emission intensive, if it's fossil fuel based, of course, very energy intensive, and not enough examples like the SMR in the case of Jordan that could be deployed in a way that could really expand benefit at multiple layers. But also desalination has products that are dumped in the water. It's brine solutions that are actually very harmful, and that has, if you look at the Gulf region, the Persian, Arabian Gulf, however you want to call it, you can see impacts of that very directly on even the fisheries, on the aquifers. All of that is actually still a problem. And then, of course, there's the issue of carbon capture, which has a financial cost as well. I am being pointed to time, which gladly I am moving to my third point, which is that, in my opinion, decarbonization and energy, whatever energy policy we have in the region, which is questionable in some parts, but basically I think they just do not consider socioeconomic impacts. So His Royal Highness Prince Hassan this morning said that social impacts are not considered, also economic impacts are not considered. And part of this is an issue of the silos, just as in the energy and the climate world. So policy makers operate in silos, but also the issue of data. And we heard in the morning about pollution data not being accessible. Also, economic data are also difficult to get in the region, and I can tell you that of myself as an economist who speaks languages of the region and still finds it very difficult to access that data. And here I just want to give examples of 3 very quick issues where basically also the socioeconomic impacts are harmed by potential decarbonization. The first one has been talked about already, but important to remind you of transportation. So transportation, we don't see a huge focus of decarbonizing public transportation so that it's affordable, clean, and also accessible for millions. I think, yes, the number was about 900 million people in the region who live in urban cities. The second example is on jobs. And here we're looking at a region where it's probably one of the youngest regions globally. the focus has been on industries that have been able to show job creation. Green Industries has announced that in the region by about 2050 there will be 10 million jobs, and they're able to get subsidies and all sorts of support for that. That's fantastic. But the region actually needs 300 million, not 10, 300 million jobs by 2050. So then there is a need then to incorporate the decarbonization of the current systems really with the larger value chain, but also focus on other industries that are job creating, and of course link that to education, et cetera. And the final bit is really energy policy is very male dominant. People like me, gender issues, it's very basically, the gender inequities are massive in the energy policy in the region, including in the green energy policy. So these are my main really challenges there. So just for you, your final takeaways basically. The first one is the massive financial trade-off. So we need to focus on energy that is clean, affordable, and accessible. The second one is energy and decarbonization plans should not harm the environment. And the third one is energy policy needs to become more inclusive, needs to be more integrative, and also focus on economic development. Thank you all very much.
Thank you very much, yes, for this very wide-ranging overview of several socioeconomic aspects. They are numerous, but you touched upon many of them. Dr. Elinas, again. Yes. Thank you.
Well, most of this conference has concentrated on the climate change and ways to mitigate it. But in the region, there are many barriers to it, practical barriers to it, common barriers to change towards decarbonization of regional economies. More specifically applicable to the East Med include government systems not up to managing the task, lack of capital investment in new systems to mitigate it, competing priorities of energy investors and players in the region, putting priority over financial returns ahead of environment and sustainability. Having said that, MA is a very diverse region to generalize on the barriers to decarbonization. I will make my points by concentrating on the East Med, and particularly on Egypt, the most populous country in the region, and Cyprus, where we are now, and the only member state of the EU from the region. So what about Egypt? According to international economic indices, Egypt's economy is considered to be repressed. Egypt is struggling with a prolonged economic crisis made worse by chronic foreign currency shortages, with reserves barely enough to feed its people for 4 months. Another challenge is its increase. I mean, the national debt is $160 billion. Another challenge, it is the increasing population, now at 116 million, and still increasing by 1.6% per year, putting more pressure on the country's beleaguered economy and growing energy needs. These are the main barriers making it difficult for the country to tackle climate change. To do that, it needs external investment. This is trickling in, but not at the level is required to make a serious difference. In 2023, wind and solar provided only 5% of Egypt's primary energy mix. And this has been increasing over the years, but at a very slow rate. This was dominated by Egypt's primary energy mix. It was dominated by hydrocarbon fuels, especially gas, with an 85% contribution, even though its target is to achieve 42% renewables by 2035. Based on current performance, it looks highly unlikely. Egypt relies heavily on natural gas or power generation, but it has been unable to maintain payments to international gas companies. It owes them over $5 billion. In turn, they have not been investing in new exploration and production, with Egypt seeing a rapid decline in gas production, down 30% over the last 3 years, and still declining. This year, the country was forced to go back to LNG imports with a devastating impact on its balance of payments. Not only it has lost the ability to export LNG that earn foreign currency, but it has to pay for expensive imports with foreign currency that is in short supply. For that, it has gone back to IMF and its rich Arab neighbors for help. On top of that, there are fuel subsidies. Gas and electricity are too expensive. Egyptians cannot afford it, but they cannot get out of it. If they stop the subsidies, they will have a revolution. And they cannot do it because renewables are not increasing that fast. The country has become even more reliant on Israeli gas, with all the political implications that brings, given the Gaza and now possibly the Lebanon wars. In fact, Israel has just sanctioned new projects to increase gas exports to Egypt from 10 billion cubic meters a year now to double that, 21 billion cubic meters per year by 2028. This is about a third of the gas consumption of the country, making Egypt highly dependent on Israel for its energy. Egypt has ambitious plans, with abundant solar and wind potential, turning to renewables as fast as possible may be the answer. But the 3 points I raised at the beginning make it that a big challenge. Egypt has ambitious plans for future decarbonization, but these have to wait, I'm afraid. The most populous country in ME, by far, is in a chronic survival mode, and getting out of that is its top priority. What about Cyprus then? Cyprus has none of Egypt's problems. It is doing well economically. It is a member of the EU with all the benefits and systems it brings, with little stopping it from becoming a leader in decarbonization as Greece is doing right now. But it is not happening. Per capita emissions, in terms of per capita emissions, Cyprus is at the top of Europe. So what has gone wrong? Electricity production from renewable sources was about 18% in 2023, in comparison to over 50% in Europe. The independence of Europe's electricity generation of fossil fuels has been reduced to 27%. In Cyprus, it is still 80% and not really going down. Even Netherlands, where I lived until recently, with less than a third of Cyprus' solar density, is doing better in solar than Cyprus is. Inexcusable. Unfortunately, ambition remains low. At present, the target for renewables by 2030 is to go from 18% to 23%. Only half of Europe, not really ambitious. The greatest challenges are limited capacity in the transmission and distribution network, lack of battery storage, and electricity interconnection with Europe. Without major change, these will continue to limit a significant increase in renewables in the foreseeable future. Cyprus has more than 400 billion cubic meters of natural gas reserves, but developing it is not profitable enough and not a priority for the oil companies. So it's not happening, let alone bringing it to the island. Its project to import LNG has been mired by endemic corruption and government systems not up to managing the task. And yet, using gas to generate electricity could have advanced energy transition at a stroke by slashing emissions by 30% and bringing electricity prices down by over a third. But we're not doing it. We know about it, we're not achieving it. The interconnector between Cyprus and Crete is on the verge of final approval, but it will not be operational until 2030 at the earliest. In the meanwhile, the greatest hope to reduce emissions lies in the import of LNG to replace heavy fuel oil and diesel in power generation, and more rooftop solar. The latter got a boost earlier in the year and was a great success, but it requires grid upgrading to take off. The headline on Monday was that the villagers around the Gaia, not far from here, around the Gaia's power plant, are drowning in pollution because Cyprus continues to use a highly outdated and inefficient plant to generate electricity. This is symptomatic of what is going wrong in Cyprus' energy sector. We have known about this and what needs to be done for years, but we still carry on paying huge fines for high emissions, and we are stuck in a talking mode while the problem remains unresolved. In Cyprus, big renewable projects, especially solar, have gone astray. They are mostly owned by independent private producers that more or less operate as a cartel, keeping prices high, very high. Electricity market liberalization could help if it comes and if it is truly liberal. Cyprus Energy Minister seems to have recognized the problems with the current electricity system. It is urgent to speed up the implementation of the required measures to address them so that the adoption of renewables, especially rooftop solar, and upgrading of the grid continue at a rapid pace. We need to do that. So what are the challenges? The challenges to decarbonizing the regional economies were clear from the Med9 meeting that preceded this conference in Larnaca earlier this week. The participating energy ministers reiterated their ambitious vision for transforming the Mediterranean region into a renewable energy hub and green energy development corridor. They reaffirmed their commitment to support the promotion of a sustainable, secure, and resilient future for the Med region and declare their intention to continue cooperation in order to lay the foundations for the provision of secure and affordable clean energy in the region. I read what they said. All the right words, but for the participating MEC countries, not much different from last year, and the year before that, and the year before that. We keep talking about this. We say the right words, we don't implement them. The ambition is there, but delivering it requires overcoming the barriers to decarbonization I talked about. Progress is being made, but it is slow, demonstrating how difficult the task is. So what is the answer for the from the Med9 energy ministers? Interesting. They decided to consider conducting a new, updated, in-depth study adapted to the requirements of the region and its energy vision, possibly financed by member states on a voluntary basis. I'm not sure what this means and practically, and where it takes the MEC countries. I don't think it takes them anywhere. Probably not much further forward for a while yet, but at least they are requesting the support and involvement of the European Commission for the possible conduct of the study. Concluding, in addition to talking about mitigation and adaptation measures, we must concentrate on removing the barriers to decarbonization in the region. Thank you.
Thank you. Thank you very much. Thank you very much. With these case studies, I guess you pointed to the issue of implementation, to the issue of long-term planning and coherent planning, which is a matter of policy and a matter of governance. So we have heard about lifestyles, policy, poverty, governance. I think in the interest of time, let's take up to 2 questions, fast questions if possible, and please introduce yourselves and say whom you are asking this question. Yes, please.
Hello.
Okay. It's this lady, sorry, and then the gentleman back there. Okay, these 2 questions. Okay.
Hello, my name is Miriam Brusilovsky, and I am the president of the Israel Desalination Society. Just a small comment. People usually talk about the desalination as a harmful technology, and I would like to correct this view. As in the Mediterranean area, also in Cyprus, in Israel, we are using seawater desalination for the social and economical development of our countries. I think we need to know the facts. So desalination is producing a more concentrated, salt-concentrated stream that is discharged to the sea in a very responsible way by mixing it with the area and applying regulations that allow the monitoring of the health of the marine habitat. We are able, at least in Israel, to see during 20 years of desalination that are providing 80% of the domestic water consumption in the country, that our cost is healthy, and as the definition of sustainability, we have to balance between the use of our natural resources and the benefits for the social economical values for our generation and the future ones.
Okay.
Thank you.
Thank you very much. I guess the question, if you can send the microphone to the gentleman back there. And the question, I mean, your comment or question is probably to Dr. Shahabi. So if you want to comment. Yeah, please.
Sure. Thank you so much for that. And absolutely, the technology varies. Not every country, as you know, uses the exact same technology for desalination. And there are better technologies that are more expensive as well. So there are levels of that. And the example I gave is also based on facts. And there's also scientific research that show that in the Gulf, for example, the salinity level increases beyond what is needed because it's not enough time for the ocean or for the Gulf itself. And that's different than the Mediterranean because of openness, because you're more open than a small Gulf. So the point here is not to say desalination in itself is harmful, but it can be harmful indeed if it's not used correctly, and there are improvements in the technology. And the better technology is also more expensive. Israel has advantage also of using recycled water system, wastewater, which is very good, and that also gives you an advantage there, but that doesn't mean that it's as well, equally well in the region. So that is the comment I would say. And then you mentioned one word that I think is key also in the use of desalination. You said you have regulation that measures, and that is going to be key, that if we absolutely need desalination. I'm not against it at all. But it has to be coupled with the right technology, which can be costly, also with the right energy that produces it so that we don't produce more emissions, and then, of course, with regulation on the environment.
Thank you very much, Dr. Shahabi. So the last question, please, if possible, a question and fast.
Okay. Hello. First, I would like to thank all the panels for all the great information they gave us. But my question concerns another topic, maybe slightly different. According to National Geographic, 3 billion people globally are using solid fuels for their cooking needs, with huge amounts of CO2 and deforestation. Also, according to the WHO, 4 million people are dying every year because of the toxic gases, because of the cooking. So my question is, do you have any scientific data concerning this amount of CO2 emissions? And second, what are your suggestions to solve this problem? Thank you.
Thank you. I think this was addressed a little bit in the first panel of the scientific basis about the black smoke. Of course, it touches upon energy poverty and the emissions. Is there any reaction? I mean, do you have any? About the amount of CO2 emissions, and because of the burning of coal by poor people, and of course, the health impacts. If there is some information on that. Yes, the issue is eradication of energy poverty, yes.
So I hope I didn't hear the earlier part of your question, so I apologize if I'm not answering it collectively. We know that energy poverty exists but varies within different regions, of course, right? So there's about 2 billion people in the world who don't have access to clean cooking fuel, mostly in Africa, followed by Asia. In terms of, I think there's about also 2+ million people with basic electricity needs that they're just not existent. I think in terms of, I think your question was on burning coal and maybe other issues. Based on the knowledge I know and the facts that I know, there is some data on some of the burning of that, but not all. A lot of the people, a lot of the rural areas tend to also be where a lot of that burning is happening, basically in small spaces rather than, you know, a big coal plant. More data exists on what the emissions are coming out of the larger plants rather than basically what you know, people in rural Africa or in some rural part of the region might be emitting in terms of burning. However, the extent of energy poverty is big, but the extent of the emissions that are coming out of people in energy poverty who are using alternative burning fuel is actually not that big. The bigger emitter are the larger industries, and I think you mentioned coal, really the larger coal plants more than that. So I think that was the first part of your question. Was there another part of the question? Does that answer you?
Yes, there is more information. No, please, we don't have time for that. You can also interact because in the interest of the lunch break. As I said, the colleagues who reported on the scientific basis in the morning, for example, Professor Jos Lelyveld, who was here, have these reports with with specific estimations of the amount of emissions and the health impacts on this. So.
Just to say, if I'm wrong on some of my statistics, I'll correct them afterwards, but
yes,
happy to discuss as well after for any other questions.
That's why we're here. So thanks very much to our panelists and enjoy your lunch.
Thank you, Professor Zachariadis, Professor Christoforou, Dr. Elinas, and Dr. Shehavi. We will now take a break for lunch. Please make sure you're back in time for our afternoon session, which will start at 1:30. Thank you. Welcome back. We will now continue with session 3, during which our distinguished invitees will discuss the impacts of climate change as well as adaptation pathways. We now welcome the convener of the first panel of this session, Professor Fatih Komer, Professor of the Energy, Environment and Water Research Center at the Cyprus Institute, for the panel discussion on the water-food migration nexus.
Thank you so much, Christiana, for this introduction. Good afternoon, ladies and gentlemen, dear colleague, esteemed guest. It's an honor to convene this panel on the critical subject of the nexus, water, food, and migration within the Eastern Mediterranean and Middle Eastern countries. As we know, we have a lot of challenges that we need to overcome. The first challenge is the challenge of climate change, which impact directly migration, which impact also the water, the energy. It will impact the nexus. And we have seen from our speaker in the morning, our scientists at CYI, and other prominent academia, how climate change and atmospheric pollution will impact our life and our existence in the EMI countries. So let's hope for the best, and let's hope that our politicians who are gathered today in the United Nations in New York thinks about implementing sustainable peace. We as scientists, we always, thank you so much, thank you. We as scientists, we always speak about peace. When I started with the concept of hydrodiplomacy more than 20 years ago, they always says, why Fatih Komer is talking about the peace around water? Well, the answer was that water is the link, is the connector. Water is a connector for energy, water is a connector for the food security, water is a connector among all the human beings. Disregard their religion, disregard their ethnics, disregard anything. And I remember that one day in the Water Symposium of Cannes, after the Festival of Cinema, we used to organize a water symposium with the University of Nice. I organized a panel on water and the monotheistic religion. They were the Grand Rabbin of France, they were the Recteur de la Grande Mosquée of Paris, and the Archbishop of Beirut. And it was a real success, and this panel was moderated by a former Minister of Culture in France, Jean-François Mattei. So I hope that we could overcome all these aspects of challenges by dealing with water through the peace sustainability. Today, ladies and gentlemen, in my panel, I have prominent leaders, prominent water experts, prominent nexus experts, environmental experts. Let me first of all present our colleague, Mr. Jacob Westlander. Mr. Jacob Westlander is the special envoy of the government of the Netherlands for water, energy, food. So he's the special envoy for Wi-Fi. I wish each country could nominate a special envoy for Wi-Fi, because Wi-Fi is an essential subject for our human existence. So Jacob we will talk about all these issues at the Mediterranean and international level, since he is a leader in his subject, and since that he has a wide experience as an expert at the World Bank, one of the senior also administrator of IWRA, and now actually he works at the MENA region, Middle East and North Africa, with all the embassies of the Netherlands. He's based in Jordan, he worked with Lebanon, he worked with all the countries of the Middle East. Our thought goes today, while we are speaking about peace, our thought goes to Lebanon, to Palestine, who are suffering a lot, and we will have another prominent leader, Minister Nasser Yassin from Lebanon, Minister of Environment, who will join us also by Zoom in order to speak about the challenges of migration in Lebanon, the challenge of Wi-Fi in Lebanon. And we have a prominent expert, Minister Hassan Janabi. He was the Minister of Water Resources and Irrigation in Iraq, several time ambassador. And with Minister Janabi, we had the chance to organize with my dear colleague who visited CYI 2 times, Senator Olivier Cadic, the French Senator of Overseas. We have organized several initiatives at the French Senate where we have gathered the minister in charge of the Jordan River Basin, riparian countries, the Orontes River Basin, and the Tigris and Euphrates, and Minister Janabi was with us at the French Senate under the support of Olivier Cadic, our senator, 2 times in France. So thank you so much for your presence. Let me first start with Mr. Jacob Waslander, since he has to leave in 20 minutes, by the first question. So Jacob, as you have handled these subjects since a couple of years, I think, in the MENA region, could you kindly give us the key challenges, but also the opportunity? Because we need to speak about the opportunity in order to implement the concept of Wi-Fi in the region, and also to start thinking about the Wi-Fi security in the region, because we are greatly impacted, as Professor Papanikolaou said his opening speech, will be impacted in this region as a hotspot through water, through energy, through food security. Thank you, Jacob. You can use the microphone.
Thank you, Fadi, and thank you for inviting me. And it's really a privilege to be in such an esteemed panel with Minister Janabi and Minister Yassin. So thank you. You know, as an envoy for the Middle East and North Africa, I travel across all those countries. I work with the governments, but also with what we call Track 2, so NGOs, academia, with companies, to see how those scarce resources, water, energy and food, and environment, can be best and most optimal way be used. What, first of all, is key is to realize that those are interlinked. In the end, here in the Middle East, water scarcity is, I think, the main challenge, but it drives also energy production and consumption, and also the food production. 80% of the water in the Middle East and North Africa goes to food production, so it's very much interlinked. And the second point is that in the Dutch view, there is ample potential for this region to take its responsibility and to improve lives and livelihood here in the region. And that's where we should support. So that is our main approach. And the last point I want to drive home is, in our view, developments around water, energy, food, and environment should be data-driven. And for some of you here in the scientific world, that may sound like an open door, but I feel that in my connections with counterparts, it's not always evident. And this morning it was also mentioned that data are not often entirely reliable or accessible. And what I try to drive home is you need your data. You need to analyze them. You need to develop scenarios and communicate. And communicate with a farmer association is different than communicate with a parliamentary delegation. So you need to make clear to people what type of choices and trade-offs have to be made. And that is, I find, the core of my current job. Back to you.
Thank you so much, Jacob, for this clarification. Very important for us. Since we need, as you have said, data, we need to launch project together in this subject. how can the Netherlands and you as special envoy help in implementing the policies of the Wi-Fi in the MENA region? It was a big subject that we have debated yesterday, and we need to pass from the sectorial management of water alone, energy alone, and food alone, and of course the ecosystem, towards a global management. So we need policies. How can we help the government of the Eastern Mediterranean, Jordan, Lebanon, Egypt, Palestine, Israel, all those countries to cope with this idea of Nexus? Could the Netherlands help in this?
Well, thank you, Fadi. I think we do, and we currently are actively engaged. We have, of course, a lot of expertise in the domain of food production. This small country, the Netherlands, is worldwide still the #2 food exporter after the United States. People don't know that, but we are so extremely efficient in our food production that we are, after the US, the 2nd world food exporter. As Kofi Annan, the late Secretary General, always said, the Dutch are still a superpower, but that's in the agricultural domain. So that's where we have a lot of knowledge. But we're also lying under sea level in a delta. So also on water management, we have much experience. And our research institutes work with research institutes in this region. And we also have collaboration on governmental level to support the governments here in drafting those policies. But once again, what we always drive home is open up your data, make them available, and first step is really analyze and develop those scenarios. Final point here is the Paris Agreement. We all know there is the objective of mitigating greenhouse gas emissions, and the second one we all know as well, that's adapting to the effects of climate change. What people often forget is there is a third objective, and that is that we have to green or make climate friendly all the financial flows in the world. So it's not only the 100 billion a year which donors have to give to developing nations, but all financial flows should become climate compatible. And that also should play a role in those discussions, because in the end, we must make sure that all those discussions lead to investment plans which are compatible with this third goal of Paris, that it should indeed be compatible with our agreed trajectory towards 2 degrees, preferably 1.5 degrees global warming. So it's about data, and it's about finance, and it's about science. And all the three, we try to support governments and other entities in this region.
Thank you so much, Jacob, for your thoughts about data, about financing, about science. Well, it's a classical methodology. Do we apply this classical methodology when we are in the crisis of migration? And you know that in Jordan, in the Middle East, Lebanon, we are suffering of a big migration which is linked to conflicts. And how can you see that the international organization can help in the migration problem linked to climate change and to the Nexus? Because migration could be either from conflictual situation, and it will be happening in a short time from the climate change impact, also from country to country, seeking water, seeking food, destabilizing the political situation of some country because of the migration. We know in Amman how much they suffer from the water scarcity because of the migration. In Lebanon too. So how can you see the help could come from the international organization concerning the Wi-Fi and the migration situation?
I give you 2 examples. You started about Jordan. Access to data was quite a challenge. When I arrived in Jordan 3 years ago, I thought, let me start with Jordan. That's where I live with my family. And so the first thing I did was asking the government for all water scarcity related data. So groundwater levels, wastewater levels and all those data, and I didn't get them. After much questioning, I got some data. But then I heard, yeah, you know, those data are secret. They're state secret. We can't share them. So what I then did is ask a couple of Dutch science institutions who are working with geospatial data and so on to come to Jordan and give some presentations on, of course, those were not hard data, but based on geospatial analysis, what might be the current water scarcity situation in Jordan. And that helped to convince the counterparts that secrecy of certain data was not helpful, because nowadays you can find the data if you want to. So that's an example where we were trying in a friendly way to tell our counterparts, be open and forthcoming. On security, peace, it's becoming more and more a problem, because water should bind us together, is what you said earlier, but it's also dividing. If there's no water left, it can lead to a lot of struggle. We see it now in Egypt with the mighty river Nile and the Mediterranean and the Red Sea next door. You would think there is plenty of water, but they now also say in Egypt that they have a water scarcity problem. And it goes that far that they are now threatening to take military action regarding Ethiopia in building the upstream dam and filling the lakes. They're also pressing all the members of the Nile Basin Initiative, which is a collaborative effort between 11 riverine states established 40 years ago, to quit the Nile Basin Initiative. And that's where I try now with my team in Cairo to see where we could work with the Egyptian counterparts on a water peace security approach. Make a conflict sensitivity analysis based on water scarcity, and trying to see what kind of perspective we can give to the Egyptians to act in order to address the water scarcity problem in another way than bombing a neighboring state. So how can we find solutions to the increasing water scarcity? So showing a positive agenda to act, and hopefully that can feed into the different stakeholders and also can convince the authorities there to be more forthcoming and thinking out of the box in how to address this, indeed, a real problem for Egypt. So it's just an example, but that's where we try to work with colleagues, counterparts, in helping them to move forward.
Thank you so much, Jacob. Before you leave, just a quick question. Since you have mentioned the problem of the GERD Dam, how the GERD Dam is impacting Sudan, impacting Egypt, especially the High Aswan Dam and the production of energy, we have launched at the Cyprus Institute 2 years ago the Hydro Diplomacy Partnership Program. You know, the hydro diplomacy, it's a concept that I launched personally 20 years ago, following a process starting with the technical, then the institutional, and the political and diplomatic process. So this platform that we have created at the Cyprus Institute, could you, as a special envoy of the Netherlands, help in strengthening the momentum, launching mediation about hydro diplomacy within this program, HPP?
Well, Fadi, you now put me on the spot, but I'm very open to exploring what you bring to the fore, because in the end, what we should do is help the counterparts here in the region in moving forward. It's the future of the people here in the region, and we can help them with shaping that future, but in the end, it's their responsibility. And there is so much knowledge, so much capacity in the Middle East and North Africa, and I think there's also a lot of ambition to really bring more prosperity and moving countries forward. So where we could join forces in helping the counterparts, of course we should do so. And so we certainly will have an additional chat to see how this could work.
Thank you so much for your presence. It's really an honor to have you in this panel, and I know you have a very important commitment, so we will release you to go to your commitment. Thank you so much, Jacob. Thank you. It was a very interesting discussion. As I told you, we have another prominent expert with us, Minister Hassan Janabi, who visited the Cyprus Institute 2 years ago within the program that we have launched, the Hydro Diplomacy Partnership Program. So, Minister Janabi, we are honored to have you with us, and we know that, as I have mentioned, you were very, very active in hydro diplomacy in the MENA region. So allow me to ask you the first question, please, concerning the significance of water diplomacy. Among our audience, we have also prominent expert in water diplomacy, Minister Sharafat Afilal, Her Excellency Secretary General Maysoon Zobi. Is water diplomacy an approach to resolve water-related dispute between countries in the region, and how water diplomacy and hydro diplomacy could really be effective for a win-win situation on the Tigris and Euphrates?
Thank you very much, Dr. Fadi, and please allow me also to extend my sympathy with you and your family and your friends and nation in Lebanon, and also in Palestine. My thoughts are with you all. And thank you for having me. I was supposed to be with you there in the panel, but unfortunately, the recent events prevented me from coming. Yes, absolutely, water diplomacy is a very, very significant approach and a tool available for water diplomat, if you wish, to basically try to resolve issues related to the water. As you know, for example, the Tigris and Euphrates rivers, very ancient rivers and very well known. And what happened, of course, it is contributed to by 4 countries, so 4 countries sharing that water. And the demand on water is getting higher and higher, the higher ever demand on water, while the yield, as we all know, the hydrologists, that the catchment yield cannot be increased. That means the average is constant. So we cannot put more water into the river to satisfy the needs of every single country. So, so this is a real challenge, how to balance the demand with the supply of the rivers themselves, but you do it in a reasonable way, in sustainable way, and of course avoiding all the disputes and potential conflicts. So water diplomacy is the way to use diplomatic tools in trying to resolve these issues. In my view, water diplomacy concept or direction is a strategic choice for us. And as a strategic choice, because we have so many other challenges between the countries, and to avoid further escalating the conflicts, creating more political tension. So I think the entry point to try to resolve those issues is water diplomacy. So reducing the flow, I mean, now countries are able to control the entire flow, 100%. And as we all know that, for example, the constructions of dams and reservoirs on the river basins exceeds the capacity of the yearly yield of those rivers. So this means that controlling the water becomes very, very sensitive. Reducing the water, for example, as a downstream country like that, reducing the flow is a recipe for devastating communities. Those communities, historically, is very, very ancient communities, townships and villages. They have to leave because every single township in Iraq is based on a river or a stream or a canal. So if there is no water flowing, there is no way of staying in that place. So you go to force them to migrate, and by migrating, you create further problems in the cities, and this creates, of course, political tension because everybody accuses, upstream countries of controlling that water, and if you add to it the climate change impact, it becomes very, very complicated. So, and this, I think, if I am allowed to give you an example, for example, the Tigris River flow in Baghdad over the history, it brings on average 1,500 cubic meters per second. For the last 20 years or 30 years, it is less than 450 cubic meters per second. So you can imagine the impact on the environment, on agriculture, on biodiversity, on the social fabric of the people. So yes, cooperation could be ensured through water diplomacy, and there is also international principles on shared water that need to be resorted to, and allowing for reasonable and equitable use of water for all the riparian countries.
Thank you so much, Minister Janabi. You hear me? You hear me,
Yes,
I think?
yes.
Let's pass now to another question concerning specifically Iraq, if you don't mind. For instance, in Iraq, of course, the issue of water scarcity is very important, shrinking the green covers, impacting the rural urban migration, which is all linked to climate change and to internal problem, structure problem in the administration also. How can we improve the policies, and what action can be taken in Iraq in order to overcome these problems?
Yes, Dr. Fadi, this is very complex question, but I think the issue is also very, very complicated. Iraq has been the focus of the world for the last 40 years or so, but it has been the focus for the wrong reasons, of course. Everything was there, like, war and terrorism and what have you, and Iraq needs really decades, in my view, to recover from the impact of past policies. So the social impact, in particular, of 40 years of wars and has been catastrophic, and that's why we need really more stability, more development to ensure that what we are doing is stable, is giving hope to the people. But because of what happened in the last 40 years or so, it becomes very, very hard, if it's not impossible, to distinguish between the impact of climate change and the impact of other local and regional policies and programs. So it is interlinked, and it is in a dynamic way, but in a very negative impact on the country, where like control over water is overwhelming, and we also interpret climate change in our society in terms of water availability. So everything is linked. Sometimes opportunistic politician, sorry, they use climate change as a slogan to hide the wrong policies that they are pursuing, and also the wrong investment, because they are diverting from what we need to invest in the line of adaptation to climate change. So a lot of things that have been happening in Iraq because there was lack of basic services. There is a huge migration from rural areas, from small townships for better jobs in the capital, for example. The infrastructure in the capital has been designed to sustain 2.5 million people. Now you've got 10 million people in Baghdad itself. Certain other cities the same. So it cannot, the governments are under huge pressure to provide for basic needs of the people. We also have issues of unemployment, and the hundreds of thousands of young people graduating from universities have no hope in getting employment. So sometimes the governments struggle in providing really programs that are ad hoc programs, not in line with the adaptation policies, and it's very hard also to separate these issues and challenges facing Iraq from the climate change. Climate change by itself is a threat, but it's also a threat magnifier when it comes to bad policies resulting in shrinking agriculture areas, low production areas, migration, and what have you. So degradation of the environment is a real threat as well to Iraq. So Iraq needs to be given really, I don't know, it's not only sympathy and support, but that support needs to go in the right direction by international community, by friendly countries, donor countries. We need to push these ideas, not only to talk about climate change, but really to take action based on, a clear direction of adaptation to climate change.
Thank you so much, Minister Janabi, for this lesson learned. Your wide experience in this domain, you started as an ambassador, and then as a minister, you have encountered all these really critical phases in Iraq and in the regional also environment aspect. My last question, if you don't mind, goes back to the Tigris and the Euphrates. Within the hydrodiplomacy concept and the last track in hydrodiplomacy, which is the political process, we knew that Iraq and Turkey signed an agreement on water during the last visit of the Turkish President Erdogan to Baghdad. Could you shed more light on this matter, because we didn't have a lot of information about this agreement and how this agreement can relieve Baghdad from water scarcity. I remember in 2018, I invited you for the Beirut Water Week in Lebanon. 2 days before, you told me, Fadi, Baghdad is under zero water because of the replenishment of the Iluzu Dam. I will not be able to come to Lebanon to discuss all this hydrodiplomatic issue. Can you please give us some information about this agreement, and this agreement could really be sustainable in order to solve the problem of the Tigris and Euphrates, please?
Yes, thank you for this excellent question, Fadi. This Iraq-Turkey agreement, the last agreement signed by President Erdogan and Prime Minister Mohammed Shia Sudani, is really, really a welcome development in the bilateral water relations. So it is really, as they call it, a framework for cooperation agreement, a framework for cooperation between the two countries. What is interesting in this agreement is there is a clear reference to the past agreement between the two countries that has been signed in 1946, which was one of the excellent examples of cooperation on shared water between two emerging countries back then. Unfortunately, that agreement was shelved for very, very long time and never mentioned again in any document. So this document refers to that agreement, which is really a good sign of openness. It also has references, clear references to sustainable use of water. As you know, I mean, my stand is that water in the Tigris and Euphrates River has been overused, over-consumed, and over-controlled. And this is not the right way to go. So the reference to sustainable use of water is politically as a very good recognition of that we need to have a look and see that we all know that the demand is higher than the supply. So the sustainable use of water is very, very important. It also was based to enhance cooperation between the two countries, technical cooperation here. So which is good. Of course, we need technical cooperation not only with Turkey but with every other countries, particularly countries with advanced technologies and what have you. But in Turkey, it has very, very specific meaning when you have really your technical cooperation is framed in a wider agreement. The other thing in it is it has a time framework, which is a really good time framework, which is 100 years with potential of renewal on a yearly basis as needed. So that is really good in terms of trying to get results out of these technical cooperation agreements. But what is also very specific in this, the mechanism for financing of these potential joint projects between the two countries. So this mechanism using oil, so Iraq would be potentially paying in oil export for Turkish contribution and doing joint projects in Iraq. So I think the agreement has the potential to serve both countries. It opened a wide gate for further cooperation and development in water resources, further understanding. So it removes the political obstacles that we used to face when we came to agreement with our technical counterparts. So now, how is this a model for cooperation? I'm not quite sure, but it could be. It is very specific, to the Iraq-Turkey relation. But possible lessons learned from this agreement while it gets implemented are widespread, like joint projects, a new approach to the finance the projects. The time frame is long enough to implement and make tangible results. But by the end of the day, this would serve as a major step towards the potential long-term water sharing agreement. It's not only technical cooperation agreement. We need really long-term water sharing agreement with our neighbors that bring peace and sustainability to our nations.
Minister Janabi, thank you so much for giving us this complimentary information about this new agreement between Turkey and Iraq. In fact, just a thought that I would like to say it, in order to make an agreement sustainable, as you know, what we generally seek is the creation of a river basin authority. And this is very important to have an agreement, but without a river basin authority, whereas all the riparian country can share the data, can share the capacity building, can share the research pilot project, can share the management of a complicated transboundary river basin. I think that the agreement will not really be sustainable, or it could be sustainable for the short time. Just a quick answer. Do you agree with this thought?
Yes, absolutely, absolutely. The agreement lacks this basin-wide commission. I think this is in very specific bilateral water relations between the two countries. This is a little complicated. It needs a lot of work, a lot of water diplomacy, if you wish, to try to convince the parties that this is really in the interest of the two nations. Yes, I agree with that, and I think it's a very good tool to ensure at least even the projects, the joint projects that agreed upon to be implemented, taking into account the wider space of this is not only the project location. I mean, so it is very important, but we would like to work on this again. And we have 10 years to try to improve the bilateral relations.
Thank you so much, Minister Janabi, for your time. Thank you for your presence. We wish to gain your presence next time in our premises at the Cyprus Institute. And this is the vision that we wanted to give at the Cyprus Institute through the Hydrodiplomacy Partnership Program, which will encapsulate water diplomacy, technical diplomacy, environmental diplomacy, climate diplomacy, in order to launch mediation and negotiation on transboundary water. So we applaud your presence. And we thank you very much. Thank you very much.
Thank you, mate. Thank you.
Thank you. It was really passionate to discuss with Minister Janabi on this subject. Unfortunately, I think that Minister Nasser Yassin, the Minister of Environment in Lebanon, will not be able to join us because his new duty is to preside the ad hoc ministerial commission concerning the refugee in Lebanon due to this very thorough incident that we had, the bombardment of Lebanon by Israel. We hope that peace will be on the track. We hope that the political decision makers will implement peace in all the region of the Middle East, as we as scientists we are doing. And I recall 2 years ago when Professor Papanikolas and myself, we went to visit His Holiness Pope Francis, and we visited His Holiness for one reason, is to tell His Holiness that the Cyprus Institute has looked to Laudato Si, the Pope encyclic on the environment, to preserve the earth. And we have presented to His Holiness a booklet which also talk about all our research seeking climate change. And the Pope was really affected by this initiative. And we stayed more than 30 minutes discussing with His Holiness Pope Francis about the peace process linked to science and scientists. And our institute was the first institute that was invited by Pope Francis to visit the Vatican. So we hope that peace will be implemented soon. Thank you so much, and God bless you. It was passionate to be in this panel. Thank you.
Thank you, Professor Comer. Thank you, Minister Janabi. The second panel of this session will discuss extreme events such as heat waves, droughts, floods, as well as health. And we now welcome the convener of this panel, Dr. George Zitis, Associate Research Scientist from the Climate and Atmosphere Research Center at the Cyprus Institute.
So good afternoon, dear colleagues. We have heard many times today that the region is a well-known and profound climate, but also environmental change hotspots. While societies and ecosystems might be relatively easier to adapt to slow changes in mean conditions, unfortunately, this will not be the case during extreme events. that have already become more frequent and more intense. So this type of events, such as extreme heat waves, mega droughts, is the ones that we are going to discuss in this session. So first, we are going to have 3 presentations from our international invited speakers, and then we will have some time for discussion and questions. So I will first invite to the podium. It's a great pleasure to have today with us Professor Mansour Al-Mazroui. He's one of the most profound and active climate scientists in the region of the Middle East. Professor Al-Mazroui is the head of the Department of Meteorology at King Abdulaziz University in Jeddah in Saudi Arabia. And he's also an associate fellow in the Climate Research Unit of the University of East Anglia. His research interests include climate change and the effect on environment, water resources, and agriculture. And he's also very interested in studying future climate change in the Middle East with the use of regional climate models. He's involved in several committees, international bodies, and has been a co-author of several IPCC reports. And currently, he's also the managing editor of one of the most prominent journals of Springer, Earth Systems and Environment, where I also have the honor to serve as an associate editor. So, Professor Al-Mazroui, the floor is yours.
Yes.
Assalamu alaikum. Good afternoon in Cyprus. This is my 3rd time to visit Cyprus. Particularly, this visit is really marvelous. You know, this hotel is really great. It's along the beach, which is really good time to spend. Unfortunately, I'm leaving today. Anyhow, it's good to be in this comfort climate crisis in the East Mediterranean and Middle East. Actually, we are in crisis because of climate change. Climate change is happening now. It's not we're predicting, it's happening now. We are in climate change. So my talk is going to talk about temperature extreme over the Arabian Peninsula, future perspective and strategies. Because even the president talked about strategies of adaptation. So we are going to talk about the adaptation strategy in Saudi Arabia in general. But I need to give you output of the climate change in the Arabian Peninsula. So anyhow, already the profile being said by George. This is what also he mentioned. Now, this is the journals. We just started this journal, but this one is called ECED. Its impact factor is 5.3. So I invite you to publish this journal. It's getting higher for 5 now. Even the citation is great. Anyhow, that one is really great. In fact, I established these 2 journals. I established these 2 journals, in fact, before, and it's now going up. This one is getting a lot of attention at the moment around the world. Last year, it was having 25 publications. This year is having 100, and many people publishing this journal, particularly big scientists. For example, Fribo Georgi. So this is the part of the journal. Now, this is the outcome, the outline of the talk. We're going to talk about the collaboration within the MENA region. And also, we're going to talk about initiation of a subject regional climate center. This is ART Climate Change Center. This is RCC. And then we'll talk about climate extremes, talk about adaptation resilience, and talk how we do the recommendation and action points, as well as why we need gridded data. This is a very good point to talk about, but I hope that time will allow. Now, this is the idea of having a regional hub, which is like RCC, which will cover the MENA region as a whole. The role of it is going to be like the role of the ESMWF. It's really very big initiative. I hope it will be established for the region. Now, this is some evidence of climate extremes around the world. You can see here, it's 56.7 in Colombia, California, USA. That was 1913. And Africa, Tunisia, it was 55 degrees centigrade. And in Asia, I mean, in Iran, it was like 54, and it is in Australia, it's getting like 50.7, and also we have Canada. Canada before, it was having 46.7. This is really very big. Yeah, have fun. Now, this is the work that we are doing at the moment with the help of Georgie as well as Banos. We talk about compound extremes, which mean heat wave as well as wet or dry rainfall. So if you combine together, what will happen? So we're gonna do this one. This is part of the study. We talk about 90 percentiles, and you talk about drought events. So this is the part of the study. It's data from Saudi Arabia, which take from 1984 to 2023. This is updated data, by the way, on daily data. It's difficult to get the data, but anyhow, we get the data. So this is some of the result of the frequency duration of the drought, and you can see it is like 5.6 days decrease. I mean the days. The drought increasing, and temperature is this. The drought is actually trend is 0.67 per year. The drought, and also more important issue. You see, it is over the northern part of the Arabia. The most important thing, northern part. It's not just only northern part, but also Palestine, Jordan, all this area getting drier. And even Northern Africa also getting drier. This is part of the IPCC report, by the way. I'm going to show you some figure regarding this in the future also. But you can see here, this is the circle of the impact. It's called compound event of HUW, which is the compound drought, heat, and heat wave. So this is just about the frequency. This is what we discussed. Now, this is the future climatic conditions in the region. You can see it's a lot of, by the mid of century, hot. But by the end of the century, it's getting more hotter, huge hotter. This is departed from the mean, which is the normal year. You can see it is 3.5, and here getting almost 6 degrees. Going to show some figure which also confirmed with Georgia figure. So this is actually what happened. I mean, as a climate extreme, the precipitation in the north decreased, but in the south increased. And this is the case that we talk about the drought. On the northern part, there's going to be drought, and in the north and south, going to be increase. One of the increased issue that is really had maybe in April 2024, we got a very extreme event in UAE, 254 millimeter. And this summer, strange thing is really in the south of the Arabian Peninsula, which is the Jizan. We never get rainfall above 20 millimeter per day in Jizan. But this year, we got huge one. How much you think? How much you expect in Jizan, which is 20 millimeter? How much? Just say a number. Any number. 20, 30? Huh? 50? More. More than 100. 154. This is really huge. You cannot imagine this 184 coming in less than 24 hours. This is not really normal rain. This is actually extreme event. This is due to the climate change. This is really huge. For example, I'll give you another thing. In Jeddah, my city, 2009, it was 74 millimeter. How much? 74. 2011, how much, 111. But in 2022, doubled, 182 millimeter. Definitely, this is not normal rainfall. This is flooded because of climate change. So this is the case of the extreme rainfall. It's happening huge. We have to deal with this in the future. This is the rainfall, but I'm going to talk now about the temperature. Temperature is worse, by the way. It's really worse. I'll show you the figure. Just prepare yourself. You're going to be dying.
You want to die? So this is the extreme. But this one is really confirming the drought in the north. It's not just only this paper, which published in ECV, get almost 108 citation. This is a huge citation. But you can see in the south and all this longitude, it is what? Green. And the north is really red. This is mean dry. And this is mean wet. Can you see? It's not just only the Arabian Peninsula, but along the latitude. This is this is published in the IPCC, by the way. You see here, if in Europe, it's getting drier. Europe, don't think that's going to be wet, it's going to be dry in the future. So this is actually good results. This is the temperature, by the way, for the MENA region. I think this is George paper. You can see it is MENA Cortex, but in the Saudi Arabia, it's getting hotter. But in the end of the century, by the end of the century, all this yellow getting red. You see how much red this is? This is the worst thing. I'll give you another one you will like so much, but you will die. This one, where is it? Saudi Arabia. But what you can see, everything is normal until 2050. What happened? Increase. 250 is like killing point. 250. And the extreme is getting more by the end of the century. Is it me only doing this? No, the other people. The other people will confirm this result. Who is this? George and his team. I was one of the authors. So this is actually from MENA region. This is Zetas. And you can see it's getting more ultra extreme in 2051. You see, same figure as it did before, but that one for Saudi Arabia, but this one for MENA region. This is for Saudi Arabia, and this is MENA region. Anyhow, it's just only extreme in high temperature. We have other extremes. What is it? Cold extremes. In Saudi Arabia, there was an event. It was in 2008, where temperature being dropped below zero. You will be surprised. Yes. You will be surprised? No. See this one. The most significant thing is this station. It is almost 11 days in row below zero. 11 days, imagine. And this one, high, it reached up to -10. Imagine in Saudi Arabia that you have temperature below -10. This is going to be killing. This year was actually being raised a relief by the government. People were in the Bedouin in the desert, they were supported by the government because they were dying. This is huge. And even here, it is Taif, it is -7, -8. Imagine over Saudi Arabia, it's getting -8. Huge. This is really a marvelous result. I mean, this is not just only normal, this is actually related to the climate change. But this event is really a unique one. What is the hierarchy region for this? It's actually a cold Siberian high, come from Siberia, across the Arabian Peninsula, until the middle of Asia, Africa. This is very big stuff. We may expect even La Nina this year, which is going to be low temperature. We expect it to happen, actually. So this is La Nina case. You know La Nina? You heard about La Nina, isn't it? Who defined La Nina? La Nina, who's defined it? Okay, I will define La Nina. It is temperature below average of the equatorial part of the Pacific Ocean, where it is below zero. Currently, it is -0.5, which is mild La Nina. But what this mild La Nina will give you? Will give you many things. So this is the recent forecast of IRI, which is Columbia University. This is updated now. We can see this area is getting drier. 60%. Can you see here? almost 60%, and in Central getting minus 40%. So it means that it is getting drier. For sure, this next season gonna be drier. What will happen? This will cause what, Shabab? What will cause? As His Royal Highness said, that we are having problem with dust storms, because this one will increase the dust storm, not just over the Saudi Arabia, but also over Egypt and Africa, over the Sahara, which is called Hamasine. So this has to be alerted to the people in the school and for health issue. This is health issue, isn't it? You know, it will happen because people will go to doctor and hospital for asthma issue, particularly students. So we have to alert what? Minister of Education, Minister of Health, and prepare for the worst. We don't want to say that it will happen, but you have to be prepared. This is called early warning system. So we have to prepare for the offense. So I hope you will understand this. This is La Nina. What will happen? Even the temperature is getting higher because of the extreme rainfall temperature. Even La Nina, the temperature is getting higher. You can see it's more than average. But what it means, doesn't mean that there will be no snow. Could be there is snow, but it's still higher temperature. Last year, by the way, it was El Nino. And Saudi Arabia, the north of the city, you see -7, didn't drop to 0 last year. So this year it could drop below 0, but not that normal. How much? 5 minutes. Anyhow, this is some of the vulnerable sector affected by climate change in Saudi Arabia: agriculture, power sector, water resources, livelihood, and coastal development, and those who have problems related to Hajj and Umrah. You know, this is for Hajj people. We have extreme temperature, which affect the Haji who came from Europe in particular, because high temperature. Last year, many people died because of the heat. So this has to be taken into consideration. This is what we need, actually, early warning system. And we have to do safety pilgrims, but I will go forward. Time is not running. This is action plan, but it is really need to do the resilience and the adaptation strategies. We don't have time to take all this. I need another lecture if they allow me next time. I'll do it, inshallah. I'll explain to you later. But this is a huge thing that not just only Saudi Arabia, but any country can take it over. Take it, record it. This is really important. You have to action plan for your country. Even for Cyprus, this action plan is important. This is to improve our digital infrastructure, early warning system, agriculture activities, and we have what is called infrastructure. Because of the climate change, the road has to be enhanced. Even the bridges. Before in Saudi Arabia, they were built about rainfall will happen 100 millimeter. Now rainfall is 200. So whatever they have to change. You have to adapt it. You have to do resilience. So this is the issue of the. I have to go quickly because there are a lot of things to say, particularly the data. This is the data. The problem of the data is actually, you can see, without data, it can't work. We as climate change, we depend on the data, but we depend on quality control data. And we need actually collaboration for all the region to provide the data. The big issue of the Middle East, particularly the Arab country, they don't give the data. This is a big issue in all Saudi Arabia, Gulf, often the Jordan, they don't give you the data. They think this is an important issue and we can't give it to you. Come on, if you don't give it, we can't tell you what will happen in the future. This is a big issue. But without the good data, this is what will happen. But if you have good data, you can see what happened in the picture. It's been clear. And you need what is collaboration. Meeting with the higher figures for managing this issue. Climate change has to be at top level. We talk about COP, but we need to talk about the regional efforts. This is really not happening, actually, unfortunately. Because last thing they will talk about climate change. Anyhow, this is an issue. This is the data. Can you see? what really we need, this is coarse resolution, but we need fine resolution. There must be some work on getting gridded data, but getting high quality. We know crude data is 0.5, but we need it for our region more higher than 0.5. Now, this is the issue that really needs collaboration. So this is actually crude data. Maybe we need to have consultation with these crew people to do the region. But the problem is coming again, the observation data. Nobody will give it. What do we need? Why do you need the quality control data? Because we have example of Cordex. Cordex is getting bigger scale, but then with the Cordex data, we can do RCM. RCM high resolution, 0.25 degree, which is really important to give you the output and then to analyze the temperature and rainfall. Example of NASA. So this is what is called the high quality data. You can see here, if it is scored, this is how the picture, but if it is getting more higher, get good quality and get the picture. Almost finished. So this is the regional capacity that you need to do. We need education, we need training, and then scientific collaboration on research, on climate change. So this is the final thought. We found that there is increased frequency of duration of drought, heat wave, and combined event in Saudi Arabia. And we need more to focus on this study. We still have a big project with the Moniz and George, and we'll study it later on. But I show you just only one example, which is drought with heat wave. We're going to study with as well high temperature. What will happen? Sure, they're going to be happening more. So this is one finding. We need policy recommendation. We need government to work together on this issue and to help us. We need call for action. Urgent need for integrating climate resilience and national planning mitigation for the impact of the extreme events. This is really important. I think this is the last one. And thank you very much.
Thank you very much, Mansour. I think this was a very exciting talk. Some pessimistic projections for the future, but this is something that we already see in many parts of the region. So our next invited speaker is Dr. Marlene Tomaskiewicz, working at the United Nations Economic and Social Commission for Western Asia in Beirut. She has a PhD in water resources and environmental engineering from the American University of Beirut. She has completed previous studies in the United States in civil engineering, and she has many years of working experience in the United States. Her current work focuses on droughts, water resources in the Middle East and North Africa. And I would like to thank again Marlene for coming. It is much appreciated to have you here in Cyprus. Thank you very much.
So thank you, George, for the introduction. Again, I'm with ESCO. We're the regional commission for the UN. I'm based in Beirut. And within ESCO, we house the Arab Center for Climate Change Policies. So we basically focus on sound policy making in the context of climate change. And my specific role is to help bridge that science policy interface. You know, the scientists have a realm, the policymakers have a realm, and how we link together is not always that transparent. So I help to bridge that gap through some of the work we do. So I'll start from there. So again, I'm going to be focusing primarily on droughts. And droughts, we've been talking about drought quite a bit today. We have a picture of drought on the banner. Drought is a huge, huge, huge issue to our region. We're not strangers to drought. Drought is not a new thing. But drought is a complex phenomenon. You know, the definition of drought is sustained and extensive events of below average water availability, which causes adverse impacts to vegetation, to agriculture, to livestock, to the population. All sorts of sectors are impacted. It differs from aridity, it differs from water scarcity. Our region is, characteristically described as arid, semi-arid. So it differs from that. It's not necessarily a business as normal kind of situation. It's a much more, a drought is a specific event that is less than normal water availability. And it is also complex in how it's characterized. We have meteorological drought, which is just the absence of precipitation. We have hydrological drought, which impacts our waterways. Agricultural drought, which impacts the water available in soil and available for crops. Ecological, which is kind of a new concept that's being talked about, which impacts our forest and other ecosystems. As well as socioeconomic drought, which will impact the water as a commodity, the cost of water, and how it affects food security and other measures. And how is climate change related to drought? Are droughts increasing due to climate change? Are they more or less the same? And we think they're increasing primarily, first of all, temperature is increasing, and that's, we kind of all agree on that. The temperature is, in general, increasing, and it's increasing not linearly, it's increasing more exponentially. So more heat due to anthropogenic warming, and that heat that's created has a warmer, the atmosphere overall is warmer. And a warmer atmosphere can hold more water. And because of this more water, first of all, we get more intensive rainfall. Our rainfall patterns are changing because we have all this atmospheric water available, intense rainfall. And then we have, and then it's also followed by periods of drought, and the drought may be extended because there's a longer period of time for that atmospheric water to recharge. And there's a feedback loop between these droughts and floods. We have extended drought where our soils dry out. It basically creates a hydrological surface that is almost like concrete. So when it does rain, and again, rainfall is going to be more likely more intense, it will wash off immediately like it's running on pavement, and those create floods. Also, with increased temperature, we have, in general, increased evaporation. And that evaporation, particularly when temperatures are high, that can also enhance drought. There's a kind of a new concept that's coming out in the scientific circles that they're flash droughts. Flash floods we're much more familiar with, but similarly, there's flash droughts when we have heat waves that, like Mansour was talking about, with these intense heat waves, resulting in intense evaporation, boom, we have a flash drought. Also, due to climate change, we have decreased snowpack. And some of our areas in this region do have mountains, and for example, where I'm in Lebanon, we have snowfall, which we really depend on for our water resources. I know there's some snowfall here in Cyprus and elsewhere around the region. With climate change, we're having decreased snowpack, which is definitively impacting our water resources and resulting in drought. So these are different pathways of how climate change affects drought. How do we quantify drought? Drought, again, is a complex phenomenon, and there are different ways that have been, methodologies that have been suggested to quantify drought, and using different indices. Mansour was talking about consecutive dry days, which we use as well. There's different indices out there. One of the most common indices, which I'll be talking about mostly today, is a standardized precipitation index, which is widely used. It's a simple index. It only considers precipitation, which is, it makes it simple, but it's also a little bit of a weakness, admittedly, so it's only used for meteorological drought. But it is most commonly used because of its simplicity. And it's regarded by the WMO as the preferred index to characterize drought. So I'm going to be using data sets. We have at ESQA, we launched an initiative almost 10 years ago now. It's called the Regional Initiative for the Assessment of Climate Change impacts on water resources and socioeconomic vulnerability in the Arab region, also known as RECAR. And RECAR is initially launched again to assess the impacts of water resources in the region, but it's extended into different sectors as well, so it's widely reaching. And part of that, we had initially launched a domain you see on the left, which is the Arab domain. And the idea was to do regional climate modeling and homogenize climate modeling across the Arab region. So, you know, countries in Morocco could speak the same climate dialogue as climatologists and scientists and policymakers in Oman. So it's meant to homogenize that. And it's actually hosted by the Cyprus Institute. And those data sets are still valid, but they're a 50-kilometer scale, considering both RCP 4.5 and RCP 8.5. And those are open access data sets that are available on our website for those may be interested. A couple of years ago, we launched a second domain we call it the Meshreq domain, to kind of give it a little bit more of an Arab identity. And again, here it's there on the right. It focuses on the Arabian Peninsula, the Eastern Mediterranean, and kind of extends into Northeast Africa as well. And those data sets are very, very high resolution. They're available at 10-kilometer scale. They're based on the most recent CMIP scenarios, CMIP 6 scenarios, the SSPs. So we have SSP 2 4.5 as well as SSP 5 8.5. And both of these domains, which kind of makes them distinguished from other climate data sets. There are many, many climate data sets that are out there. We also bias correct our climate data sets, which makes them, which you introduce observed data sets, reanalysis data sets into the climate modeling output to improve their results. And it makes them much more suitable for hydrological studies such as drought. So I'm going to be focusing on the 3-month standardized precipitation index. Again, be focusing on meteorological drought. And the 3-month is effective for analyzing reduced soil moisture, small stream flow, and sand and dust storms, which we have not talked about at all today. But sand and dust storms are a growing issue in our region, and we're actually doing a lot of analysis on sand and dust storms at ESCWA. So I'll be assessing the changes on drought duration and severity over the Meshreq domain, that 10-kilometer data sets. So the methodology is to calculate SPI 3 using the entire climate data set. We have data sets from over a 110-year period from 1961 to 2070. A drought event is considered when SPI gets below 1. So here's what SPI, different categories to calculate. And then again, to calculate drought duration and severity using run theory. And severity is equal to the absolute sum, absolute value of SPI. The methodology. So here's kind of the maps. This is kind of the crux of the presentation here. So I wanted to first show drought duration. This is for SSP 2 4.5, the more moderate scenario. So on the left, we have the reference period, and you can see areas of drought, a little bit mixed signals across the region. And then increasing drought as we move to mid-century, to near century, which we're currently in, the 2021 to 2040 period. And then 2041 to 2060 on the far right. And I kind of zoomed in here a little bit on the Eastern Mediterranean. And you can see a little bit of increasing drought projected across our region. When we get to the higher upper level boundary scenario, you can see it's much more pronounced, particularly at 2041 to 2060 period. We can expect an increase in droughts. This is again for the 3-month SPI. I will do some upcoming analysis soon to analyze different other periods of SPI, to look at 6-month, which is much more to look at more hydrological scale, as well as the 12-month, and those will assess much more larger impacts of drought. And I'm also going to do assessments on SPEI, which brings in that
evaporation component. It's basically considers both precipitation as well as evaporation, so it's much more encompassing to look at agricultural impacts, et cetera. With severity, again, areas in red, we have increasing severity of drought. And again, here is the more moderate scenario. You can see a much more pronounced signal. We can, not only are expecting drought duration to extend, but those droughts that do occur, they will be much more severe. And we can see it particularly with upper boundary scenario. You can see it in southern Turkey, as well in Lebanon, and a little bit in Cyprus. The droughts that are going to occur will be much more severe. I added this slide based on some of the discussions that were happening this morning. Why are we talking about climate, especially we've got other crises that are definitely impacting our region right now that we've been talking about throughout the day. And how does that relate to climate? Climate and conflict are interrelated. One doesn't necessarily cause the other, but they are both what we define as transmission channels. We have loss of income due to climate change as well as conflict. We have loss of food security. We have resource competition. There is more likely migration. So there is interlinkages, and I just wanted to highlight that a climate crisis is definitely part of a conflict crisis. So I just wanted to show that to kind of emphasize some of the things we've been talking about today. So what can we do about drought? And some of these drought adaptation measures we have been already doing in our region. Again, we are not strangers to drought. Drought has been occurring here for many, many years. But there are definitely mechanisms that we can improve upon. For example, water-saving irrigation measures, better integration between livestock pastoralism and crops, and integrating them for a much more holistic approach for how we implement agriculture. We can focus on much more on income diversification, improved infrastructure, rainwater harvesting, as well as holistic landscape and watershed management. So these are some of the measures that are already, as I mentioned, already currently being done, and but again, we can definitely improve. So here's our website. Again, I encourage you to go to recard.org, as well as our website on the Arab Center for Climate Change Policies. I also encourage for those of you who are on LinkedIn to follow me. Sometimes I post some side links. For example, as Mansour was talking about with temperatures, and this past summer was the hottest temperature on record for the Arab region. And I did some analysis using Copernicus ERA5 data, and I posted a map as well as evidence to show where exactly and how this past summer was the warmest on record. Our region is already increasing higher than in temperature than the global mean. So, just to additionally emphasize the importance of highlighting climate change in our region. So with that, I will conclude. So thank you very much.
Thank you very much, Marlon, for this great talk. Our next distinguished speaker is Dr. Robin Fiers. Dr. Fiers has a background in biochemistry, nutrition, and medical research, and almost 3 decades of previous experience in pharmaceutical industry research and development. In the last 2 decades, he provides advice on biosciences policy issues to a range of public sector organizations, parliamentary groups, including the United Nations, the European Commission, and of course, industry. Since 2002, Dr. Fiers advised the European Academy Science Advisory Council, EASAC, and he directs the work of the Biosciences program. And this work includes major global projects on food and nutrition security, agriculture, climate change, and health. So today he's going to talk about health impacts of climate change. Please.
George, and thank you for the invitation to speak today. My focus is on health and health solutions, and I start by showing a figure from the WHO to emphasize the complexity between the interaction, the different pathways of climate change on health in terms of extreme events such as heat. Clearly there are direct impacts on health, but there are also indirect impacts mediated by food systems or migration and water availability, as we've heard previously. It affects us all, but there are particular vulnerabilities within populations and between countries related to exposure, socioeconomic status, and health system resilience. I will move rapidly through a couple of slides because I think they reinforce what we've already heard. The first speaker in this session described extreme heat in this region, and these are recent data from the WMO cited by the UN Secretary General this summer. This region is at risk. These data from the recent Lancet Countdown on Climate and Health emphasize, the paper itself emphasizes a number of impacts of climate change on health in Europe. This particular slide characterizes some of the potential risk in terms of a reduction in productivity and labor supply. Countries like Cyprus are shown to be markedly affected, and of course if there's a reduction in incomes, potential increase in poverty, then that will affect health. This region tends to also have a concentration of cities manifesting at high urban heat intensity. So the effects are found everywhere, but some of the metropolises in Europe and beyond are suffering particular issues. Given that background, I want now to draw on some of the recent work of the Inter-Academy Partnership, which, if you don't know, essentially is a global network of academies of science, engineering, and medicine. And this allows me to add my welcome to the Cyprus Academy as the latest member of IAP, so welcome. But of course, the Cyprus Academy has been very active in international academy relationships for many years. So these are, IAP organizes its academy network of 150 members through the regions, Europe, Africa, Asia, and Americas, and actually the Eastern Mediterranean, Middle East tends to fall between the regions of, in academy terms, of Europe and Asia. Allowing for that, IAP and its partners is engaged in a large interregional project examining the impacts of the various pathways of climate change on health around the world in the different regions and in specific areas such as the Arctic and the Mediterranean, where we did work together with the Cyprus Institute and the Cyprus Academy to characterize some of the issues for health in this region. And obviously I don't have time to go through all these publications, but I single out two as particularly relevant for heat health studies and covering the countries listed here, together of course with the countries such as Cyprus, Greece, Italy, that are very rich sources of data on heat health interactions. We've heard throughout today the importance of robust data, expert evidence, and I commend these reports to you as a source of evidence both at the national level and at the regional level. And in addition, as I think you will all know, Cyprus Institute and Academy have helped to lead a climate initiative over the last few years, examining the impact of climate change on a number of sectors, including health. And this slide concentrates on the report of the Health Task Force, and we discussed this in more detail earlier this week in a workshop here. And I won't go into the detail, but just bring your attention to the final point that one of the research gaps emphasised in this task force report was we need to do more to evaluate solutions and the interaction between the different solutions. And that's what I want to spend the rest of my presentation on. And essentially, in that context, the Inter-Academy Partnership recently initiated a new project together with the global NGO Save the Children to look at some health adaptation case studies, to compile a database, a resource of case studies from around the world on adaptation. And we looked at a number of priority areas, including food systems, health systems, impacts of urbanization, and so on, adopting the planetary health framework that is incorporating both the human health and the health of the systems on which we depend, within the broader context, of course, of the Sustainable Development Goals, and taking essentially a transdisciplinary and cross-sector approach to the research, and finally trying to focus on certain vulnerable groups, particularly women and children, given the interest, of course, of Save the Children, and especially in low and middle income countries. And right here I have to confess a gap in this evidence base, a weakness in the data, if you like, that we don't have any case studies from this region. And actually part of my interest in being here this week is to encourage you to think about helping us with case studies in the region. I'll come back to that. Okay, so I haven't time to go through all our case studies. They have all now been published in an open access volume, and we've also published a synthesis, a summary of some of the issues for policymakers, which is highlighted on this slide, and that was launched at COP28 in Dubai last year. But looking at some of the specific case studies, the ones on this slide are selected as being particularly relevant to urban heat health around the world. And as I say, the detail can be found in the individual studies. I haven't got time to look at these. These are the particular heat health, but as I say, we ranged over a number of other themes and objectives in food, nutrition, health system strengthening, flooding, infectious diseases, and so on, and some are listed here. And again, you can find the details in our core publications. But just coming back for a minute to the focus on the conclusions from the work on urban heat health correlations. As I say, we brought together information from case studies in Asia and Africa for this purpose. And really the study, and although so let me just say again that there aren't any studies from the ME region, but actually the conclusions from these studies are we feel generalizable for all regions. So for example, we documented the impact of high heat levels, both indoor and outdoor, on both physical and mental health risks, and in particularly in vulnerable groups such as children and the elderly. This information, of course, has already been available from other sources, but we help to characterize the specifics in our case studies and identify the particular health effects, for example, on respiratory and cardiovascular, and to emphasize the interaction between high heat and other drivers of risk, such as pollution. Again, that was something we've talked a lot about this week in our preliminary workshop. In terms of solutions, the case studies explored various mitigation and adaptation solutions. the project was designed to look at adaptation, but it's critically important to look at the integration between adaptation and mitigation. For example, if you're trying to reduce high heat, then you need mitigation to reduce greenhouse gases and climate warming, but you also need adaptation, for example, to paint the roofs of houses with white paint to cool the local communities. So very much an interaction between the different solutions, and urban greening, a number of strands of evidence in favour of that, although there's also the risk of potential maladaptation. If, for example, you increase the level of greening in cities, you may also increase the reservoirs for vector-borne diseases. So it's important to take truly a transdisciplinary and systems-based approach to looking at the solutions. Okay, one of the features that really came out of all our case studies was the importance of co-design with the affected communities, and that of course has implications for increasing their awareness of the problems of climate change on health and the solutions, and then in terms of translating between the research and policy and practice to empower the communities that we worked with the information and the tools to effect change. This can be done at the local level, and we also have examples of where it's done at the city level and then fed into national guidelines, for example, in India, and urban planning policies, as well as health policies, and emphasise the point that health is not just an issue for the health sector, it is a cross-sectoral priority. Okay, just to finish, what works in designing case studies? We learned various things from doing this work. We confirmed that it is important to take a systems-based approach across the disciplines, across sectors, and it helps, of course, if you think about the metrics for measuring impact before you start. Metrics for measuring health impacts are not necessarily straightforward, and the problem is that different research groups use different metrics. So how do you bring together the conclusions in a way that's relatively easier for mitigation, where essentially everybody's looking at greenhouse gas emissions? So there's an issue for metrics. There's very much an emphasis on we must involve end users, both in terms of identifying the right research outputs, the right endpoints, taking account of what the local communities need in terms of their health, avoiding the risks of maladaptation, and indeed increasing the likelihood that the results can be used in practice by the community and can, if we're fortunate, can then serve as lessons of good practice for replication elsewhere, for upscaling, and for sharing more broadly. And this is my last slide, I think. Okay, so the work has resulted in a significant amount of generalized guidance on good practice in designing and implementing adaptation research. But it also allows us to develop some priorities for translating the evidence from that research into policy and practice. And I think, as a number of speakers today have emphasised, it's important to do more to build the interfaces between science informing the evidence and policymakers or other stakeholders using that evidence. That's true whatever the level of governance, whether it's local, national, regional, or indeed global. And that has a number of implications, for example, for policymakers understanding that there are, and the research community understanding that there may be a diversity of research streams. It's not always double-blinded, randomized research. There may be other knowledge streams that need to be taken into account. In terms of building those interfaces, we need to pay very great attention to how to target the vulnerable groups, such as the children, the elderly, those with pre-existing medical disorders and so on. And in addition to the specific actions that we can take in adaptation or mitigation, there are some general features which, if we don't attend to, are specific objectives what won't be achieved. For example, the social determinants of health and inequity in health and health systems. I think I'll finish there. As I say, health is involved in all policy sectors, all sectors of policy, but there are then issues for trade-offs as we develop policy in individual policy silos. It's important to bring policy together in a systems-based approach, as it is to bring research together in a systems-based approach. And of course, finally, climate change is not the only health crisis in recent times. The intersection between climate change and COVID produced a number of exacerbations of adverse health effects. And of course, it's important to take account of the specific impacts of climate change in terms of what we already have for objectives for global health strategies and the SDGs. Thank you.
Thank you very much, Dr. Fears. Allow me also to briefly introduce our fourth panelist, Professor Hadjinikolaou, Panos Hadjinikolaou, who is an associate professor at the Cyprus Institute, where he leads the Climate System Processes Research Group. I think we're running a bit out of time for this session, but I think we have time maybe for one, maybe two questions to the panelists. I think there's one. The gentleman there.
Really a question for Mr. Fierce. Health. In your mitigation list, an obvious thing at an individual level is air conditioning. And we read about the heat crisis in Europe. A number of people would have been saved. Older people had air conditioning. I know in my short lifetime, places that never had air conditioning have air conditioning now. So that is increasing as people add air conditioning as an individual mitigation method. To what extent does the heat that's released from more air conditioning, plus the energy that's involved, change the baseline at all? Is it measurable, or is it just discounted?
Yes, I think the question was about the effect of air conditioning that can exacerbate.
I'll be happy to repeat it. No, basically, air conditioning is increasing as an individual mitigation method, let's say, and we know that it would have saved lives during current heat waves. And we also know that it is increasing both in vehicles, homes, public buildings. I was just wondering whether the heat that's released from the air conditioning itself, plus the extra energy used, has enough impact on climate change to be taken into account.
Yeah, clearly I didn't have time to. I didn't have time to explore all the many issues, but indeed, a part of the active research in adaptation is to consider the issues of actually you might be making things worse in maladaptation, either by ignoring vulnerable groups or by introducing solutions without sufficient thought as to the consequences, whether in terms of increasing climate change itself with air conditioning or whatever. The other point, of course, the broad methodological point, is the one of attribution. there's still a lot of research to be done to identify specific health changes to specific climate changes. What worldwide systemic reviews suggest that for the Heat Health Mortality Association, about 35% of that can be specifically attributed to climate change, anthropogenic climate change. And obviously that varies around the world, and there's very large data gaps in that, including in this region. We also heard earlier this week in the workshop on health that, for example, in this region, the spread of West Nile virus can specifically be attributed to the ecosystem change associated with climate change over the last 10 years. So there is evidence emerging to clarify some of these associations, but indeed there's a great deal still to be done to understand the trade-offs between different adaptation and mitigation solutions. Well, I hope that answers you.
We can have one last question, and we can continue the discussion maybe in the coffee break.
Yes, thank you. And compliments on a very interesting presentation and also very sound conclusions. As you know, there is fairly extensive work in Europe evaluating, assessing nature-based solutions and strategies with cities to go into a lot of experimentation, how to create development around that. The health and the nature connection has not been really focused, but there are a number of important sort of studies and conclusions and action in cities. And these demonstrate very clearly that the health implications of developing green areas in cities within certain area, especially for vulnerable communities and so on that you mentioned, can have very, very major health implications. Now, the link between health and nature-based solutions and environment more broadly need to be more developed. I was missing that a little bit in your conclusions, actually the coordination. I was at the ministerial of WHO and UNEP, the joint ministerial in Budapest last summer, and you could very clearly see that the two sides do not connect very well. There was an interest, but it's very hard. Now, if you're able to connect and coordinate so that you can take into account more of the health effects, you could get a stronger momentum for actually developing nature-based solutions and change the cities. And in the same way, if you can get that link stronger, you can also impact the health profession to be more looking at prevention and capacity building of another sort. Would you agree with that? And what would you see as the most important to strengthen that sort of mutual coordination? Thank you.
Yeah, I would certainly agree with the general point, strengthening coordination at the city level and urban planning, as well as at other levels of governance. Of course, as you note, the evidence available is not always clear-cut in terms of urban greening, for example. While there is significant documented examples of value, clearly there are some factors involved, such, for example, if you involve the local community in designing and using green spaces, then you get an improved benefit on mental health compared to if you don't involve the local community. So there are a number of issues to be taken into account. And as I mentioned, that there are also possible adverse consequences that need to be thought about, which will be context dependent. So if you increase green space in some areas, you may increase the reservoir of vector-borne diseases, or you may introduce new allergens if you don't think carefully about what vegetation you're introducing. But there are some good examples to follow there. And certainly I would agree with your general point about the need for coordination in that planning, which is, it's happening partially, but there is still, I think, a lot to be done to connect the evidence with the practice.
Thank you very much. I think we can conclude the session. We may continue the discussion in the coffee break, but let's thank once again our speakers.
Thank you, Dr. Zitis, Professor Al-Mazrui, Dr. Fierce, Professor Hadjinicolaou, and Dr. Tomaskewicz. We will now proceed to the third panel of this session, which will discuss marine and terrestrial environment and biodiversity. I would like to welcome Professor Konstantinos Kounamas, Director of the Nature Conservation Unit at Frederick University.
Good afternoon, everybody. Thank you for being here in the almost to the last one presentation before the break. Now, can you hear me? Louder? Okay. We were supposed to have 3 panelists. Unfortunately, one of our panelists has difficulties in connecting. Professor Naim Ouaini greets everyone and apologizes for. He would like to be here for this conference. Unfortunately, he has issues connecting with our conference now. Now, our session deals with the marine and terrestrial environment and biodiversity. As people know, biological diversity is the variety of life on Earth and concerns all of its forms. According to United Nations website, etc., over half of the GDP, of the global GDP, is dependent on nature, and more than 1 billion people rely on forests for their livelihoods. However, nature is in crisis, where up to 1 million species face extinction within the next few decades. Climate change plays an increasingly important role in this decline of biodiversity. Climate change has altered marine, terrestrial, and freshwater ecosystems around the world. On land, the higher temperatures, as exhibited before by the previous colleagues, have forced animals and plants to move to higher elevations and higher altitudes, while in the sea, the ocean, rising temperatures increase the risk of irreversible loss of marine and coastal ecosystems. The climate change affects the health of ecosystems, influencing shifts in the distribution of plants, viruses, animals, and even human settlements. The global community has put in place several legal frameworks, strategies, and action plans to protect nature and restore its habitat and species through management and conservation measures. Our first speaker today will be Dr. Nicolas Jarreau. He's the Senior Specialist, Engagement and Partnership Development with the Global Water Partnership. Dr. Nicolas Jarreau is a founding member of the Leadership Council of SDSN Cyprus and has almost 15 years of feasibility project and program management experience, along with a great experience in environmental sustainability. His lecture will deal with the integrated water resource management and propose a solution to the triple planetary crisis: climate, biodiversity, and pollution. Dr. Jarreau?
Well, hello everyone, and thank you very much to the organizers, the Cyprus Institute and the Academy, for allowing me to be here today. I know that we are standing between you and your coffee, but I think we'll try and do our best to keep you entertained and keep you informed. So I'm Nicolas Jarreau from the Global Water Partnership, and I'm going to talk to you about integrated water resource management as a possible solution to the triple planetary crisis. The Global Water Partnership is an international organization dedicated to strengthening sustainable water management and governance worldwide. It's a network of more than 3,500 organizations operating in more than 180 countries. The reason organizations like ours exist is because we're facing, as we know, a triple planetary crisis: climate, biodiversity, and pollution. We've heard a lot about climate today, but of course all these three crises are completely interrelated. Every creature on this planet is between 10 and 90% water. Not a single creature on this planet would survive for 1 instant without water. In fact, when scientists are looking for life on other planets, they're not looking for oxygen, they're looking for traces of water. Pollution, of course, affects the water courses, it affects the land, and so all these crises have several things in common. One of them, obviously, is that they are of human origin. The second, though, is that all three crises are, at the end of the day, caused by a problem with either the distribution or the availability of water. And we've seen earlier on the links between climate and water. We don't need to go back into that. This is obvious. What is maybe not so obvious to people is that the solutions that mankind often finds, for example, for adaptation to climate change, in terms of the access to water, will solve the short-term problem in terms of access to water for human consumption, for agriculture, for industry. Most of these solutions will not address the need of ecosystems, and in particular terrestrial ecosystems, for water. So water is at the heart of all these crises. So in terms of the Sustainable Development Goals, essentially SDG 6 is the ultimate connector between, in order to achieve, for the achievement of pretty much every other Sustainable Development Goal that you can imagine. I mentioned the triple planetary crisis. In this region, it's probably a quadruple crisis, which is conflict. And we've mentioned that earlier today. We've seen also the link between climate change and conflict. And again, transboundary water cooperation, as we've seen in Professor Comer's session, for example, is essential once again, to address that fourth crisis that we are living through in this region. So an integrated approach to SDG 6, which is about solving the water problems of this world, is essential for progress on all the Sustainable Development Goals. This is completely different from the usual approach that we see across the globe, which is what we call the inverted wedding cake, where essentially water is almost like an afterthought in the actions that we take to try and meet these goals by the year 2030. Because at the end of the day, SDG 6, if you break it down, addresses all angles of the crisis. If you look at indicator 6.3, you're dealing with the pollution crisis, with water quality, with wastewater. If you look at indicator 6.6, you're seeing how dealing with water is also about dealing with the preservation of ecosystems. And I was glad to hear a comment from the audience in the last session about nature-based solutions. This is exactly what this is about. And then indicator 6.5 is both about the transboundary cooperation that we've heard about earlier and the integrated management of water resources. What does this mean in our region? We've known for years, this is not news. We know from IUCN assessments that the Eastern Mediterranean is both a climate and a biodiversity hotspot. It supports just over 4.4% of the global population, but contains only 1.1% of its renewable water resources, so the water stress is inevitable. And land use and climate change have made that worse. And as a result, over 19% of freshwater biodiversity in this region is considered to be threatened. And 58% of the region's endemic freshwater species, and this region has a lot of endemic species, especially on islands like Cyprus, are again assessed as threatened. And the freshwater ecosystems themselves, of course, play a vital role in the preservation of all terrestrial ecosystems. And so the IUCN concluded many, many years ago, almost a decade ago, on the urgency of integrated river basin management, which essentially is a special case of integrated water management at the basin or at the watershed level. Here in Cyprus, the situation is similar, and we'll get back to that, probably even worse. Cyprus is in the top 5 most water-stressed ecosystems in the world. So as a result of climate change and other human activity, the Eastern Mediterranean essentially has reached a tipping point, of precipitation and freshwater tipping point, beyond which its plant diversity, and therefore in consequence its animal diversity, will decline irreversibly. So one of the approaches to address this problem is integrated water resource management. This is an indicator of the Sustainable Development Goals, and essentially it connects with every other target within SDG 6, but also beyond, for example, SDG 15, life on land, SDG 13, climate, SDG 17, collective action for peace. It goes on and on. So, but what is it? So integrated water resource management essentially it starts with an understanding that water has a multitude of values and uses. It has economic value, it has value for human survival, but it also has value for the preservation of the ecosystems that are our life support system. And therefore, as a result, we need to break away from dealing with water as an isolated problem and dealing with it as an integrated issue, which brings in interventions in agriculture, in energy, across what we now call the water, energy, food ecosystems nexus, the WEFE nexus that we've talked about earlier. The difference between the WEFE approach and the IWRM, the Integrated Water Resource Management approach, is that IWRM puts water at the center of this approach, whereas the nexus essentially considers energy, water, food, and ecosystems to be 4 pillars that have to be addressed simultaneously. But apart from that, these are 2 very related approaches. And as you will see, the world is doing variably in meeting the objectives of integrated water resource management. And our region in particular is a mixed picture. The northern coast of the Mediterranean seems to have a reasonably high level of achievement, with some problems in the Balkans And the southern rim of our region is perhaps doing a little less well. Of course, this relates also to the physical factors and the actual physical availability of water, but it also relates to policy decisions that are made. And so if we break down the region, again, we see a lot of variability in different countries in the region. And of course, sometimes the failure to take an integrated water resource management approach is linked to other parts of this quadruple crisis that we're facing. A country in conflict, for example, or a country struggling to meet the needs of its people may not have the resources needed to try and manage their waters in an effective, transboundary and sustainable way. At the Global Water Partnership, essentially what we do is we work with countries to try and help them, first of all, monitor their progress towards SDG 6, and in particular towards integrated water resource management. We help them then develop action plans, and then we help them to find financing for those action plans in countries where the resources might be lacking. So we're currently supporting 88 countries in this process. And the countries that have been through that support process are 3 times more likely to be on target to achieve SDG 6 by 2030. These are some of the countries that have been supported in this process. As you can see, a couple in the Mediterranean, Tunisia and Morocco, and Lebanon, actually, and Lebanon being actually the only country in the EMME region. So we need to do much more work here. We need to do our homework in that respect. So, as I mentioned before, a close cousin of integrated water resource management is the water, energy, food ecosystems nexus approach. And yesterday I was honored to be invited by Professor Comer to attend the launch of the WEF-FRMED Community of Practice. The WEF-FRMED Community of Practice brings together the Global Water Partnership and the Cyprus Institute and many other partners in an attempt to bring together all the people around the Mediterranean, not just the EMME, but the whole Mediterranean, who are trying to find solutions which are win-win scenarios in terms of carbon emissions, in terms of water footprint, in terms of supporting our basic needs for agriculture, and the natural environment. Because the ecosystem, the natural environment, is always an afterthought until it starts collapsing and we start suffering the consequences of that. And so essentially, the WEF-FRMED project is created a community of practice which brings together not just the technical people, but also the policymakers, because working on water and putting water at the center of development requires policy change. It requires breaking the silos between ministries, between departments, between countries as well. And so this is an essential part of the work towards achieving SDG 6. And in consequence, preserving our terrestrial and other ecosystems. And essentially, at the end of the day, it links to what we would call a water and carbon technical solutions agenda. So the idea is that you are establishing win-win scenarios where you can actually reduce emissions in a process that is also improving the access to water for all those who need it, including the natural environment. And there we have especially our Mediterranean branch, GWP Med, which is our Mediterranean region based in Greece, have had interventions in Cyprus, in Greece, in Italy, in Kosovo, Malta, Montenegro, Tunisia, Jordan, and Palestine. And a very good example of this is the Matchmaker 2 project, because it contains all the components needed to address the triple or quadruple planetary crisis. First of all, there is the idea of transferring water to where it's needed. Secondly, there is the idea of creating artificial wetlands, which are not just to provide, they will provide obviously a supply for agriculture, but they will also improve the biodiversity by allowing, for example, migratory birds, freshwater aquatic plant and animal species to have an additional environment where they can thrive. The use of solar energy on the energy side of the nexus, and of course the societal benefits, which ultimately will bring about better social cohesion. female farmers being involved and creating their own businesses, creating jobs in communities which otherwise might be tempted to pack their bags and leave and move somewhere else because simply they can no longer survive. So we try through these interventions to address all the angles of the global crisis. To give you some numbers, for example, in a small project like this in Jordan, 21 cubic meters per day of treated wastewater, which addresses also the pollution problem of the pollution angle of the planetary crisis, 45 cubic meters per day in Palestine, reduction of emissions of CO2. So again, trying to bring about the carbon and water footprint benefits that ultimately will benefit not only the human communities, but the terrestrial ecosystems around them. I deliberately did not mention the ocean biodiversity because I know that this is covered in a different presentation, so I'm going to stop here, and I hope I didn't take too much time.
Thank you very much, Dr. Jarreau. Our next speaker is Professor Ioannis Karagatsis. Professor Karagatsis is the director of Marine Ecology Lab in the Department of Biology, University of Crete in Greece. He has been involved in more than 40 national and international research projects relevant to aquaculture and environment interactions, and is a member of various groups, including the Bethany Indicators group of the IOC UNESCO, GSAMP on offshore aquaculture, etc. His presentation will deal with the Mediterranean marine biodiversity, threats and actions needed, and will involve discussion on climate crisis, invasive species, and other sources of disturbance. Dr. Karagatsis, thank you.
Sorry.
Thank you, Mr. Chairman, and thanks to the organizers for the invitation. I will start from where the previous speaker finished. So the idea is about the marine biodiversity. I would like to attract your interest in something which is not only related to climatic change, but also is of global importance. So the problem of water is one of the major things which comes to our mind when we discuss about climatic change. And of course, we know that water resources are already under overexploitation while human population increases exponentially. And we know that in 2050, the human population will reach probably 20% more than today. Now, you know that something like 80% of water resources go to freshwater resources, go to food production. And perhaps you should know that we need in water something like 50 liters for one apple, 140 liters for a cup of coffee, and so on, so on, so on. And in the end, we need something like 15 tons of water for 1 kilogram of beef. So in the future, perhaps it will be considered immoral to use this type of energy. So the question is, can we go on like that? Perhaps the main source of animal protein in the future will be from the sea, because it is the only ecosystem which does not depend on freshwater supply. However, global fisheries production is stagnant or decreasing during the past 20 years, despite the fact that we have in there the meal of the carnivores that we have not exterminated, but driven out of competition. We have 2% of the sharks in the Mediterranean today that we had 1 century ago. So we have this stagnant thing is not real. Now, a good example, it's not from the Mediterranean, but it's interesting. It's the geographic expansion which changes with time. Spanish fisheries in the 50s was like that. It was reasonable. Half a century later, it was like that. So the mirror image would be the Japanese fleet. So we expand fishing fields anywhere on Earth. Now, if we see different types of food production systems, like for instance, agriculture has changed a bit in the last half a century. Livestock stayed almost the same. Fisheries seems increasing, but it's not real. And aquaculture was the only part that of production system that increased by 2 orders of magnitude, which means 100 times. But we should not be very pleased because with fish farming again, we don't stop at vegetables or herbivore animals, but go to the 5th trophic level. So we eat what would eat a lion. This is not really sustainable on the long term. Now, is the medium we use for this production system healthy? The problem is there are doubts about that. So if you see the up right corner, you can see the number of harmful algal blooms in 30 years between 70 and 95 or something. So it seems that has been a tremendous increase, and this is related to climatic crisis as well, because we have been able to destabilize the carbon cycle. It took us something like 2 centuries to do that, but with the nitrogen cycle, we did it much faster. We have the know-how now as humans. And as a result, in some cases, you can see all these dots in the other image showing that dead zones, areas without oxygen. And you can see some of them also in the Mediterranean, despite the fact that the Mediterranean is one of the most oligotrophic parts of the world. Now, we all know that the terrestrial ecosystem is exploited, is owned, is fragmented, and we have the impression that, for instance, the sea is the last part which is unaffected by human activity. Now, and the most interesting part, the most fragile part, and the most productive part of the marine environment is the coastal environment. So let's have a look at this coastal environment between Britain and Ireland and see what happens there. So land use, tourism, oil and gas, mariculture, coastal defense, parts of navigation, military activities, culture, conservation, dredging and disposal, submarine cables, fishing, renewable energy, marine recreation, and mineral extraction. So this very important ecosystem is under threat now, not in the future, not in the after 1 century. It is now a big problem. And all these are legitimate societal needs, but it's also a problem for the future. Now, if this is the case, most of us would expect that marine biodiversity decreases. Well, it's not really the case. For instance, unlike what happens to the terrestrial environment, where the humans have been responsible for many losses of important species, in the sea, it doesn't work like that. I mean, you have seen that in the past 600 million years, there has been a great increase in the number of families and, of course, of species as well. Now, but what you can see is that from time to time, there are sudden changes, which means that there are massive extinctions. So in a certain period of time, in this case, 1 million years, we lose 50% or 30% or 60% of the animals. And this means that we have a very, very big change in the ecosystem services provided by diversity. So our fear is that this part here, we are perhaps at the edge of a new massive extinction, which might be caused not by anything else, but by humans. Now, our neighborhood. Mediterranean is a very interesting environment. It has a high temperature, and you can see on the top right, at the same moment, it has been a very, very big change between North Sea and the Mediterranean, for instance. We never have less than 13 degrees, even during the winter and so on. It has a macrotidal regime, it has an ultra-oligotrophic waters. It means poor in terms of primary production, of nutrients, and so on. It has high transparency. It has phosphorus limitation of primary production, unlike most other marine environments, which are usually nitrogen limited. High biodiversity and low biomass. And this is because of the way that there is an exchange of water masses through Gibraltar Strait. We have poor in nutrients water coming in from the surface, and we have dense, rich in nutrients water coming out. This means that no matter how hard we have tried to pollute the Mediterranean, there is a physical resistance to that by its oceanographic processes. And the dynamic past of the Mediterranean is also interesting because in the old times, 120 million years ago, it was part of a global ocean. Then, 10 million years ago, there was a closure from the Indo-Pacific. And then, 6 million years ago, there was a disconnection of through the Gibraltar Strait, and the Mediterranean became a desert, became a series of small, bitter lakes without, which actually has driven the extinction most of the ancient biodiversity in the Mediterranean. After Gibraltar Strait opened again, the Mediterranean was colonized by species from the Atlantic. Now, one would expect that if this is the case, the Mediterranean would be a subset of what can be found in the Atlantic. It's not the case. So if you get numbers of samples and see the cumulative number of species at the same depth in different areas, you can see that Baltic and Black Sea are disturbed ecosystems are quite low. Then the Atlantics, then Australia and Mediterranean and Mexico, Gulf of Mexico are the highest level. So something has been happened there, and despite the fact that Mediterranean is a very warm sea, as said earlier. And if we put together the estimation for the number of species in infinite number of samples, you will see the Mediterranean is first among the ones I showed you. Now, the bad news, Mediterranean now is full of marine traffic, and with that we have invasive species. The Mediterranean today gets more invasive species than all the other seas in the world, and more than all other European regional seas together. Why? Because of the Suez Canal has established a contact between two biogeographic provinces that have evolved separately for 10 million years. Now, there is also suspicion that climatic change has favored expansion of tropical species towards the north. But this needs to be verified because it's, I think. Now, there are concerns whether the ports could become incubators, hotspots, or stepping stones for alien species. They fulfill all the prerequisites for that. They are stressed ecosystems, and they are along the route of the main vectors of non-invasive species. This is a thesis which is not published yet, shows that more than 3,000 species are on the other side of the Suez Canal that have at least one confamiliar species, one species of the same family, that has successfully invaded the Mediterranean. So, to conclude, climatic change only. It is important, but not the only issue. Even if we had today zero emissions, the global system would need centuries to recover. But we need a healthy marine system now. Therefore, we should take action for these other issues as well and urgently. The problem is the tragedy of timescales. Biodiversity is structured over the evolutionary timescale, which is millions of years, at least more than 1,000 years. The ecological timescale, conventionally considered less than 1,000 years, can modify ecosystem properties. The politicians, though, act at the political timescale, which is usually less than 4 years. The business people are interested in the economic timescale, which is approximately 12 months. So we expect people with power to address issues at scales that seem irrelevant to their mandate and interests. Exceptions? Yes. There have been some ideas like common fisheries policy, for instance, which there was a persistence, actually, of European Union to take measures for the preservation of marine stocks. And it seems now that something like 80% of the fish stocks in the Atlantic are at the so-called maximum sustainable yield, which is what we would wish. Action addressing climatic change, but not necessarily unnecessary disruption and destruction of marine ecosystems. Reasonable human interventions. We will still build ports and we will do all types of things in the coastal zone, but we should set limits on all of them. Conservation of key selection species, which are more likely to extinct, and sensitive habitats, and conservation of a significant proportion of unaffected habitats, the so-called marine protected areas, which should have a considerable amount of the marine environment. Thank you.
Thank you, Professor Karagassis. As mentioned earlier, unfortunately, Professor Waine could not connect with us in this session. Any questions for our speakers before going to the break?
Thank you. My name is Mary, and we work a lot of we talk about the problems. We could talk about solution. And early they said about education, how to raise generation that think and have responsibility, how to solve the problem for climate changing, and they understand their responsibility for this climate. From my experience, I did a lot of programs as environment, activist. Like a lot of food we throw, I do it with compost, and I have a big garden. I have a lot of trees, and everybody is happy. Instead of throwing the water, we do recycle water and use it for the garden. Years ago, we don't have that much of water. We don't have the technology and all this. We used to have a well from the rain, and we collect water. So we had to think, not everybody could afford to buy water like now. How we let the people have the old methods to solve the problems? Because if you let them share to solving the problem, it's going to be less risk for everyone. So how the big organization, how the big company that make all the pollution and all the risk for, how we force them by law to help to solve the problems in this, in all the countries, not. And the share of, like in my country, we don't have that much of water. We are a poor country. We try to get everybody with limited sources and use, the recycle for different things. So we had to change the vision of the media, how to deal with like everybody tried to solve the problem in his vision, but we had to share all the peace holders and all the people to solve this. Yeah. How we could reach to this goal. Thank you.
Okay. Short answer, please.
Okay, very short answer. Education, what you mentioned at the beginning, is critical, but it's not the education of the children. They know perfectly well what needs to be done. It's the education of the adults. The great thing about what I presented about this community of practice for the water, energy, food nexus is that it aims to teach politicians, policymakers, decision makers about breaking out of their silos and working across the spectrum of water, energy, food, and ecosystems. I'll just stop there because I know we can continue at coffee because I know we're in a hurry to no coffee. Okay. So, yeah. So I think, yeah.
Okay. Thank you very much. Thank you, our speakers, and can proceed. Next questions in the break. One more question? Okay, all right. One more question, I think, was over there. Yeah.
Thank you. Thank you for your presentation. It's actually eye-opening. We're at EcoPeace, we're working also in the Red Sea, and we have seen lots of, damages to the ecosystem, and we're trying to work with, as you mentioned, on education, but also trying to change human behavior in the coastal area, banning plastic bags. But we would love to learn more, probably with you, what other measures can be done on different level on the social, economic, and policy making, so we can make our economical existence more sustainable and more healthy to the ecosystem. Thank you.
Well, it's not easy, but I think there are various things. I know that there was there have been some initiatives to use, for instance, aquaculture in the northern part of the Saudi Arabia coast, for instance. And this was because if you go further south, there's a problem with diseases because of the high temperature and so on. I don't think there is a general solution for everything. I know that FAO has tried to work with communities of different countries in different areas, has done this with GESAMP, group of, not GESAMP, sorry, GFCM in the Mediterranean, and also with a similar body in the Arabian Gulf and so on. And the idea is that we should respect the environment as a collective good and property. Occasionally there are good examples with that. For instance, trying to assess the carrying capacity of different aspects and so on. There is this type of initiative, and I think we should encourage it.
Thank you very much. I think now I want to also thank everybody and the panelists, and thank you very much.
Thank you, Professor Kournamas, Dr. Jarreau, and Professor Karakassis. We will continue with a short break of 15 minutes, and then we will have the keynote address by Professor Moniz, which will start in 15. Please be here on time, as he will be connecting from the United States. Thank you. We now welcome our distinguished speaker, Professor Ernest Moniz. Professor Moniz is co-chair and CEO of the Nuclear Threat Initiative and president and CEO of the Energy Futures Initiative. Professor of Physics at the Massachusetts Institute of Technology and former Secretary of Energy in the Obama administration. Professor Moniz is not a stranger to the region, and especially to Cyprus. He is one of the founding fathers of the Cyprus Institute, a founding trustee. He played a seminal role in the establishment of its Energy, Environment, and Water Research Center and its launching in partnership with the MIT. Professor Moniz, we are grateful that even though very important business prevented you from joining us here in presence, you have found the time in the middle of deliberations in New York to deliver this address live. Thank you.
Well, thank you very much. It's a pleasure to rejoin the Cyprus Institute community after some time away, even if I must do it remotely. But of course, in this post-COVID world, I think we are all getting more accustomed to this kind of arrangement. As was mentioned, this is the Climate Week in New York City with the United Nations, and I'm afraid there's a lot of activity of relevance to this discussion, in fact, going on in that context. So let me start out with the perspective of a Cyprus Institute elder. A nicer phrase was just used in terms of founding trustee, but I will say as an elder, regrettably, I can invoke that characterization, that description in many contexts. But here for the Cyprus Institute, let me just say that a bit of history, if you will permit, since I think many of you may not be familiar that the first discussions about the Cyprus Institute with Kostas Papanikolaou and other of his colleagues in Cyprus really started in 2001. And the idea was to try to generate a research and educational activity that would be data-driven, science and technology based, and addressing very important issues, in particular for the Eastern Mediterranean, MENA, Middle East, North Africa regions. I will say that this was a bold vision. The separation between visionary and crazy person is often it's a thin line, and often the judgment comes after the fact. If the initiative succeeds, it's visionary, and if it doesn't, well, it's the opposite. But I think this meeting itself is an example of how the vision has come true, how discussions cutting across the region, frankly, cutting across the globe, can really bring science and technology to bear on an issue, in this case, climate and the transition to address global warming and climate, critically important to this region. We all know the Eastern Mediterranean, the Middle East, North Africa are all in the hotspot category for climate change. And so bringing this conversation to bear on what in this region one can do, of course, in the global context, is exactly fulfilling the vision that I think was put forward by our Cypriot colleagues at the beginning of this century. Again, the context back then was as Cyprus was heading to membership in the European Union, and given its geographic location, to a large extent embedded in the MENA region, that this would be a wonderful opportunity for bridging the capabilities, the interests in the EU, in particular, with those of the Middle East, North Africa regions. And again, I'm hoping that this set of activities around energy and climate, which, as was said, has been central to the Cyprus Institute concept from the beginning, that again, these discussions will materially help bridge differences, which we all know are present in the region, but also advance progress in addressing the climate goals. As always, communication across communities, scientists, academicians, policymakers, civil society is critical. And I would also note that from the beginning, the idea of collaboration, in this case in particular, with the Cyprus Academy, is most welcome and frankly essential to accomplishing the mission. And furthermore, specifically, certainly the Regional Climate Initiative that I believe has been discussed at rather high levels in this meeting is exactly the kind of initiative that the Cyprus Institute should help advance in every way that it can. So again, I apologize for the little digression there, but I hope that history is of some interest. And certainly for me, it's like a quarter century of engagement in trying to advance this kind of dialogue. So let me turn a little bit to the clean energy climate agenda specifically, and offer some high-level observations that I think are of general importance in advancing us towards addressing climate change, hopefully and more effectively in the future than frankly we have over these last years, because the pace of addressing these questions, as you all know, needs to be picked up very considerably if we are to at least hopefully manage somewhat the impacts of climate change, and certainly manage those impacts as they are affecting this region, the Eastern Mediterranean MENA region, and certainly will continue to do into the future. So a few points, and then hopefully we can go to a discussion. The first point I'd like to make, and I hope this will be characteristic of the ongoing discussions regionally, is that the climate conversation, in my view, has evolved very dramatically in the last few years and in a very positive direction. This isn't the same thing as having solutions being implemented at sufficient scale, but I think the conversation has in particular broadened. Frankly, the impacts, especially the extreme weather impacts, and this region is no stranger to those impacts, has tended to focus the mind away from what I would call, frankly, ideological approaches to what will be solutions to the climate challenge, to an understanding that we need every solution that we can bring to bear on decarbonizing the energy economy, on addressing issues like water demands that are part and parcel of the climate change and the like. By that I mean that, for example, some of these will be and some of them will not be of direct relevance to your conversations, but I mentioned being here at Climate Week, and here in New York for Climate Week, just as was the case at COP28 in the Emirates last year. Nuclear power is now in the conversation. Large-scale carbon management, carbon capture, carbon dioxide removal of legacy emissions from the atmosphere, are now part of the conversation. As I think the realization has become broadly accepted that, again, we certainly need to continue in areas like developing and deploying renewable energy, for example, storage with renewables, but we are also going to need a lot more. Unfortunately, two elements of the discussion that I don't think have kept pace with the technological evolution of the discussion are, first of all, the nature of the transition itself. In other words, I think there's still a little bit too much discussion about the glorious end state that we all wish for, as opposed to the very hard work about how we get from here to there. How do we manage the transition, particularly in a way that emphasizes security and social equity to get us where we want to go in all of these dimensions. So the transition discussion, I think, really has to be the focus of useful discussions for meeting the climate challenge. Secondly, the policy discussion, certainly here in the United States, has not kept pace either with the technology discussion. In the United States, and it's not true everywhere, but in the United States, I would call our policy towards climate a policy of carrots and twigs. We have not yet evolved the twigs to be sticks, like, for example, significant carbon emissions pricing. But I think this will follow as the technology discussion has in fact broadened, I think, in the way that is much more helpful. As I said or implied already, and I would just repeat, I think that the climate discussion really needs to be viewed as one part of a simultaneous conversation around climate, energy security, and social equity, because if we do not address all of these, the headwinds in our societies will be very considerable for example, meeting our climate goals. I think in Europe, some years back, that was seen, for example, in France, in the reaction to the proposal to raise fuel taxes and the pushback from elements of society was a very good example of how we need to integrate these discussions to make progress. Another, I think, important perspective that needs to get more attention, in a certain sense, it's a return to the discussions that were held really in the 90s when the global imperative to meet climate challenges was really being realized. I think we've lost some perspective on the idea that different societies across the globe must and will evolve towards low carbon at very different paces. That development, economic development in those societies is critical, and that I think one-size-fits-all ideas will only impede our progress towards getting a global solution towards what is a global challenge. The third point I would make is that in the context of the evolved climate discussion, which again I think certainly on the technology side has been very positive, I think another realization that has reached at least near consensus level, very importantly, is that clean electrons are obviously central to the climate solution. In many ways, decarbonizing the electricity grid is the lead in terms of overall economy-wide decarbonization. But I believe the realization has also sunk home that clean electrons are necessary but not sufficient. We will also need clean molecules, fuels, for example, and I think we are lagging behind in that discussion in terms of affordable and scalable solutions. Now, within the electron discussion, there has been evolution, as I said, for example, realizing, I think, at a near consensus level, that relying solely on variable sources like wind and solar with batteries is, again, extremely important, but not sufficient. We also will need firm power, firm, clean power, and that part of the discussion needs to be accelerated. But even more so, as I said, the molecules discussion is lagging, I think, even further behind. In terms of molecules, there will be, as there is in many aspects of the climate solution space, there is a need for tailoring solutions to regional and national realities. We've already mentioned the economic realities for parts of the world, the developing world, but also just in terms of the characteristics that can be expanded on regionally will depend upon local circumstances very often. That doesn't mean that those regional solutions are not also reflecting global trends. And I would take as an example a very important way potentially of resolving the molecules challenge is in hydrogen. Hydrogen obviously has the potential of being low to no carbon. It has the potential of serving many, many end uses. It has the potential for doing so as a hydrogen molecule or embedded in other liquids, such as ammonia, for example. But again, those will be, and whether the hydrogen is produced by some mixture of from natural gas, from methane, or from water, those will all be tuned to local circumstances. But that's an example of being part of a global dialogue and yet tailoring solutions, I think, to regional realities. I think it's important in those discussions to remember that if you look at hydrogen and methane water and methane as the major sources of hydrogen potentially, we have to keep in mind that the energy requirements to dissociate a hydrogen atom from water, those energy requirements are considerably greater than the energy requirements to liberate hydrogen from methane. But in the latter case, one still has the carbon to worry about, whether it's through carbon capture and sequestration, through novel ways of producing hydrogen, such as high temperature pyrolysis leading to solid carbon, many pathways for innovation here. But I think we do have to keep, again, open the fact that there will be different pathways to making hydrogen. They will suit different circumstances in different places. And the question is, in general, are we going to be able to scale those affordably and create demand? I think it's true in Europe, it's true in the United States, that a lot of the, frankly, euphoria around hydrogen of a few years ago is now being questioned because of the gap in creating sufficient demand. But I think what we need is a steady, focused, ongoing innovation agenda so that all of these pathways to hydrogen can be examined and hopefully can be made through innovation affordable and scalable. We should not forget to innovate in other areas for liquid fuels, but certainly hydrogen is an example of something where applying science and technology, linking it up with good policy, has the chance for being a huge part of the clean energy transformation. Another point I would make more broadly is I think as we move forward, recognizing again that different parts of the world, different countries are at very, very different levels of economic development, of social development. Those are often linked, that we will need to continue what is the rapidly growing focus on financeability. As you know, there are a variety of estimates that the global transformation to clean energy will be something like a $2 to $3 trillion per year enterprise. That's a lot of money, especially in terms of the capital flows that are available to investment in all sectors of the economy. So to get there, there is no doubt that we will need very, very large private capital flows, certainly perhaps leveraged by public funding, but in the end, that level of resource will only come by addressing the risk-reward ratio that institutions across the world will need to free up huge amounts of private capital. In that context, of course, we've seen at COP28, we will see at COP29, and I think we will see at subsequent COPs, a very, very strong focus on this question of financeability. And I'd like to, in particular, highlight how at COP28, I thought a very important step was taken in the formation, so in Dubai, the formation of the Altera Fund, and specifically the subset, the $5 billion of that fund that were allocated to so-called catalytic capital. The catalytic capital is a nice way of saying that that particular fund would not necessarily be looking to get a smaller return on investment, but was willing to take a subsidiary position to some of the very, very large private sector equity funds in terms of getting large capital flows, especially to the developing world. So I think that as we go forward, I think this is a very important research area, an area for analysis. How can we develop more catalytic capital ideas that will make some degree of financial sense to get large capital flows into this sector? Clearly, a lot of the focus, and certainly at the Cyprus Institute, is on science and technology solutions, and that in the end is the bedrock of the kind of transformation we want. But I think we have to match that to technically informed analysis in areas like catalytic capital to manage the, at least for managing a transition to a large-scale clean energy economy. I would also mention, and I think this is part and parcel of the Cyprus Institute culture and mission for the last 2 decades, and that is building coalitions. Again, working across boundaries, working across countries, working across communities, working across disciplines, because if we do not build strong coalitions, in fact, if we don't stop what has been historically too often the breaking of coalitions, we will have a very, very hard time proceeding to the low carbon economy, again, at the pace and scale that we need to. So I think coalition building should be very, very much in the foreground. That includes bridging disciplines, as is happening at this meeting, but it also includes bridging across all kinds of divides. I might say, for example, we here at the Nonprofit Energy Futures Initiative recently had a workshop, a beta test of a boot camp to bring together the financial community and the policy community? Well, it reinforced our ingoing assumption that those communities have so little familiarity that they had a hard time talking to each other, at least initially, and could come together. I think, again, the Cyprus Institute, in a variety of ways, I don't necessarily mean in the financial policy bridge, but there are so many of these communication gaps that I think that has to be a major focus for going forward to encourage technically sound solutions across barriers that are unfortunately are very, very high in many parts of the enterprise that we need to change. So those are just some of my very broad comments in terms of what I think is the nature of the evolving discussion, the needs going forward for any kind of solution, and certainly, again, the importance of the mission of bringing forward scientifically and technically grounded research and analysis to inform all of the steps forward that will be so important. So thank you. Again, I apologize for not being able to be in person. Trust me, the weather I believe is much better there than it is here, but I certainly wish you well in the rest of the meeting. And certainly I'm happy to engage in any discussion if there is some to be had. Thank you.
Thank you very much, Professor Moniz. We will now take, Professor Moniz will now take a few short questions, so please.
Professor Moniz, thank you. On the matter of nuclear energy, as I understand it, we're in a climate emergency, but the construction of nuclear plants are 20, 30 or 40 years in the making, far more expensive and far more long-term, and still have a residual issue of waste disposal. So why do you consider nuclear power a component of the answer to climate change?
So, well, first of all, on the time scale, the 20, 30 years, that's one of the challenges that we need to meet. We need to get that down. It's not going to get down to a year, but I would say to the decadal time period. And the question is, how can we do that? And I'll come back to that, but first let me make a comment on the why. The why, in my view, is that clearly we have made, we collectively have made enormous progress globally in terms of advancing wind and solar. Batteries have helped with at least short-term storage. But the reality is those are variable sources, weather-dependent sources, and they are not, in my view, and I think it's developing into a consensus view, they are not adequate for putting together let's call it zero carbon, reliable grid. I'll give you an example of that from the United States. And I think I would encourage actually similar elementary studies to be done more globally. But we looked, as you know, as you probably know, in the United States, the lead region for wind in particular is Texas. Everything in Texas is supposed to be big, as you know. So Texas has enormous wind. It still is not the major part of the overall grid supply. Natural gas remains the largest source, and that's very important for the following reason. What we did is we looked at the dispatch of wind in Texas for a full year just pre-COVID. So it was a normal year, if you like. And what one found was not that surprising. 90 days, so a quarter of the year, there was no wind in Texas. So what happened was the natural gas system was ramped up with all of the carbon implications that has. If you have 90 days in a year with no wind, it won't surprise you just by random fluctuations, if you like, that there was also a period of 9 days in a row without wind in Texas. So the reality is we have to put a system together that is reliable 24/7, 365 days a year. And that calls for some very low carbon, firm power. The reality is we don't have that many options. That's where nuclear comes in as one option. Hydro, of course, in many parts of the world is and has been an important option for dispatchable power, although we are seeing now in many places, first of all, a resistance to any further large hydro growth, but also some disturbing dependence on the kinds of extreme weather that climate itself is driving. So there are some other options, maybe carbon capture and sequestration, but it hasn't really taken off. Maybe engineered geothermal with some of the new technologies will prove to be a large-scale, dispatchable, low-carbon source. But it's that context that nuclear power is going to be probably an essential mix in an overall zero-carbon reliable grid. I will just mention, and I'll focus on the United States, although this is not unique to the United States, although it's somewhat different from Europe at the moment. Today, in the United States, we have obviously the challenge of continuing to decarbonize the grid, but we also have today a huge challenge which has caught a lot of people by surprise of tremendous electricity load growth. That is being driven in the United States, at least mainly by data centers and AI. I'll give you an example. In Georgia, which is the state that has just completed, it's in that state where 2 new nuclear power plants were just brought online, the first 2 new plants in the United States in many decades. In that state, the utility had filed a plan with the regulators calling for 400 megawatts of load growth to 2030. 1 year later, they submitted an amendment. Oops, did we say 400 megawatts? We really meant 6.2 gigawatts. A factor of 16. That was because of data centers and the initial stages of electrification, new battery factories, EV plants, and the like. The point is, you're absolutely right. Nuclear power, other than the 2 plants that they just brought online, nuclear power is not going to answer the mail for meeting that load growth in anything less than 10 years for sure. So what's that going to mean? It's going to mean more gas. And we have to get to, again, very low to no carbon. That's the context. And I'll just end by saying that just last week, that all played out when Microsoft and Constellation Energy announced that after 5 years of shutdown, they were going to reopen 3 Mile Island Unit Number 1 nuclear power plant, 860 megawatts electric, with Microsoft providing a 20-year purchase power agreement for all the electrons that plant can produce and pay a price premium to get that commitment. So that's just trying to say those are the pressures that we are feeling that is leading to a very, very strong relook at nuclear and the idea that we need to go there. In fact, at Climate Week, just on Monday of this week, in addition, 14 large banks and financial institutions, Bank of America, Barclays, Goldman Sachs, and others, all put out a statement that they are ready to be open for business now to go back to financing nuclear plants. So if one can find other firm zero carbon sources, they're all on the table. But right now, there's a strong push towards relooking at nuclear. And finally, actually, I should mention, of course, at COP28 that I mentioned earlier in Dubai last year, there was a pledge or an aspiration expressed by 22 countries to triple nuclear power globally because it is viewed as an essential part of the climate solution. So, long answer, I apologize, but I think that's the context for looking at nuclear power, realizing that any significant impact will not be really felt for 10 years. But the answer to that is, if you don't start today, it'll be 20 years rather than 10.
This is Jos Lelyveld. You may remember helping our groups getting kick-started at the Cyprus Institute. You may also remember Richard Cooper, who always advocated carbon pricing. Carbon pricing is still on the table. Do you think we should implement this more strongly and create incentives?
Yes, well, first of all, it's a pleasure to sort of connect with you again. I can't quite see you here, but, and of course, Richard Cooper was a great friend to so many of us. We certainly miss him. But Richard, as you said, was certainly a very strong advocate going back many years for carbon pricing. That is exactly what I implicitly meant in saying we have to go, at least, again, I'll speak for the United States, we have to go from carrots and twigs to carrots and sticks, and I would call a significant carbon price part of that stick. Frankly, the approach of the United States, and it's an approach that is in common with many approaches in many other parts of the world, doing this through carrots, through tax incentives, through government grants, et cetera, is just very limited. It's our reality today. It is, what I call it, it's a transition to the transition. But we can never get through even the transition through carrots. So carbon pricing, I think, remains the most talked about, logical, simplest, at least in principle, approach. What I would just say is that I think what we will see happening, well, first of all, I think the tipping point for getting to some form of carbon pricing is going to be extreme weather. It's clear that we are all suffering, and certainly the MENA region is suffering greatly from extreme weather, and I think that will be the tipping point for many countries, including my own, to take more serious policy steps like carbon pricing. But I do think in many cases it will come as part of a package. So, for example, in the United States, George Shultz, who also passed away a couple of years ago, and Jim Baker, both former secretaries of state in Republican administrations in the United States, they advocated carbon pricing together with returning the funds to the public in a progressive way through a dividend, together with something that Europe has been leading in terms of trying to think through carbon border adjustments, and in turn having less dependence on the carrots such as financial incentives, but rather doing it through the pricing, the carbon border mechanism, and the dividend, which, as I said, is progressive. In the United States, to give you a number, the modeling suggests that if the funds from a carbon price were returned uniformly to the public, the lower 70%, 70% on the economic ladder would net profit, with the upper 30% obviously having the opposite impact. So I think that is part of the social equity equation that I also mentioned as essential, in my view, to serious climate solutions.
Thank you. We will now take one final question.
Dear Ernie, Petros Kareglas speaking.
Another friend.
We have liked to see you here in person, but anyway, see you on the screen. Right now,
Petros, isn't this meeting occurring in your home territory, roughly?
So our region is a boiling cauldron right now, Ernie.
Yeah. Yeah.
How do you see from far away from the United States the developments or repercussions regarding the climate crisis? Are we going back 20, 30 or more years? Thank you.
Well, I think, Petros, I think the comment I made around extreme weather pertains just as much here as it does in other parts of the world. That is, we've had certainly regionally, not across the entire country, but regionally, some extraordinarily hot weather. You may have seen that, for example, in Arizona, they broke records of 100-degree Fahrenheit plus weather for months at a time. Then we've had the opposite, so-called polar vortices with extremely cold weather going down as far as Texas. Many people died in that event a few years ago. We've had major floods in places you wouldn't guess. I don't know if you followed it, but Vermont, very mountainous state, was never thought of as a flood zone. They've had devastating floods, not to mention other parts of the country, the Midwest, et cetera. We have had very intense storms, which have taken some very strange pathways that we have never seen before. For example, a hurricane maybe a month ago hit New Orleans, and then rather than following its typical path of going to the northeast, went straight north, never before seen. Fires, of course, all over the country, literally some towns wiped out through forest fires. So we're having our share of these extreme weather events, and the polling now has shown in the United States a major shift towards the population, right or wrong. I won't get into the science here, but the fact is that now a large majority is recognizing extreme weather and is associating it with the warming climate. And I think it's not far behind that then translating into political action. So I think that, again, I'll speak for the United States, which is what your question was about. I think we are going to have a tipping point. I don't know whether it's going to be in 1 year or 10 years or somewhere in between, but I think we will have a tipping point driven by extreme weather that will lead to a direct or indirect carbon emissions pricing regime. And I think the big argument is going to come over the social equity aspects. That is, will the funds collected, and these are not trivial funds. I mean, imagine $100 a ton for 5 or 6 gigatons. That's not trivial. And the question will be, will that money be pocketed by the government to address budget deficits, which are another huge lurking problem? And a challenge for taking climate steps, or will it instead, for example, the example I mentioned earlier, go back to the people as a dividend to address especially the economically less well-off part of the population? I believe that's the argument that we'll pursue. If the former happens, that is, it goes directly to budget deficit reduction, I believe it'll be a social equity disaster. That's answer to your question. That's my prediction for the political quandary that we will be facing sometime relatively soon.
Thank you again, Professor Moniz.
Thank you all for listening, and appreciate it. And I will try to pick up that invitation to return to Cyprus sometime soon.
Thank you. We would love to have you here. Now, I would like to extend a warm thank you to all of you for joining us on this first day of the conference, and invite you to the Fellini Room, which is located in the mezzanine of the adjacent building, for the poster session and a wine and cheese reception, which will follow. Kind reminder that tomorrow, Friday, the program will start at 8:30 with an address from the Minister of Energy of the Republic of Cyprus, Mr. George Papanastasiou. Thank you.